Ladies and gentlemen, please welcome Regina Dugan.
For the next 45 minutes, you're going to get a glimpse of a small band of pirates trying to do epic shit. A small band of pirates in a very fast boat. Welcome to ATAP. Here, we don't tinker. We build new things, sometimes seemingly impossible things. We are optimized for speed. It is an essential characteristic of our work. Our small internal team is connected to hundreds of external teams. It's how we tackle hard problems at the intersection of high-end, push-to-the-edge hardware and software, at the intersection of tech and art, science and application, problems you can't solve by yourself. And it's how we do so without compromising the tech or the beauty or a sense of soul. We have protectors of all of these elements with us. There are 11 projects ongoing at present in ATAP and partners all around them. This is the global web of our partners. We believe this yields better solutions and faster. In the last 2 years, we have worked with 305 partners in 22 countries on 3 continents: universities, startups, large system integrators, governments, and nonprofits. The answer is out there somewhere if we are just humble enough to find it. This approach also lets us do large-scale research and ship, both. We dare to dream and do. ATAP is full of doer-dreamers like many of you. And our goal is to close the gap between what if and what is. We're going to talk a lot of tech this morning. We'll talk about 3 out of the 11 projects currently ongoing in ATAP. 3 projects in 45 minutes. They are proof points. Johnny Lee, Paul Aramenko, and Rashid El-Garab lead these projects. They are ATAP technical project leads. They come for 2 years. No one comes to build a career in ATAP. You come to build something, to do your best work. We're going to start off with Johnny, interface technology expert, core contributor to Connect, a top-rated TED Talk using Wiimotes, now Project Tango lead, trying to make the future awesome, and a tablet that sees in 3D. Paul will be up next. Evangelist for the power of open, complexity geek, drone designer, rocket scientist, and occasional pilot, MIT, Caltech, Georgetown, currently head of Project ARA. And a guest appearance from Glenn Keane, animator, storyteller, and champion of the hand-drawn line, Disney legend, creator of beloved characters from Ariel to Aladdin, and now ATAP upcoming spotlight story, Duet. Johnny, the floor is yours.
Wow, all right. Wow, thanks for that warm welcome. It's a pleasure to be here, and I'm really excited to be able to talk to you guys about Project Tango. So Project Tango is an effort that we've been pushing on to try to give devices a human-scale understanding of space and motion. Each of us do something remarkable every day. You sitting in your seat roughly understand the size of this room, as well as the position and orientation of the person sitting next to you, as well as yourself. And this sense of spatial awareness is remarkable, yet we take it for granted every day because it's our human perception system that does this just for free. But our phones, our tablets, and our laptops have no understanding of this spatial relationship, yet it's so fundamental to the way we interact with each other, as well as the way we interact with things. So what if you had this in a device? What could you do? Well, imagine if the directions to your destination didn't stop just at the front door, but could actually take you to the exact room that you wanted to get to, or could allow the visually impaired navigate spaces that they've never been in before. You could play games in your house where you use the furniture as castles, or you play hide and seek with game characters who actually know where your closet is and can go hide there. You could also enable emerging applications such as robotics, such as allowing free-flying robots to navigate through the space station, which is, we have one of our Project Tango devices going up in August into the ISS. Now, the reason we think we can do this now is because if you look at the amount of computing power available on mobile processors, it has grown exponentially, as was everything else. This is a very common Moore's Law chart I'm sure you're familiar with some example mobile processors. And today we have processors like the Tegra K1 with a tremendous amount of computing power. But what's really interesting is if you plot another device on this chart, which is the vehicle that won the 2005 DARPA Grand Challenge. So the modern processors we have that we can buy today actually exceed the amount of compute necessary to drive 132 miles autonomously through the Mojave Desert. So the compute is here. The compute is genuinely here to do amazing things with our devices. What's missing is the hardware and software. So Project Tango is a focused effort to work with the hardware and software ecosystem to advance the state of 3D sensing on mobile hardware. As Regina mentioned, the way ATAP operates, we work with a very large network of partners. We work with device manufacturing, engineering support, processor vendors, IMU, gyro and accelerometer vendors, lenses, camera sensors, depth sensors, optics, partners within Google, computer vision companies, and universities, all spanning 9 countries around the world. So let me give you a quick tour of our hardware journey up to where we've been to today. So we've actually built 4 platforms over the past 18 months. Each of these were built to answer a very specific question, and I'll just walk through them quickly. First, we built a USB peripheral with commodity parts, commodity cameras, commodity sensors, and this was to ask, can we actually run these decades of robotics and computer vision algorithms on consumer-grade hardware? And the answer was yes, we can. The second prototype was a tablet we built in 3 months, and the question was to ask, can we actually run all these algorithms on a mobile processor? And the answer was also yes. The phone prototype we talked about earlier this year was our effort to reduce the size of the lenses and the cameras to respect the form factor requirements to fit in a modern phone or tablet, which is things like the 6mm Z height for the sensors. And indeed, these devices also did work. Now we have the culmination of the work of everyone within our network over the past 18 months to bring us to this. This is our current prototype, our dev kit that we will be making available next year. And we built this device from the ground up to do 3D and from the ground up for compute. It has our high-performance 4-megapixel, 2-micron camera. This is a very high-speed, light-sensitive sensor. We have our customized motion tracking camera that allows the device to understand its motion in 3D space. We've also worked with hardware vendors to force the improvements of the performance of these devices to fit into a device to do 3D sensing that gives us geometry about the floor and the walls. And then we found one partner that was interested in building this device with us to put in the most powerful processor that we could find and pack it with as much RAM and storage as a laptop. So this is designed for developers to explore 3D compute. A little peek into the software side now. On the left side, you'll see the fisheye image. If you think about human vision, we have this amazing peripheral vision. We are able to see far out to the sides, but we also have this area in the center that we have detail, our foveated region. And what these 2 cameras do is give us something analogous to human vision, where we have a wide fisheye camera and a more traditional field of view camera as well. You'll also notice in the bottom left that there's these little white dots. This is actually carefully time-stamped gyro and accelerometer data. The motion sensors in a phone is very much similar to the motion sensors you have in your inner ear. So this allows us to have both the eyes and the motion sensing capabilities of human perception. A little bit about the depth sensor. At a very simplistic level, it's a sensor that sees shape instead of color. On the left, you'll see a more traditional image taken with a camera. You can see all the color and shading and lighting of the scene. But on the right, you'll actually see this is what the depth sensor sees. It just gives us information about the contours and the shape of all the furniture, regardless of the color and, to some degree, independence of the lighting conditions. When we combine all the tracking data and the sensing data together, we end up being able to fuse it into a single estimate of both the device's position and the environment. This is a video of Joel Hesh, who's one of the computer vision engineers on the team. You'll see on the left side, this is the raw data coming into the system, the camera, the motion sensors in the bottom, and what we compute is what's on the right, which is the trajectory of the device in real time. So what he's doing is he's walking around the first floor of this 40,000 square foot building, and you can actually see in real time it's estimating his position throughout that space. Now, because we just use the cameras and the motion sensors, this is a full 3D trajectory. It is not restricted to a single plane. Thanks. And you can actually see the sort of coil as it goes up the stairwell. Now remember, there's no GPS, there's no Wi-Fi, there's no Bluetooth. This is just using the cameras and the motion sensors. The only requirement that we have in the environment is we have light, which is similar to the amount of requirement that you have to walk through the space. What he's doing here is he's now walked up 5 flights of stairs, across this entire building, down 5 flights of stairs, back to his original location. And this is a very simple test for us to sort of understand how well we're doing. And it turns out that we have about 1% of drift over path length driven. Thanks. Now, when we combine the tracking information with the depth sensor, we actually are now able to capture geometry of the environment. This is Yvonne, one of the interns on the project. This is a false color image where red is low and blue is high. But you can see that it's capturing the floor, the walls, and the stairs as we walk up. In just a second, it's going to show you this top-down view, which you can actually see that even after 5 flights of travel, we can still see down the middle of the stairwell. Again, the accuracy and alignment of the data is on the order of 1%. So you've probably seen scans like this with $10,000 or $100,000 laser scanners on industrial scanning, but what's new is the push to make this happen on a consumer scale device. Now, scanning stairwells isn't something most people need to do. It's actually a nice test structure because it has X, Y, and Z variation, so we can see our accuracy along every dimension. But you can imagine once we get this into the hands of consumers, they can do things like capture the geometry of their house. So this is me walking around with one of the prototypes, walking around my house. Again, red is the floor and blue is the walls. But this is me walking around my living room, a laundry room, guest bathroom, and other bedroom. I'm basically walking around my house as quickly as I would naturally walk. I don't have to move particularly slowly. I just sort of point it as though I'm giving someone else a tour of my house. In a second, it's going to show you a zoom in of one of the rooms. You can see that the real-time structure is relatively coarse, but this is already enough geometry for game developers if someone wanted to make a game where soldiers had to like attack your bathtub. If you wanted to. But if you actually capture the data and store it, you can do much better. So this is a partner called Matterport, where we gave one of our devices. And if you store the data and do offline processing, the quality that you can produce from these devices is much higher. This is cool stuff, isn't it? Okay. All right, so we're going to switch to the tablet to show you some real demos, some real-time demos. Do we have our tablet? Hello? All right, great. So we have been having a little bit of HDMI trouble, so there will be some black screens, but we're supposed to recover from those. OK, so let me first show you the tracking. So this is our 7-inch prototype development kit, and you can see what's on the left side is basically the image from the camera. There you go. Stabilize, please. So we can see the fisheye lens. You can see the fisheye lens on the left, and also the hardware-accelerated tracking. Come on, guys. OK, I'll hold the cable. Come on. All right, maybe if I do it this way. All right, so if you see the camera lens on the left, wow, you can do it. All right, let's switch to the other device. Apologies. AV issues. Okay. So we have the camera on the left. All right. We are going to switch to that TV. That is our third backup. Well, I don't want to risk it jumping out, so apologize to you guys. Can we switch to that TV? Hello? Okay. And can we get the camera on the TV up to the screen? Otherwise, we'll just, don't want this to be, this is still this tablet. Okay, all right. So on the left side, you'll see the camera that actually has, yes, yay for AV. Thanks. On the left side, you see the fisheye lens, and you actually see these hardware-accelerated feature tracks. And this basically gives us the motion of the device. The gyro and accelerometer data are these little waveforms underneath. Now, if I turn the tablet left and right, you see the cone swapping back and forth. But what's different is that we're actually able to track the motion. So if I move left and right, it's actually tracking my position. And if I make a big circle, it actually is tracking me in real time. So if I wasn't tethered to this cable, I could actually just unplug, actually walk through the entire Moscone Center, and it would be tracking my position in full 6-degree freedom continuously. Now let me give you a quick example of some demos that we've built using this. These are all built inside of the Unity game engine. And this is an extremely simple puzzle game where if I move the yellow cube and put it on the yellow switch, it makes more blocks appear. But you can see that the blue cube and the blue switch are far separated. So I actually have to move forward to hit this switch. Okay. And because I actually can't reach this green switch, I'm actually going to have to throw it. Okay, yeah. Ah, I threw it too far. All right. There you go. Okay, yes! This is another tech demo that we built inside of the Unity game engine. And if you imagine once you have the geometry of your house and you want to create sort of fantasy lands in different rooms, you can use the device just to sort of control the camera as you look around. But you can see there's this wizard on the ground, but he's only about 6 inches tall. So if I want to get down to his level of the world, all I have to do is squat down. Okay? As if he's right in front of me. So I can look at the trees and the stones and then sort of interact with him directly. But if I want to interact with the main map, I just sort of stand back up and say, hey, go over there. And he'll sort of walk over in that direction. The other demo I want to show you is something that one of our university partners just got working very recently. And this combines both the depth sensing data and the tracking data together. So what's going on here is I'm actually building a 3D map of the stage in real time. Wow, here we go. Come on. We learn a lot of new things on this project. So I can sort of map up this wall, and it'll start to texture it and capture it as I walk around. So as the hardware and software both become better, this type of technology will become part of the tools that we want to provide, but it's not there today. We're currently working actively with both companies as well as universities to improve the software stack. So can we go back to the slides? So as I mentioned, we want to do this in collaboration with both the hardware and the software entities out there. We're excited to announce that we've started early engagement with LG to make a consumer-scale device next year. We have early integrations with both Unity and the Unreal Engine and Qualcomm Vuforia. So if you already know how to work with these tools, you can build a Project Tango-enabled app. I encourage you guys to go out to the sandbox area, try some of the demos. These are partners that have gotten early development units and started doing demos. And there's a lot more work to do. And if you want to sign up for DevKit, go to the website or go to the sandbox. There's a tremendous amount of new work to do when we start thinking about what happens when our devices have this sense of awareness. And I want to work with each of you because I genuinely think the future is awesome. Thank you.
Thanks, Johnny. Thanks, Johnny. Normally when demos fail for Johnny, he does a little jig on stage, so we miss that part of it. Project Tango is one of ATAP's most mature projects. Project ARA is in an earlier stage. Both capitalize on advances in mobile computing, miniaturization, optimization of electronics, and the opportunities that result at that intersection. They are both challenging what we believe to be possible in a mobile platform. Tango and ARA have accomplished in months what would normally take years. That's not an odd coincidence. It's the result of a core belief for us, namely that open wins over closed, and that speed is essential to innovation. To give you a sense of ATAP speed, let's take a look at the last 2 years. Now, ATAP was born on May 22nd, 2012. We are 2 years, 1 month, and 4 days old today. And in that time, 11 projects have been born, from acoustics to wearables. We've shipped multiple products to scale: Windy Day and Buggy Night, our first 2 spotlight stories, and Skip, an NFC authentication token among them. Soon, you'll be able to authenticate your Moto X with the next generation of NFC Auth, a digital tattoo that lasts for 5 days. We built an interdisciplinary team of 114, from statistical ethnographers to Oscar-winning directors. Our Skunkworks shop can build almost anything, and fast. We can build, cut, bend, and take things apart. On June 21st last year, we signed a multi-university research agreement with 8 of the country's top universities, from Caltech to MIT, Texas to Illinois, and then 8 turned into 16. It doesn't take us 9 to 12 months to contract with researchers anymore. It takes us less than 30 days. We've had 2 parent companies, 1 lockpicking class, several engagements, 2 weddings, and 6 baby pirates born. That's a fast boat. Paul is the technical lead for Project ARA, and if you want to see fast, watch Paul. Paul.
Thank you, Regina. As Regina mentioned, I am the technical project lead for Project ARA. What if we asked better questions of our phones? Like, what if a phone could see in the dark? Or what if a phone could test if water's clean? What if I could share the best parts of my phone? What if a phone could? We think that a phone should, and a modular phone platform might just make all of these things possible. There are lots of challenges, true, so much so that many have said it couldn't be done at all. But we decided to give it a shot, and in ATAP fashion, we started by turning statements like, "It's impossible," into numbers. What exactly does impossible mean? Now, the principal challenge to modularity is overhead. What we found is that Moore's Law, the miniaturization of electromechanical components, and a modern data protocol could get the modularity penalty at the system level down to about 25% across the board in PCB area, in device weight, and in overall power consumption. In exchange, users would have the flexibility to turn the phone into a solution to an old problem, or to turn their phone into a new possibility altogether, to turn their phone into a means of choosing. Why choose a phone for its camera when instead you could choose a camera for your phone? Why can't I slide in a module that's my key fob, then take it out, give it to a valet? Why not share the most expensive sensor or component among my friends, my family, or perhaps across a village? Think of ARA as a versatile computing platform, one where development of each element is paced by the limits of our collective imagination and the capabilities to build new amazing things. Think of it as an analog to the Android app ecosystem, just in hardware. So we assembled a team, a small technical team within ATAP, 20 partners, some 150 people across 3 continents. Universities, major chip makers, industrial designers, interaction engineers, many, many others. And the goal is to have the team iterate. Advances in one area inform another, a process of constant trade-offs and cooperative effort to close the design across the disciplines and across the teams. If we did it linearly, it would take us a decade. Instead,
let's boot it.
9 months into the project, we have our first functional form factor prototype. There is lots more to do, but we're off to a good start. This is ARA being born.
Oh.
Yeah! As you see, just a few short weeks ago, the phone was tethered to a laboratory bench. Since then, we have cut the umbilical, and we have exercised many of its features. So I invite you to see for yourself. This is the Spiral 1 prototype. We could switch to the shoulder cam. There you go. This is the Spiral 1 prototype. It uses FPGAs to implement a packet switch network on device using the industry-standard MIPI Unipro protocol. It also has a flexible power bus that allows any module to be a power source, a power sink, or a power storage device. And it supports, in limited fashion for now, the hot swapping of batteries and other modules. So shall we see if we can get it to boot today? Seth? This is Seth Newberg. He's our chief electrical engineer, and he's going to power it on. Here's what you should expect. About 10 seconds into the boot sequence, the power bus will initialize. The LED, there's an LED module on the back, which Seth will show you in a bit. It'll come on. About 30 seconds into the boot sequence, if all goes well, the display module should initialize, and the screen will do a quick flash. About 35 seconds into the boot sequence, the Linux kernel will boot, and the Android logo will appear on the screen. And hopefully, fingers crossed, at 60 seconds, the Android home screen will appear on the device. So, Seth, go ahead. There's the LED. Oh, flash. This is promising. All right. Just a little bit further, just a little bit further. Ooh. Well, we're most of the way there. Okay. So maybe we'll let Seth power cycle it and try again. I assume we can't recover from that particular screen without a power reboot. In the meantime, let's go back to slides. Patrick, you can relax for a second, and we'll call you back if we reestablish the home screen there. So let me talk about what's difficult about this, other than actually getting the phone to boot. There are many technical challenges that must be overcome, and I'm going to talk about just a few of them. I'd like to talk about antenna design, about the interconnects that go into making the device work, about a software architecture that supports modularity at the device level, and making it beautiful, the industrial design and the aesthetics of the device, which may actually be one of the hardest challenges of all. So cellular and Wi-Fi antennas in a user-configurable modular device pose a particularly unique challenge. Our approach has been to use computer-optimized conductive grid antennas developed by one of our partners, X5 Systems, and to leverage the endoskeleton frame's metallic structure as part of the antenna system. We're also experimenting with 3D printing the antenna using conductive inks as part of the module shells. Now, to reduce the modularity overhead, we decided on a contactless approach to the data interconnections between the modules and the endoskeleton. This allows us to save precious volume and PCB area, but capacitive or inductive data transmission mechanisms are lossy, and minimizing insertion loss across a range of frequencies is hard. Interestingly, the challenge is actually not at the high frequencies, but rather efficiently supporting the transmission of low bitrate data at the low power gears of the data protocol. How are we doing there, Seth? No luck yet. OK. The electropermanent magnets alleviate the need for mechanical connectors or latches in attaching the module to the endoskeleton frame. EPMs are magnets that are passive in both the off state and the on state, and take a short current pulse in order to switch between those two states. EPMs are a proven technology that's been used in industrial lift and crane applications, and they've been around for decades. For Project Ara, we had to miniaturize them by a factor of 1,000, from something that can lift a car to something that can hold the weight of a small kitten. The current prototype platform relies on custom kernel drivers for each module. This approach is neither scalable nor secure, given an open ecosystem of third-party developers as we envisage. The network stack, as I mentioned, employs the MIPI Unipro protocol. In future spirals of the platform, slated for later this year and early next calendar year, the Android kernel will utilize generic class drivers for Unipro, with user space components for any additional functionality or for non-class conforming devices. Yes, this is going to require changes to Android to make it modular and to support hardware hot plug. In this regard, Ara is a stress test to see what Android can do in applications that stretch beyond the traditional smartphone. Now, let's talk power for a second. Battery technology has been advancing rapidly, just not so much in smartphones. Today, the tech is here to make a battery with triple the energy density of a conventional cell phone battery. An example is the silicon lithium-ion layered technology. But the battery will have reduced cycle life. Modularity opens up new opportunities for innovation and getting it to market quickly. And the user can choose the technology based on their specific need or use case. So such a battery would more than make up for the increased power consumption of a modular architecture. But if you don't want a new battery, you can hot swap a regular battery module to essentially get any battery life that you want. Now, putting all of this together, we sought an industrial design that can be both modular and beautiful. It must overcome the connotations of boxiness and brick-like that people associate with modularity. And it also has to close from an electrical and functional perspectives. With our industrial design partner, New Deal Design, we strive for smooth, sleek-looking modules without traditional connectors, and a parceling scheme that celebrates rather than conceals the modularity of the device, as well as aesthetic customization to give users the expressive capability well beyond simply selecting the color of their phone. To that end, we're working with our partners to develop a new production 3D printer that operates at 50 times the speed of existing 3D printing technology. It will yield full 600 dpi color in hard, soft, and conductive materials. We're after strength and surface finish comparable to that of consumer-grade plastics. Except, of course, the color, shape, and texture can be entirely unique from user to user and from module shell to module shell. OK, enough about the challenges. Let me show you what is under the hood, what goes into an Ara module. So this is a close-up of a Wi-Fi module. It has spring pins for now in the Spiral 1 prototype in place of the contactless pads that I talked about. It has 2 electropermanent magnets to support the insertion of the module either in landscape or portrait orientation. There are a number of discrete components that you see up there for power management and for driving the electropermanent magnets. These will be replaced with an integrated PMIC, or power management integrated circuit. There is currently a rather large FPGA that serves as our Unipro network processor. It will be replaced with a Unipro Bridge ASIC in the next couple of months. And lastly, of course, depicted here is the Wi-Fi baseband processor and an antenna connector in the upper right-hand corner of the slide. In this first spiral, about 65 to 70% of the module is consumed by modular overhead. Things you wouldn't have in a regular smartphone, in other words. That leaves about 30 to 35% of the module for developer-unique functionality. By October, we expect to have our Spiral 2 platform and prototype built around custom ASICs for the Unipro network processing. This will bring the usable area for module developers to somewhere around 70 or 75% of the module area. And while doing exact silicon area estimates is kind of a challenge, in the long run, we expect that native adoption of Unipro across a wide range of peripherals will get the modularity overhead down to approximately 10 to 15% of each individual module's PCB area. In the meantime, however, we think that there are a lot of interesting things that can be done even on the current ARA platform. And so today, I'm pleased to announce the first in a series of prize challenges for ARA module developers. We will award $100,000 to the developer of a novel module aimed at daily use that enables something that you cannot currently do with a smartphone. We encourage teams, and the module must be working when it is submitted to us for judging. The first 2 runners-up will get all expense-paid trips to the next ARA developer event in the fall. We're making a set of developer hardware available to prize challenge participants along with the latest release of our Module Developers Kit, or MDK. Guys, this will be really hard, but we're going to do this together. We're making a supply chain for EPMs. We're developing the processes needed for shell fabrication. The Unipro ASICs are well on their way. Expect a prototype version of Android with modularity feature support sometime in the fall. And the MDK is already out. Download it, check it out. So if we were to ask better questions of our phone, maybe they would look something like this.
Oh, it just booted. No, I'm kidding. I'm kidding. If there's anything I've learned over time, it's that stories move us. In his book entitled The Golden Theme, Brian McDonald wrote about the universal truth of storytelling. He argues that there is one golden theme in stories, from westerns to science fiction, myths to fairy tales. That truth is all any story worth telling is getting at. And in this regard, he says he believes he has discovered the single underlying truth that links all stories. We are all the same. Spotlight Stories is about finding the age-old truth of storytelling in modern technology. On October 29th last year, Moto X users got a little gift, a red hat that danced across their screen. The red hat marked an entry to a portal to an interactive, immersive world, where a mouse named Pepe learned that coveting a red hat is dangerous business. And users started smiling at their phones in new ways. Windy Day was the first of ATAP Spotlight Stories, a new storytelling format made uniquely for mobile. It is at the intersection of hardware, software, and content, art, and technology. Today's smartphones have graphics processing capabilities equal to game consoles. So we asked, what could we do with all that power? This industry spends billions every year making the tasks of our lives more efficient. But what about the entire emotional landscape of our lives? If you want to do something that touches people emotionally, you go running to storytelling. Perhaps in the advances of mobile, we might find a new creative canvas for storytelling. So we asked the best to help us find out. Oscar-winning director Jan Pinkava, Oscar-winning producer Karen Dufalo, the artist who animated Woody in Toy Story, Doug Sweetland, character animator Mark Oftedal, art director and Caldecott Medal winner John Klassen. Animators, modelers, and sound experts from 8 different countries descended on ATAP. They joined our technical team, and they started to build. What together they delivered was a simple story, a narrative with a beginning, middle, and end, where your phone is not a small screen at all, but a window to a new world. Windy Day is a technical feat. It is rendered in real time at 60 frames per second. Indeed, it is the first ever real-time rendering implementation of Pixar's open graphics standard, OpenSubdiv, and simultaneously the first ever use on mobile. It required an intimate understanding of the graphics pipeline, from the GPU to the OS, through scheduling, all the way to the high-level rendering engine, and a rethinking of tessellation to fit to the hardware requirements of real time. And it required hardware engineers, those intimately familiar with GPUs and IMUs, because the IMU sensor data is what told us where you were looking in the story, so we'd know what to render. And if the phone was to feel like a window, invisible, the sensor fusion performance had to improve. So we implemented precision planetary landing algorithms to make the interaction fluid. We are building a story development kit that will enable new stories to be written. One day, we hope, you'll have a new type of film festival in your pocket. And our second story turned the forest of Windy Day into a buggy night. And we continued our conversation with artists. We have this new format. What would you do with it? And one of those conversations was with Glenn Keane. Glenn Keane is a legendary animator, a singularity on this planet. He was with Disney for 38 years. Glenn wanted to draw again, but with a graphite pencil. That meant that he was to become our rendering engine. Only he'd render on paper and in 2D. Now, Glenn is at once an amazing rendering engine, but he's very high latency. He just can't draw in real time on the screen. Glenn's art challenged the tech of Spotlight Stories in entirely new ways. And the Spotlight Stories studio became a place where animators and engineers sat side by side, where Glenn taught us to draw, and we taught him if then else. Now, he flipped a few things on us, too. He turned the rendering timing problem completely upside down. In CG, the time of the frame is chosen, and the rendering engine creates a perfectly tuned image. But because Glenn was our engine, all animation timing had to be cued off the image drawn. There's no interpolation between hand-drawn images. This required better than 16 millisecond timing accuracy. Every piece of the pipeline had to become high precision. It took 3 months to implement an entirely new timing architecture. Everything from the animation system to the camera had to behave in reverse order. And when it's wrong, it's wrong. Ghosting occurs, or characters miss their cues. We flipped a few problems on Glenn. Traditional animation is drawn at 24 frames per second. But on a mobile device, everything is waiting for frames at 60 frames per second. That meant that Glenn had to draw not in 24 frames per second, but in 60 frames per second. And he had to draw in the 3-point perspective at scale. Glenn's story duet contains 10,055 original drawings. And these are just the frames that are visible. Many more were not used. So we had to develop a filing system. This is Glenn's, and this is ours. And we had to recover occasionally from file corruption, compression became critically important. Glenn is able to create seamless transitions, like the transformation of characters as they grow. In fact, it's so seamless, you don't feel there's anything unnatural about it. No technique in CG will allow that to happen. No mathematical encoding will enable you to do such a transformation. That meant what was once a mathematical representation of the line now was a graphite stardust field. And each drawing had to be mapped exactly to the screen resolution so that it feels as if the line is drawn right in front of you. Pixelization destroys the life of the line. 10,055 drawings became 13.5 gigabytes of data. And we used an entire hierarchy of compression to fit that into 150 megabytes. The score attracted 2 Stradivarius violins and top musicians who came because the visual demanded music of equal beauty. Duet allowed state-of-the-art technology, software and hardware engineers to breathe new life into an art form almost lost to us. The art of hand-drawn animations, Glenn Keane's art.
I see myself as an artist first who animates. Fortunately for me, everything I've animated has always tested me to learn something new. And I do believe that those feelings come out in line. In embracing this new technology, I feel like I rediscovered a love for animation.
As a tech team, we had no idea how this would be executed, none whatsoever. Going from CG, how do we do that in a way that doesn't distort what Glenn is drawing? In CG, if something goes wrong, it's very easy to fix it up and go. In hand-drawn, there's no way, because that has to be redrawn by Glenn. To some extent, he's our rendering engine. He's the guy who's actually producing the frames. We're just putting them in a 3D space. Unlike traditional film, our hardware runs at 60 frames per second, not 24. We decided from the beginning that what you see on screen will be Glenn's drawings untouched.
I've spent 40 years thinking at 24 frames a second. How in the world can I actually animate at a whole different time rate?
And it was like, whoa, that's a lot of work. But then I started thinking, wait a second, this gives you 60 more possible images to describe an action with. Why wouldn't you want that? This whole experience has shown me that whether you're holding a pencil or you're programming on a keyboard, you are an artist. It's going to take both sides to really move this art form forward to what it can become.
With a traditional story, the director holds the camera, so you know he'll get it right. But in our medium, we never knew. You see somebody watching Duet and tearing up. That's a moment that you don't forget.
Ladies and gentlemen, Glenn Keane.
Thank you. Thank you. So I'm an animator, which is an actor with a pencil. So I think I better boot up my device here. Wait for it. There it goes. Okay. So like I said, I'm an actor with a pencil. And so whether I'm animating a mermaid, or the Beast, or Aladdin, or Tarzan, I live in the skin of the characters that I draw. In this case, it's a little baby girl, which is weird, I know. But I know what it feels like to hold a little baby like this in your arms. Just this last week, we had our new little granddaughter born, and I know that those soft little chubby arms with their little marshmallow hands, what that feels like. And when I draw, I see my drawing as a sort of, it's a way for me to connect to you. I see drawing as a kind of seismograph of the soul. The lines representing how I feel. And kind of like the eyes are the window to the soul. And this is little Mia from Duet with her little beauty mark and a belly button. Thank you. About a year ago, Regina invited me up to ATAP, and she handed me this mobile device and said, so what would you do with this? And I looked at it and said, well, the screen is a lot smaller. I'm used to a big movie screen where my animation can play up there. And then I noticed it wasn't a screen at all, but it was a window into an infinite virtual world where the viewer had the camera in their hands, and it was a seamless storytelling. It was like there was no cuts in it at all. It was like unbroken eye contact, a captivating conversation between the artist and the viewer. This is wonderful. I said, so Regina, what do you want me to do with this? And she said, I just want you to make something beautiful and emotional. Wow, this is music to the ears of any artist. So what's the catch? She said, well, there is no catch. I just want you to push yourself creatively. That will push us technologically. I like this, Regina. So a year later, here we are with Duet. And the thing I realized, as I think back on that year, working side by side with Rashid's team, is that whether you're an artist with a pencil, expressing yourself creatively, or you are programming on a keyboard, that kind of an artist, we stand on one another's shoulders to reach higher than any one of us could do alone. Later on this year, you'll see Duet in all of its virtual, interactive glory. But this morning, we're going to present it to you in a theatrical format. And I hope you like it. Here's Duet.
I asked myself what I'd like you to remember about ATAP. We're a small band of pirates trying to do epic shit. We're trying to close the gap between what if and what is, that we are mobile first, lean and agile, open, optimized for speed. Yes, all of those things. But what I'd like for you to remember in the end, most of all, is that ATAP is full of doer dreamers like you, who dare to believe, even when it means we might fail. It's terrifying and hard because it's authentic and human and scary to dare and dream and do. But it's the only thing that really matters. It's why I'm here, and I suspect it's why you're here. And I don't mean here at I.O., I mean here. It's why we're all here, to believe and dream and do. In this respect, I'm certain we are all the same. Thank you.
Okay, great. Good morning. All right. I want to spend a moment to help reintroduce the mobile web. At Google, we love the web. The web is in Google's DNA. Google as a company grew up with the internet along with everyone else. We want the web to be first class because there's a lot of intrinsic values about the web that we really care about. The web offers a frictionless experience. You can just tap a link and you're there, experiencing what that link led to. You don't have to pause and think about, make decisions. Do you trust it? Do you want to install it? You can just move into new experiences effortlessly. The web is also discoverable. It's all just built on top of URLs. A single URL has a lot of power because it represents its content. But I can do quite a lot with it. I can store it so that I can revisit it again, of course, but more powerful, of course, is sharing. Links are shared by all sorts of means, and with those links, a single app or document can link into the state or another section of any other. And that link is just a single tap away from absolutely everyone. The web is everywhere. Interoperability is this beautiful thing that's let the web flourish because it's a shared, open platform with multiple implementations. That's the platform. That platform is on every device. And that single link can be accessed by everyone. And yet, you might have heard some less than favorable views on the mobile web. Not everyone is convinced. But respectfully, we disagree. It's had its rough times. And we may have missed the boat a few times. But I want to share what we've done about it. The mobile web is very much alive. The reality is today, the web is multi-device, and the count of users accessing it on devices is growing. And more than just increasing the number of users, the web itself is turning to be more mobile. In just 8 months, the number of sites that are mobile optimized has risen from 47% to 60, 68 even. Things are improving fast, but the question is, why isn't this happening even faster? Why aren't all sites great on mobile? And what's holding back developers from delivering fantastic experiences on the web? So about a year ago, developers were asked what stops them from building with HTML5. And cited were items like performance, APIs, difficulty in building rich UIs, and immature frameworks. And we heard 3 key pain points come out of this: speed, integration, and polish. At Chrome, we take these challenges seriously, and we've been putting a deep investment into the mobile web and investments into addressing these specific pain points. So I want to share an update of what we've been doing in the past 6 months to make the web better. First thing that we can do is just make the platform faster. We want to improve the speed of the most common interaction, the tap. For a long time, there's been this 300 millisecond delay on all taps. The browser is waiting for a double tap to happen. We managed to remove this delay entirely, making a dramatic impact on the input latency that all users have. Since then, Firefox and Safari have done the same. Now we've focused on other input latency actions, like flinging the page, and made good improvements there as well. The JavaScript engine inside of Chrome, V8, has long been a leader in performance. Its speed on mobile is a large focus for the team, and we're happy to report strong gains in our execution speed, reduction in GC latency, and a lower memory footprint on mobile devices. It's our goal to get the browser out of the way so that you can have full use of the main thread. This is a look at the same frame of animation. The second one is taken 6 months later. We've been making core improvements to the rendering engine, Blink, inside of Chrome. These improvements have spanned across the entire architecture, from the compositor to style engine to layout to paint. You can see on the, we've moved this particular frame of animation from 18 milliseconds down to 10 milliseconds. Now, 8 milliseconds difference may not sound like a lot, but we've made this improvement so that all web content doesn't animate at a stuttery animation, but we can get 60 FPS. On the whole, we've improved the speed of animation 75% and scrolling 35%. All this faster than what we had in 2013. We're committed to helping you get 60 FPS on the mobile web. So speed was identified as a pain point, and we've delivered marked improvements in Chrome on mobile. Now that we're making the experience faster, we need to give you more control over the platform. So this means new APIs and features. One of the most fundamental features is Service Worker. You can think of it as a successor to App Cache, and it is, but it's more powerful than just that. It allows you to build offline-first experiences. Service Worker can manage resource fetching and caching on your behalf. And for users, it's a huge win, too, because they can get content faster, and they can finally have proper offline-first experiences delivered from the web. Service Worker also unlocks a number of high-value features. Push notifications is a great example. Time and again, we heard from you. You want proper push notifications on the web. So they're on the way, and they're being powered by Service Worker. Other capabilities like background sync and geofencing are also coming, sitting on top of this powerful primitive. The web platform has long been monetized, right? E-commerce kind of changed the way that retail is done. But in the shift to mobile, things got a little bit more difficult. Keyboards vanished, so input is a bit more difficult, right? Request autocomplete is a new standard. I'm going to show quickly what this looks like. Just kidding. Request autocomplete allows you to build off of the HTML5 standard autocomplete attribute. And you can dramatically improve the process of filling out a checkout flow and other forms. We've seen a great improvement on mobile where a user can come through a checkout flow far faster than dealing with their thumbs on text fields all day. Now, WebGL, of course, offers great hardware-accelerated 3D content on the web. And I want to show this demo to you because it's really nice. I'm going to come over here to my phone. You can Google this yourself. Just look up Samsung Racer WebGL. I'm going to click into it. And this experience was just built with WebGL and also web audio. So it loads up. There we go. And we have a nice 60 FPS experience of WebGL here on my phone on the web. I can stop and then pan around, too. The panning is done dynamically with the Web Audio API, so I really get into the experience. And you can see we're not missing frames. This is a full, slick 60 frames per second. All right. So while the browser needs extra features so that you can deliver these great experiences, we also want to help users get closer to your content. So you saw in yesterday's keynote the redesigned recents. So your web tabs move and merge along with recent apps. This allows you to move easily between contexts, whether it is web or app. So we heard you when you said you needed a more complete feature set, and we've been delivering on that. Now, no matter how web apps are built, appearances matter. The web deserves to look and feel gorgeous. In yesterday's keynote, you saw material design, a unified vision for visual, motion, and interaction design across different devices. Polymer has an implementation of this that you can use no matter what sort of device it is, laptop, tablet, or phone, whether your user is using a mouse, trackpad, or their finger. The web's got the same great looks. And we're bringing beauty back to the web with material design. I'm going to come over. We're going to take a look at one of the applications built with this powerful design promise. So this is an app, the quiz app, called Topeka. It's built with Polymer. So it's built with the next generation of the web. But beyond that, we've made sure to deliver a great experience. So I'm going to come down here, and as we move around, there's a lot of things happening. We have simultaneous animations and slick 60 FPS animation. I'll come back, and we'll go down to Profile. And as I tap in on the input selection, we can see a nice effect coming off. We can see a similar effect, too, when we come into Science and Nature. And as I'm selecting, what is the only bird that can fly backwards? Albatross? Pelican? I'm not sure. What is the answer? Hummingbird, yes. The nice thing here is that we have a paper ripple effect coming off from the placement of where I put my finger. Yes. Thank you. Thank you very much. All right. One last stop over in TV and movies. Select the actors who played James Bond. I know this one. That's good. Dalton, yes. Niven? All right. Yeah, that's good. Yeah, I think that's it, right? But we have this nice checkbox effect coming in on the web. Oh. All right. Well, that's great. I'll come back to my slides. 0 points. All right. All right. We're excited to have strong UI components and UX paradigms for you to build experiences with. Now, we know that implementing all the most awesomest features in the world doesn't matter if the platform is hard to write code for. So we've been investing in developer ergonomics and tooling to make it easier for you to build. Polymer is a framework for building the next generation of the web, and it builds on the power of web components. Now, we've been working on this for a few years, and the engineers who work on Polymer work in conjunction with those that work on the web platform. And this collaboration has worked out really well and has benefited everyone. It's great because the web platform gets to benefit from these great web developer-centric use cases. And meanwhile, we can make sure that the implementation of Polymer can stay on the fast path of performance. This here is a look at Polymer Designer. This is a drag-and-drop UI for constructing fast prototypes and other things. Not only can I drag and drop all these components together, but I can instantly dive into the code beneath them. Now, we care a lot about making sure that the ergonomics of building with Polymer is smooth. Using web components is just HTML. So take this Google Map element. Once I import it, I can use it very naturally just with attributes. Meanwhile, the element itself encapsulates and hides its implementation, so I can just reuse it easily. But as you're developing, you need tools to give you strong insight into the performance of your app and a great expectation of what it's going to look like to your mobile users. So we've been working hard to bring you a great mobile development and debugging experience with the Chrome developer tools, including rich device emulation features, powerful remote debugging, and rich instrumentation to understand how to improve performance. So whether you're working with Shadow DOM, ES6 promises, we want to make sure that the Chrome dev tools are behind you, helping you iterate quickly, and you can move fast, focus on delivering a great experience rather than focusing on the technology. Beyond the dev tools, there's 2 more sites that are critical in helping you deliver on the web. PageSpeed Insights will run your site against a battery of tests, helping you identify not only how to improve your page load time, but also UX concerns like sizing your tap targets to be appropriate size, and also improving text readability on small screens. This is Web Page Test. It recently added great mobile device support, which is an invaluable tool in helping you optimize for the critical path. So take something as fuzzy as slow page loading. Web Page Test helps you zero in on exactly what's holding you back. Here, we're looking at the film strip view. The film strip view is a great look at correlating the network waterfall along with the visual load of the page so you can identify what's blocking and how to make things faster. And so there's a lot going on in web development. We know that keeping up with all the best practices of web development is a full-time job. So, how do we address responsive design, responsive layout, images, navigation, hamburger menus, rich input, rich media? At Web Fundamentals, we've documented some of these answers into living guides. We're hopefully making the job of building for the modern web a little bit more sane. And taking the right first step is key. So we've shipped Web Starter Kit just last week. This is a boilerplate for building multi-device sites. It sets you on the right path with smart defaults. Some of the things inside Web Starter Kit, it has a complete set of styles and components and layouts, a style guide that's driven by components so you can help craft your visual identity with your designers, and tooling for build process and smart developer workflow ergonomics like device synchronization and live reload. So to recap, developers asked us for an even faster runtime, even better ergonomics and tools, and more beauty. We've had our heads down to make big strides, and we hope over these 2 days of I/O you've seen some of this. But we can't do it without you. The web is open. The web is a conversation, and it's a collaboration, and we need your help too. Actually, let me take a moment and tell you about a guy named Dominic. Dominic's just like a JavaScript developer, just like you and me. Dominic, a while ago, was taking a look at handling asynchronous operations. He ended up writing a blog post. This blog post, he was saying, there's a lot of people doing work inside JavaScript libraries, but he made the case for saying the way that we're handling asynchronous events should be standard. We should be able to have all these JavaScript libraries interop with each other. This blog post begat a test suite. The test suite begat 30 compatible, interoperable implementations, one of which ended up in the DOM spec. Soon enough, with Dominic's help, the promises has landed in ECMAScript, the language. So going from a blog post to landing a major feature that a number of web APIs are built on is a big feat. And not everyone is Dominic. I'm certainly not. So what can we do? First, we just want to hear from you. Anything that you can tell us on why it's difficult to build for mobile, what we can do for you, what features you need, what's slow, let us know. File bugs, be active on mailing lists. Just give us the feedback so that we can serve you well. Now, this also goes almost without saying, but build responsibly. It's our awesome opportunity to build these frictionless experiences on the web to all users, regardless of what screen they're looking at. The number one thing that you can do to make your site better for mobile users is just to make it faster. With DevTools, Polymer, and the other resources I've shared, you have a whole host of tools, not only to keep you on the fast path of performance, but to help diagnose and address when you fall off that. And for a lot of users, their first experience with your brand is your mobile website. So they'll tap on a link that was shared with them, maybe via Facebook or email to them, and they got it over IM, found on a pinboard, or maybe they just tapped on a search result. But they arrived via the mobile web. Now that once they're in, they might eventually find their way to a natively installed app, and that's fine, but they came through the mobile web, and it's your responsibility to deliver success on that place. So this morning, I shared with you how we're making Chrome faster, from input latency to JavaScript, to massive improvements in the core rendering speed. We've looked at powerful capabilities like service worker, push notifications, request autocomplete, and integrated web and app recents. We're making the web beautiful and enjoyable to touch, and we want to make sure that it's also a joy to build. So we've invested in Polymer, the DevTools, and other tools to keep you on the right path. We've done a lot of work, but we're just getting started. Chrome is committed to the mobile web. Chrome and Google are committed to improve the web for developers and for your users. We're not done yet, but you can get started today. Join us. Let's help deliver on the promise and the power of the mobile web. Thanks.
Developing Scalable Apps, developed with Google, is your guide to the most efficient way to build scalable applications on Google App Engine. Learn how to architect and build highly scalable, reliable apps by leveraging Google Cloud Platform. This class covers concepts like platform as a service, infrastructure as a service, data storage, caching, cloud endpoints, and more, to help you develop a highly scalable backend that works seamlessly with both web and native mobile apps. For more information, visit udacity.com/Google.
Hi there, my name's Ellis, and this is Making Polymer Elements Accessible. So you've gotten the web components bug and downloaded Polymer and you've made your first custom element. Fantastic. Today, I'm here to talk a bit about how we can make sure our brand new custom elements can be used by everyone. Right now, built-in HTML5 elements work well for accessibility. This didn't happen by accident. Browser developers followed published standards for ensuring the accessibility of these elements and add keyboard handling, styling, and semantic information to make sure that all users can use them. When we're creating new components for the web, ideally they should be using the same standards. They too should be accessible to all users. When we talk about all users, there are several broad classes of impairment that we consider. Visual impairment, which could range from poor color vision through low vision to no vision. Hearing issues, whether a user is deaf, hard of hearing, or simply can't use their device's audio output. Mobility or motor impairment, whether temporary or permanent, such as a broken arm, RSI, or long-term motor disorder. Other impairments, which encompass a very broad range of issues, including cognitive impairments like dyslexia, ADHD, brain injury, and other impairments like learning disorder, epilepsy, and vestibular disorder. The first thing we want to look at is whether our element can be used with the keyboard alone. This is a first step ensuring it can be used by users of assistive technology on all platforms, but also important for users with motor impairments or injuries, or any desktop users who can't or won't use a mouse right now. During your user experience design, think about how you would use your element with the keyboard alone and figure out a consistent set of keyboard interactions. To help with the design process, consider including physical impairments in your user experience personas. If you're creating an element which mimics an existing element in some way, consider copying the way it handles keyboard interaction to provide consistency. Try using a native element with the keyboard and find out what already works. Chances are you've been using the keyboard sometimes anyway, so you'll find it comes pretty naturally. Later we'll talk about ARIA, which allows you to specify additional semantics for your element. Once you've picked a semantic role, you can use the ARIA Design Patterns Guide to get some extra advice on what keyboard events to handle. The first step in actually implementing keyboard interactions is to make sure the element can take keyboard focus. Unless you can actually focus on the element, it's not going to get any keyboard events. Ensure you have a sensible focus target for your element. For a simple element like a button, this will obviously just be the element itself. A complex element like a menu may be one focus target within the page, but then manage focus within itself, so that the active menu item always takes focus. In this case, you want to make sure that the menu items are programmatically focusable, but not in the tab order itself. This is where an understanding of the nuances of the tab index attribute is going to come in handy. Tab index can take one of three classes of values. When tab index is 0, the element will be in the natural tab order, which is defined by the DOM order. This is what you would use to make a custom element, such as a custom button, keyboard focusable. When tab index is negative, the element will be programmatically focusable, but not in the tab order. This will be useful for something like the menu example on the previous slide. The menu container element can manage setting focus to each individual menu item when appropriate. The tab index is greater than 0, the element will be in a manual tab order. This makes no sense in the context of web components, since you essentially never know where your element will fall on the page. So now that you've spec'd out your keyboard interactions and made your element focusable, you need to implement the actual keyboard interactions. Luckily, there's an event handler for that. You can add an on-key down attribute to your Polymer element and add a method to handle the keyboard event, checking for any key press events you're interested in. Finally, make sure your keyboard interactions are discoverable, especially if they're not using one of the standard patterns. Tooltips or keyboard help overlays are common patterns for achieving this. Once our keyboard interactions are working, we're a good part of the way there already. Next, we need to take a look at whether our element can be used with assistive technology. The types of users who would use assistive technology range from users with visual impairments who might use screen readers or braille displays, to users with cognitive impairments, such as dyslexia, who might use a screen reader to augment their reading ability, and users with motor impairments who need to use technologies like voice control to interact with their devices. There are really only two parts to ensuring that your element can be used with assistive technology, including screen readers, once you've addressed keyboard accessibility. Adding semantic information, including the element's role, state, value, and name, and making sure that all information conveyed visually has a text alternative. First, let's talk about semantics. One of the great things about custom elements is that they make our markup look semantic again. We can hide presentation logic inside the shadow DOM and use meaningful element names to create a readable DOM. However, assistive technology doesn't see those semantics. It still sees, essentially, div soup, unless you tell it about the semantics you want your element to have. Assuming we're not extending built-in elements, the way we tell assistive technology about these additional semantics is using WAI ARIA, or ARIA for short. ARIA is a specification defining support for accessible rich web applications. It defines markup extensions implemented as attributes on elements, which can be used to provide additional information about the semantics of elements to assistive technologies like screen readers. This is what using ARIA looks like in vanilla HTML5. So we can use ARIA to add the semantic information we want to our custom elements. This is a custom slider element, which you can visually see has a minimum value of 1, a maximum value of 5, and a current value of 2.5. Until we add the relevant ARIA attributes, though, this element doesn't communicate any of this to assistive technology. We can add ARIA value attributes to tell assistive technology about the value of this element. Here we've added the attributes for role and current minimum and maximum values. Finally, once all your semantics are in place, make sure you always have text alternatives for any other information which is conveyed visually. For example, if your custom button uses a settings icon, make sure you give it a name of settings as well. And obviously, make sure all of your images have an alt attribute, even if you want them to be skipped by assistive technology. Assistive technology will try to come up with alternative text if you don't provide it, and often it'll pick the file name. So provide an empty alt attribute if you want the image to be visible to assistive technology. We also need to make sure that users with any form of color blindness can use our element. Firstly, this makes sure that we're not communicating anything with color alone. Color shouldn't be used as the only means of conveying information, such as indicating a status, prompting for a response, or distinguishing a visual custom element. Here we have the Chromium dashboard, which, as well as being a Polymer application, gives a status for each new web platform feature being developed or shipped in Chromium. Since the color dots next to the stakeholders are meant to convey information, the developers added a tooltip here, which appears when you hover over the name giving the same information. We also need to make sure that there's always sufficient contrast between text or icons and the background color. This is important for users with low vision who might have trouble reading low contrast text, colorblind users in the case where we're using two different colors next to each other, and any user using a mobile phone or device in bright sunlight. Any text content displayed in your element should at least meet the minimum contrast ratio of 4.5 to 1. You can audit your element for sufficient contrast using the Accessibility Developer Tools extension, which even provides suggested foreground and background color pairs if it finds low contrast text. Lastly, make sure any moving or flashing content is stoppable and safe. If you have any fancy slidey, parallaxy transitions, make sure you have a way to turn those off. They can be a real pain for people with vestibular disorder who may experience motion sickness symptoms while using them. And if you have any flashing content, please don't tell me you're re-implementing the blink tag. Make sure it meets the criteria for safe flashing content of having a flash frequency of 3 times per second or fewer. So let's recap and summarize everything into a handy list. Remember, every built-in HTML5 element will have all of these properties, at least in a mainstream browser, so we should make sure that custom elements do too. Make sure that your element can be used with a keyboard alone. Make sure that it works with assistive technology. Make sure that it doesn't rely on color to communicate important information. Make sure all text and icons have sufficient contrast ratio with the background. Make sure that it works without sound. I didn't cover this, but make sure any video or audio elements have the appropriate text alternatives, and make sure you aren't relying on audio cues to prompt for actions. And finally, make sure any moving or flashing content is configurable and safe. Please check out our article on the Polymer project website, which goes into more detail on much of what I've covered here, as well as providing links to many other useful resources. Remember, we're creating new components for the web. We have an amazing opportunity to make sure the web is accessible for everyone. Let's do this.
Hello, I'm Dan. I'm a games developer advocate here at Google.
And I'm Crispy, also developer advocate at Google, focused on games.
In this video, we will discuss the high-level aspects of building games for the big screen.
Not that big screen. TVs, more like this one. We're going to talk about what to avoid, what to strive towards, and how Google APIs can help support bringing your apps to the really big screen.
Much of what we are about to show you will apply in the broader context of the Android ecosystem surrounding games. In particular, when you consider how many Android devices are able to connect to large displays using Miracast, DisplayPort, docking hardware, as well as TVs with Android built in, you have at your disposal a full suite of technology that can put you in front of an engaged and growing audience. There are a lot of mobile gamers in the world, and they're looking to expand their gaming experience onto the biggest screen in their home. We hope that after watching this, you will be inspired to make sure your users get the best gaming experience on the big screen. Android TVs are going to be coming soon to a family room near you, and you better make sure your games look good on it.
With Android TV, you get to build on your existing mobile development experience. You can now take full advantage of modern Android, including NDK support, to craft your gaming worlds in unimaginable ways. It's even possible to extend the gaming experience through second screen interactions.
TV game development might seem to be overwhelming at first, considering how many different aspects are involved. In practice, though, it's not very different from what you are already doing with your mobile game development. Your projects can be managed in the same way. You just need to factor in a few additional considerations.
Let's start with my personal favorite, game controllers. Many mobile games use gestures whereby the user touches the sleek glass screen in front of them to interact with it. This works fine on a phone, but not so much for TV screens.
My arms certainly aren't long enough to reach across my living room.
Mine either. On TV, mobile on-screen controls become useless.
And even if my arms were long enough, touching most TVs would just result in a messy screen.
Yeah, not many people have touchscreen TVs, which is why you need to add touchscreen required equal false in your application manifest. It's implicit, which means you need to make the distinction.
Luckily, every Android TV will have a controller capable of producing directional pad input, thus allowing the user to interact with the TV.
Yep. The Android reference controller is definitely a developer's best friend. It has exactly what you would expect a game controller to have. 2 analog sticks, D-pad, B, A, X, Y buttons, left and right triggers, left and right bumpers, back button, home button.
It can also be paired with any Bluetooth-capable Android device, which means you can play controller-enabled games on your phone or tablet as well.
That's a very useful thing to do in general. I'm always a little surprised and saddened when I find a game that would be great to play with a paired controller, only to discover it doesn't accept the controller as valid input. Even worse, some of these games have on-screen simulated game controllers.
Yeah, it makes me sad too, because the developers have already done the work of mapping to the same kinds of input, but did not include the button mappings to the hardware.
With all the game controller support that exists with Android now, I don't feel there's an excuse for that.
Maybe they just don't know about it.
Fair point, but, you know, if you're watching this, you know about it.
And knowing is half the battle.
Yeah, there's a few other things to know too, though. For instance, Android KitKat now supports the enumeration of controllers, and the game controllers that support this will light up accordingly.
In your application, you make a call to get controller number to determine the controller driving the input event being dealt with. You can use this feature to make sure your little brother or sister is playing as player 2.
You can now tell Google Play that your game requires a game controller. This could be used to stand out in the Android TV Play Store.
You add the details to the application's manifest. This example indicates that your game must be used with a controller. You can also list all the supported types of controls for your game. If you require either a multi-touch touchscreen and gyro, or will work with the game controller, then you can use feature groups to define it in the manifest.
Now that you've added support in the manifest and in gameplay, you aren't finished yet. You need to think about how the players will make menu selections and provide non-gameplay input.
One of the hardest things that game developers have to deal with is focus and selection. Many games designed for touch just don't yet have that concept.
You know, one place to start would be to change the color of the selected text. This alone is not enough though. In this example, you really can't tell whether the start game or settings is currently selected.
This is a bit better.
It would be even better if it were animated. You know, use motion to convey context.
Done!
You know, a lot of games have buttons to connect to social services, etc. These buttons are often in non-obvious places for navigation.
So, this is easier to follow, right?
Yeah, but you're clearly not a UX designer.
Remember, hire a good designer. One of my favorite recent games did a great job with bringing their game to the TV and navigating menus, except that it was near impossible to actually purchase anything in the game without touching the screen.
It fell down when it came to purchases?
No one had tried buying anything with the controller. Google Play in-app payments supports D-pad navigation out of the box with a UI that looks great on TV. but you have to make sure the user can get there. Making your navigation clear and understandable is just as important outside of your main menu. Make sure that your TV players aren't missing out.
Okay. Let's shift gears now and discuss another essential item on the TV development checklist, networking.
So, you're probably thinking that you know about network detection on Android. However, many developers forget to consider the possibility of Ethernet network connectivity when building for TV.
Android TVs have wired Ethernet ports to allow fast networking. This means that Wi-Fi may be turned off, but it's still connected to the internet. Mobile developers have not had to worry much about fixed stationary devices. It's not been common for developers to build their network checking code to consider connectivity beyond cellular and Wi-Fi.
The good news is that it's really easy to test for network connectivity without caring about the type using this snippet of code. But if you really want to test whether wired networking is active, you can check to see if the active network is of type Ethernet. Understanding the active hardware allows your game to make good decisions about using bandwidth. Speaking of hardware, Android TVs have graphics hardware exposed to the power of OpenGL-ES. You can draw at the full resolution of your TV.
With many pixels comes fill rate responsibility. Use your pixel power wisely.
Right. It turns out that we're not quite ready to draw graphically intense 4K scenes with mobile GPUs. Yet. But there's an easy way to tell Android that you want to render at a lower resolution. If you're using Java, you can call surfaceholder.setFixedSize, and that will tell our compositing engine to scale your smaller window to the size of the screen.
And if you're like almost every game developer out there and not implementing your graphics in Java, you can change the size attribute of the target window.
Hey, you can still use GL Surface View with the native renderer. The context are shared. The key thing is you want to make sure your games look beautiful on a large screen. Many of the shortcuts taken in mobile look glaring on a large screen.
Low-res textures, low poly count models, geometry rounding errors, poor bit mappings. Look, you know what I'm talking about here.
Oh, amen, brother.
So with all this cool rendering, there's another thing you have to consider when developing for the TV screen.
Other than epic sizeness?
Well, overscan. It's something that still inexplicitly exists on modern TVs. Effectively, this means that some of your content may be pushed beyond the visible edge of the display.
So people should letterbox content and have borders?
No, just make sure you fill the screen, but keep the important information out of the outer 3% of the display.
Like what kind of important information?
HUDs, for example. It's kind of important for people to see those. It could become very annoying for the user to fiddle with their TV settings, trying to see the full UI of your game, only to discover that no matter what settings they play with, they still can't see the whole thing. Keep the edges of your game free of critical information.
Oh, I wish every developer knew about overscan and didn't have to know about overscan. Let's move on to what developers can do with Google Play Game Services.
Google Play Game Services have been optimized for Android TV with easy navigation and a great new look and feel.
You can also utilize achievements, leaderboards, quests, and more.
More being multiplayer support.
Yes, you can utilize turn-based multiplayer and real-time multiplayer from Play Services. There's even C++ support for turn-based multiplayer.
I want to see some awesome multiplayer experiences with people playing on their tablets in the same room so I can hear them groan. Second screen experiences in the living room are growing in number. Game saves can be a great tool for keeping your users engaged. Part of extending the mobile experiences to the TV means being able to continue playing on the biggest, baddest, most overscan prone screen in my house.
Cooperative multiplayer is also worthwhile. Play Games has a great API for peer-to-peer multiplayer with up to 8 players. It's so much cooler if some of them can be on TVs.
Everything's better on TV. You know, you can unlock the RTFM achievement.
Wait, what achievement was that?
Read the full manual. It's not exactly a manual, but rather a website. We're always trying to make it better.
And on that note, help us make TV games better. In this short talk, we covered a lot of ground, but there is always more to explore.
In summary, we looked at game controllers and the importance of navigation, focus, and selection. Networking and why it's not sufficient to just look for Wi-Fi. Graphics rendering on the TV and the challenges that overscan can present. And finally, Google Play Services and how it can help bring about the best gaming experiences for your users on TV.
More details about how to get your game ready for TV can be found on the new developer site for Android TV, including important manifest changes to work with our new lean-back experience. You can get in touch with us at +Dan Galpin and at DA Galpin.
And plus Kristen Uccello or at _Crispy_.
Now go build something fun, engaging, and big for us to play on TV.
Good morning. Welcome to this session on mobile web performance auditing. If you can see past the glare of lights on bald, you'll see that that's what I look like. You can find me on Google Plus as Paul Lewis and on Twitter as AeroTwist. Hey, Paul, would you mind doing a performance audit? This is what my colleagues would say. Or if they're feeling particularly urban that day, sup, Paul? The point here is that over time, people have asked me to figure out whether something is fast or not. And so I've built up, over time, a way of figuring that out. And that's what I wanted to share with you. So maybe you find yourself in this situation where people are asking you to do more performance work. And you're wondering how you should go about it. Welcome. This is what we're going to talk about. Good. So the first question is, why even bother? What's the point? Well, as you probably gathered from all the sessions that we've been doing, smartphones are on the rise, which isn't to say there's going to be a rebellion. I just mean that more people are using them. And one study reckons that just over a third of American adults using the smartphone as their primary means of internet access. As Paul Irish said in his session, that means that the first experience that somebody has of you and your brand is going to be on their phone. This trend isn't just America, it is actually further afield. This is the global internet traffic percentage for mobile is on the way up. It's just crossing the 30% mark Sometime in the middle of next year, if the trend line is to be believed, we will cross 50%. That will make it the majority. The thing about these devices, more people are using them, but they're performance constrained. If you have a performance problem on your desktop, when it hits the mobile device, it's going to be really painful. And if you're asking yourself whether this is a big deal, let's just cover the stats very quickly, a couple that are interesting. A 200 millisecond delay to Google results caused a 0.3% loss in engagement. This is a study that we did a few years ago. But if you like your stats a little bit more on the positive side, this is what Etsy had to say. Lara Swanson from Etsy, she said, when we eliminated jank, and we'll talk about that in a little bit, on Etsy's activity feed, we saw people favorite more often and favorite more things, which is a sort of meta indicator for conversions, really. So performance matters. Or as I like to say, hashtag perf matters, which you can track along with, or you can get the sticker. I've actually got stickers. Come and get a sticker. You can wear it like a badge, put it on your laptop, put it on somebody else's laptop as a passive-aggressive measure. Just, you know, don't want to call it out, but yeah. But the thing about mobile as well is that because the browser is the only thing that people have on the screen at that time, they have these really high expectations. In the way they also interact with it, with their touch, you feel the latency in a way you don't necessarily feel with a mouse. So you sort of, not only are these devices performance constrained, but people actually have higher expectations. Yay! And you might ask yourself the question, well, isn't it the browser's job to make things go faster? And the answer is, yeah, absolutely. And from a Chrome point of view, we have, and we are doing, and we will continue to make things faster. This is something that we take very, very seriously. However, there is a whole suite of things that we as developers get to control, and we get to decide for our sites and our apps. And so this is where the audit comes in, because it's really talking about the things that we get to control and how we can make sure that we're working with the browser rather than against it. So what then does the performance audit look like? Well, for me, it falls into two parts. The page load, how quickly did we get something on the screen? And then once it's on the screen, how well did it run? Were the scrolling, the animations, interactions, were those all fast? So we'll step through it bit by bit. We'll start off with page load. And the first tool I would go to on the audit would be this, Page Speed Insights. All you do is you pop in your URL like so, hit Analyze. It's really complicated. And ta-da, you get a score out the other side. You get a score for desktop, you get a score for mobile, and it will give you some user experience hints as well, like tap targets, legibility of your text, and so forth. So if you've got problems that might not be obvious when you look at your device and you run it, then this will start to pick them out for you. People ask what kind of scores they should get. These are my own personal scores. 85 on mobile, 90 on desktop, and I don't want to see any UX issues. You could disagree with these. I would recommend that you go and have a look at what you're actually getting as your scores. I tend to say that if you're getting in this range, you haven't got any major issues there. But what kind of things are we looking for? Well, I'm going to go blast through what I consider to be the bread and butter, the things that I think we've talked about time and time again as developers over the years. First one is unoptimized images. Because unoptimized images are going to waste your mobile data, and as somebody who's roaming in the States right now, I'm very acutely aware of my carrier back home and the charges they could levy against me if I were to download something that was very large. But it also increases site load time. 63%, according to HTTP Archive. That's the percentage of bytes in the average web page that is over images. So it represents this huge surface area of optimization that we can go after as well. Easiest way I know, if you have this problem, is just drag them onto ImageOptim. If you're on a Mac, there are equivalents for Windows, I'm sure. And it will go through, it will crush the images down, spit them out, and you're way better. Unmanified resources, so things like your JavaScript and your CSS, they also waste data, and they will increase your site load time. We've talked about this, I think, as an industry for a long time. So it's on my list because this is what I look for, but all the same, I would say it's something that I would expect everybody does already. Anyway, the one I don't think that too many people think about is the number of requests. Oh, maybe they do, but let's talk about this a bit. Every request that you're going to make, JavaScript, CSS, images, they're going to slow down your site. So that should also be on the list. And now we go into what I consider to be the ones that are, I suppose, more mobile concerned. This one, too many redirects. Not something that I think people think about initially, but let me explain why. Every redirect that you make is going to slow down somebody on their phone. And 40% of people apparently will abandon your site if it takes longer than 3 seconds. So I've taken the liberty of putting a timer here. If we request the site and it's your site, we incur the cost of DNS and a connection and sending some data. And on 3G, we'll be talking potentially up to a second to get this done. If we respond by saying, actually, what you're looking for is on the m.dot site, we now have to do another DNS lookup, make another connection, and send more data. And we're into that, potentially into that 2 seconds. And then we say, actually, what you really wanted was on this path. We don't have DNS this time, but we do have a connection and data. And all of a sudden, we're starting to get perilously close to that 3 seconds, and all we've done was show a white screen. This is bad and something that we want to avoid. Shock upon shock. The solution is to actually respond to the request. And if that sounds like a sort of roundabout way of saying m.dot sites might be bad, yeah, you might think that this is an easier way to solve that problem. So on my list of things, and the things that PageSpeed Insights will also give you back, is avoiding redirects. So far, so good. We have this kind of list of things, this checklist of things, but we don't really know what it's like to load the site from a real-world location on a particular device and so forth. That is where Web Page Test is going to come in and help us, and it is not very complicated to set up. Here we go. Pop the URL in the top, and we ask it for a particular location and browser, and we say, in this case, I want 3G, number of tests, and because I'm feeling exciting, let's capture a video as well. That's one of the amazing features. I love capturing videos. We're going to look at that one in a sec. So we run this, and we get some results back. And at first glance, I always think this is a bit overwhelming. So let's dive into what we're seeing. Performance grades in the top corner. These are like the headline items of what you should be looking for. If you get reds in here, that's something that you want to look for and you want to fix. So if you click on it, it will tell you why you got the grade you got and what you need to go away and fix. The next thing we get are the performance details. How long did it take our server to start sending data back? How long did it take for the page to render? Everything that you sort of need from a numbers point of view. We also get a waterfall and a few charts. And then because I checked that capture video button, I also get this in the corner, which says watch video. So I thought I'd share the video of my... I made this test site, by the way. It is hideous, but I did it to show. It's not that I did this on purpose. Well, I did do this on purpose. Anyway, have a look. Well, I hope that was as agonizing for you as it was for me, frankly. 18.2 seconds to load something on a 3G connection. I've pulled out the 3 milestones that I think are dead important here. First of all, 6.5 seconds. That's the point at which we started to get something on screen. Up to that point, all we had was a white screen. And as we discovered earlier, up to 3 seconds for everything, and people start leaving. So that's bad. 9.7 seconds is when we actually had the initial viewport filled in, and that's something we'll come back to in a second. And then lastly, when everything's loaded at 18.2 seconds, we can consider ourselves complete. So this one here, saying that something is visually complete is actually a really interesting measure because it represents something to do with perceived performance and how people feel how long it takes to load your site. And when we go back into those results that we have from Web Page Test, the one number that should stand out for us then is this, which is that 9.7 seconds expressed as milliseconds, pretty much. There is a bit of a difference. The speed index is a really good measure for perceived performance. It's actually a link. You can click on it. It will tell you how it figures out what the speed index should be. And it is a bit convoluted, but it does represent the best measurement that we have for perceived load, not just the body on load kind of event, which, as we saw, was several seconds later. I tend to, when I'm doing my audits, I tend to look for a speed index of around about 1,000, which is a very tricky number, difficult number to get, but it's actually a really valuable one. That's going to make your site feel really snappy to anybody who loads it, particularly on a mobile connection. Also worth pointing out is because I checked that capture video button, I have this film strip view. And if we look at that, it's pretty much like that video I showed, I suppose, in many ways. But you have the white screen there at 6 seconds. You have visually complete at about 10. And it's basically up to this point, up to this sort of 10 seconds, is what we call the critical rendering path. This is the point where we have to sort of figure out, well, what does the browser need in order to get things on screen? And that comes in two parts. It's what information does it need, and then how can we stop it being blocked in doing that? So, for example, JavaScript can block rendering, as an example. The thing you want to do is to prioritize the critical rendering path. You want to make it easy for the browser to get something on screen. That will lower your speed index, and it will make your site feel a lot snappier. Prioritizing the critical rendering path is a big topic, too big for this, so I will point you towards the Google Web Fundamentals, which we recently launched. I've created a short link there if you care for taking that down, bit.ly/iocrp. There we go. That is a whole documentation on how you can prioritize the critical rendering path. Looking at the waterfall that we get, first thing is those redirects. PageSpeed Insights will have told us that we had redirects. This is going to confirm that, and each one of those, you can see, slows us down. The other thing I thought was quite interesting in my fake example is that I'd duplicated files. I'd requested jQuery twice, but I know that this is perfectly reasonable and possible, having seen it in the wild, that you have multiple developers. One pulls in jQuery, the other one pulls in jQuery, and whoops, didn't realize we were getting it twice. If you look at your waterfalls, you might start to see those kinds of patterns. The other thing I noticed is that we've spent a long time transferring one of the images, that dark blue. Most of the time, it's not actually spent transferring bytes. It's actually all the different connections and so forth, which comes back to the number of actual requests. But in this case, we do have a long transfer time. So far, so good. This is the page load. So it's optimizing resources, reducing the number of requests, it's avoiding redirects, and it's prioritizing the critical rendering path. And I think most people, when they hear that, they go, fine, but that sounds like a lot of work. Yes, it can be, but there's good news. Grunt and Gulp both have tasks galore to help you do this. And so all you need to do is just run them with these tasks, and it will hopefully help you. In fact, when I ran through this talk, my colleagues went, I need the closure. They don't sound like that. That's me doing a mean impression of them. And so I said, OK, fine. This is me running grunt. 8 whole seconds later. Ta-da. And now, my PageSpeed Insight score is 100. But really, when somebody loads it, you'll notice that the speed index has dipped to 1,396. Just following PageSpeed Insights' guidance, following Web Page Tests' guidance, will help you significantly. In this case, we're 6.8 times faster. Yay for me, but... Wait, no, I made it 7 times slower on purpose. No, it's all good. So that's page load. For me, it's those kinds of things. The bit where I normally kick in is this bit, the runtime, because for me, I get very frustrated even when something loads quickly if it is horrible to actually use. And other people notice that as well. Let's come back to what Laura said. When we eliminated jank, better, better, more, more, brilliant. OK? Jank. Jank is missed frames. But then you go, hang on a minute. What's a frame? Exactly what are we talking about here? Yeah, let's set this one out. Your modern smartphone refreshes its screen about 60 times a second. For us, then, we actually have to get 60 pictures or 60 frames onto the screen. And that means that for that 1 second, we will have 16 milliseconds in which to create those pictures. And so it becomes very important to understand how those pictures are made and how we control that part of the process, because we really, really do. So let's talk about how Chrome goes about making a frame. This is the Chrome one. To be honest, most browsers actually go through a very, very similar process. But this is the Chrome-specific bit. The first part of the process from a developer's point of view is the recalculation of style. Here we've got a DOM tree. I've simplified it a little bit. There's nothing under head. There normally would be. But you get the idea. We have a DOM tree. We've parsed our HTML. We've created this tree. And what we do is we bring in the CSS that we have from the style sheets that we have from the user agent. And what we start doing is we start saying, OK, this applies to these elements, and some of it will cascade down. This from the user agent actually switches off the head because we don't display that. Same goes for scripts, and so on, and so on, and so on. The browser does it faster than I would. Till we arrive at this. This is a new tree called the render tree, and it's all the things that we care about putting on screen. So we have this tree, and we know all the things about, all the, in theory, the colors and the positions and how everything relates to everything else. Now we actually have to figure out the geometry of the page, and we call this layout. So we push this in, and I marked it out with boxes. This is where we think all the elements are going to be. And the thing about this part of the process is the unique-ish layout model of the web means that one thing can affect another thing. If I change the height or the width of the body, then the things that are inside the body are probably going to be affected. So it starts to matter about how we start to deal with our elements as to whether layout will be a problem. Next, we actually have to start filling in some pixels. So let's start with our boxes. Let's fill it in white, pop in a header, a couple of UI elements there, some buttons, a bit of text, a bit more text. Hamburger icon. Argue with whether that's a good thing. User experience people aren't so sure. Title, date, and we're good. We've filled in our picture. We've had this one bitmap in memory that we've drawn our pixels into. Super. The final part of the process that we care about is compositing. Now, to understand compositing, we actually have to go back to Paint a second, where let's say we've got a different header that we want to put in. Let's say we're fading between that darker one to that brighter one. Well, this area in red is considered dirty. And so we paint in our new header, but now we actually have to repaint the hamburger icon, the title, and the date. And you start to sort of say, hang on a minute, that's not great, because we've had to paint a bunch of things that didn't even change. Well, the good news is we can, and we do better. What we actually do is we create these things called compositor layers. So these things are in sort of separate space in this picture, but really you can see the header is animating all by itself, and we have this separate layer that we've painted all the other content into. And the idea is now we can keep them separate, and when we're repainting, we don't have to repaint the things that didn't change. So that's compositing. The good news is that Chrome DevTools will show you frame data. If you load up DevTools and go to the Timeline tab, you can see something like this. This is zoomed in. The things that we care about is there's this line here at the top that marks the 30 frames a second. 30 frames a second. This one is 60 frames a second. And you see here, when you're running your page and this is recording, you'll start to see these bars appear. This is your page's frames per second. And when we zone in on one of these bars, we start to see these records appear at the bottom. And they correspond to that pipeline that we just discussed, recalculating style. What applied to what CSS applied to which elements. Layout, figuring out the geometry of the page. Paint, filling in the pixels. And of course, compositing, putting all those layers back together. So now that we know about how Chrome and other browsers create frames, I would like to introduce you to my friends, the 4 horsemen of the Jankocalypse. These issues are my greatest hits, as it were, of Jank. That's not to say they will occur in every project, but they're the things that I'm looking for when I do the audits. And They're as follows. Firstly, expensive animations, and you should consider scrolling to be an animation something is moving on screen. Let's take a pretty innocent-looking example, I suppose. Let's assume we're making a card-based system, because that's pretty popular on mobile. And we have this expanded class. We tap, say, one of these cards, and we expand it out to 400 pixels in height. And we're going to just do a CSS animation, because we've heard that that's good, or a CSS transition. That's also good. It turns out that this isn't quite as good as we'd hoped. And to understand why, what we're going to do is, notionally, we're going to plug in our Nexus 5 into our machine over USB. We'll go to Chrome Inspect, and you'll start to see that the tabs appear that we have open. And I have an animation on Layout tab open here. And all we need to do is tap Inspect, or click Inspect, and we'll start bringing up DevTools. So we have our card example here. We have DevTools, and the little red light says that we're recording. And when I tap on one of these cards to expand it, boop, you'll see that we've shot out the top of that, even the 30 frames a second line. And when we click on it, we find out that we spent 23 milliseconds figuring out the geometry of the page, because as we expanded one of those elements, we had to move all the other ones down, and we had to figure out what happened to the geometry. And that was expensive on a mobile device. And you also notice that we spent nearly 600 milliseconds painting the pixels. So when we're supposed to be doing 16 milliseconds in a frame, to spend 600 is going to kill our frames per second. So this, for your users, will appear as janky. Of course, this is one situation. It's not always the case, but generally speaking, I tend to find that layout will trigger these kinds of performance problems. But you can see how you start to figure it out yourself with Chrome DevTools. So from a kind of frames point of view, if we go with these 16 millisecond markers, that layout, even just the layout pushed us past that marker, and now the paint just killed everything for us. And it's not much better if you go straight to paint. I have a bit of code here that's going to send something to hot pink. Why wouldn't you? And again, we're going to use a CSS transition. Similar kind of situation. Let's have a look at what we see when we run it in DevTools. Tap it. Boop. And you can see, again, we're not even hitting 60 frames a second. In fact, there we are, 72 milliseconds just painting each of those. Again, you might find that that's not always going to be the problem for you. But even so, it's probably worth figuring out the tools. Do excuse me. There we go. Failure to plug in. There we are. Please tell me that I didn't kill something. I'm back. Thank you so much. OK, good. Whew. Move along. All right, so you might be asking yourselves, how can we get high-performance animations on a mobile device? Great question. And the answer is to stick to these, actually, is to stick to transforms and opacity changes. So the transforms obviously translate, scale, rotate. There we are. And opacity there. Now, the only note there is that the element will need to be on its own compositor layer, just like the header that we had before, which was on its own layer. And you might be saying, well, OK, fine. How does something get its own layer? Great. OK. Well, there's a new property that is in Firefox, and it's in Chrome. It's currently in Canary, I believe, is will change. And will change, you can tell it about the things that are going to change from a visual point of view, like transform in this case. Or you can tell it about something like opacity. You could use left, top, depending on what it's going to change. And you're now trusting the browser to create compositor layers or just make the right optimization for you. And that's a really good thing. One kind of note of caution here is that if you create too many compositor layers, you could find that your timing compositing goes through the roof. So that's something to watch for in terms of those records that you see in DevTools. So let's go back and see what happens when we just animate transform and opacity. Here we go again. There we go. A very smooth 60 frames a second is what you'd experience. And you'll notice that we spend a fraction of a millisecond recalculating each of the frames of our animation, and then a fraction of a millisecond compositing things together. People often say, well, how come I'm seeing transparent bars up here in DevTools? And the answer is, essentially those frames are empty. The workload was so light to do compositor-based operations compared to doing layout and paint that we can now fit it comfortably inside the 60 frames a second budget. So from a kind of frame point of view, we recalculated style, we did compositing, all was well. So in terms of this kind of waterfall, we would like to be down here, is the long and the short of it, rather than starting right up, say, at the top with layout and then paint. So then, having explained all that, the first item on my list is, am I seeing expensive animations? If so, I will start to suggest that people restrict their animations to these properties. The next thing I see quite often is mistimed animations. It's still true, I believe, today that jQuery uses setInterval for its animations. And the problem that you have when you use setInterval for your animations is that you'll find that your JavaScript, your setInterval fires at some point inside your frame. And sometimes you'll miss your frame, and sometimes you'll hit your frame. But for your users, what they'll see is they'll see it judder and jank. What you should be doing instead is using request animation frame, because it gives you this. It gives you a consistency and the scheduling, the knowledge that you are going at the start of the frame and much more likely to hit your happy point. So the second thing I look for is sane use of request animation frame. Layout thrashing continues to be an interesting one. And what this is, let's take a fairly contrived but fun example. We'd like to resize all these paragraphs to be the same width as this blue block here, like so. And the code for this, I think, would be pretty trivial. We'd loop through our paragraphs, we ask for the width of the blue block, and then we set the first paragraph. And we go round the loop, and we ask for the width of the blue block, and we set the second one. And if you run DevTools against this, you'll start to see something that looks like this. The first thing to notice is that we have a monster frame, which is about 2.65 seconds. When we look into the records of why it was a monster frame, you start to see that we've gone into this bizarre cycle of reading and writing styles. And what's actually happening is we're asking for the width of the blue block, and then we're doing something to invalidate that calculation by setting the paragraph's width. DevTools actually puts this yellow triangle, and this is a warning to you, which it's going to call it a forced synchronous layout operation, which is its way of saying, you made me go away and do some layout calculations, figure out the geometry of something, its width, its height, its padding, its margin, when I wasn't expecting to. And we're going into this kind of thrashing between the two states. Instead, what we should do is ask for the layout property once at the start, and then do all the writing. So it's this kind of more general rule. When I see a layout thrashing, I would say, read any layout values, then write them. That said, if you're going for the first one, you'll probably try and avoid layout during an animation. And the last thing that I look for, the fourth horseman of the jankocalypse, is garbage collection. Garbage collection has the ability to essentially interrupt at any point. It's an undeterminate point in your frame's lifecycle. When we switch over to the memory in DevTools, the memory profiler, you see here we have one of these drops. So we see this chart of memory going up and down, up and down. Every time it goes down, that's garbage being collected. In this particular situation, I have a large amount, about 40 megabytes of garbage, so stuff that has been released, and it takes Chrome 10 milliseconds. Now, this has actually got a lot faster over the last few years, but it can still knock you off in terms of your frames per second. Oh, it hurt. And this is why. Basically, it's something you don't have control over in that sense of when this is going to happen, but if it does happen to you, then you will not make your 60 frames a second. So, writing fast memory-efficient JavaScript is a big topic in and of itself, and so I will just point you to this, which is Adi Osmani's article by that very same name. I like the fact that Adi's not even looking at anybody here. He's just aloof. Doesn't want to look at us. All right? Good. Runtime, then. For me, it's restricting animations to transforms and its opacity. As I say, these aren't always going to crop up, but this is what I'm looking for. It's the sane use of request animation frame. It's reading layout values and then writing them if necessary. And it's writing fast, memory-efficient JavaScript. As I said, these aren't always going to crop up, but when they do, these are the things that are going to stop it feeling silky smooth on a mobile device. So far, though, this is what I spend my time looking at. So like I said at the start, the future that we face is with these things. It's with smartphones. And they are performance constrained. When you hit a performance issue, you really know about it. And people have higher expectations of performance on mobile. Bizarrely, they do. And so we really need to meet that expectation. We really need to make fast-performing sites and apps. The way you're going to get there is to start by gathering data. The tools that I've shown, PageSpeed Insights, Chrome DevTools, Web Page Test, they should be the bread and butter. You should go away and run those and see if you can figure out what's happening. But the tools themselves will let you gain insight. They will actually tell you what the numbers mean, why you got the scores you got, and what you should do. This is PageSpeed Insights saying, here are all the reasons why I think you have illegible text. And if I fix all these, then I'm good. Which is to say, the final part of the puzzle is to take action. It's no use getting all this information, all this data, and then doing nothing with it. So if I can ask you to do one thing, it would be to go forth and audit. Thank you very much. All right, you can let me know what you think with the session feedback, and I will be outside for Q&A after this.
Google I/O is just around the corner.
And we're really excited to show you what we've been cooking up.
For the first time, in addition to our live streams, we are rolling out over 100 I/O Bytes.
Short videos to help developers like you dive in.
And experience I/O anytime, anywhere.
We're delivering more content.
And making it easier than ever to design,
develop,
and distribute.
And making it even more accessible.
And it's all for you.
It's just for you.
It's all just for you.
Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
In the last few years, we've seen a staggering increase in video consumption on the web, while worldwide internet bandwidth has not kept the same pace. To help with this, my name is Vignesh. I'm here to talk about how you can take advantage of a new video format for the web. Video already accounts for more than half of the peak internet bandwidth worldwide and almost 2/3 of the peak internet bandwidth in certain parts of the world. The WebM project is a collection of open tools and media technologies that aim to tackle the challenges of media at internet scale and enable open and free communication of ideas through media. The WebM project develops two video codecs, VP8 and VP9, a media container, that's the WebM container, and an image format called WebP. These technologies together power some of your favorite Google services at a large scale like YouTube and Hangouts. They are also widely used on the web. For example, Netflix and Facebook use WebP. We announced VP9, our next generation open video codec, at I/O 2013. Videos encoded in VP9 see up to 50% improvement in compression efficiency. Today, VP9 video playback is supported in Chrome, Firefox, Opera, and Android. Since I/O 2013, we've improved both the speed and the compression efficiency of VP9. This has enabled YouTube to choose VP9 as their next generation video codec. If you're curious about updates to VP9 since I/O 2013, check out our video Updates to VP9. Additionally, if you want to deep dive into the encoding techniques used to achieve the compression performance, we highly recommend checking out our I/O 2013 session on VP9. It's called the New Open Video Codec. In this video, I'm going to focus on how to easily encode VP9 videos using open source tools, and then go on to talk about how we can play those videos back. First, the simple progressive encode. Let's say that you just want to encode a video and want it to be played back across multiple devices. In other words, all you want to do is just host a video and play it back using the video tag by using the hosted URL as the source. Here's how you do it. Progressive encodes are simple and will allow any supported VP9 player to download and play the file. Examples include Chrome, Firefox, and Android. Here's how you create a progressive VP9 encode. All you need to do is point FFmpeg to your input file and ask it to use the VP9 encoder. Here's how you play back this video. That was simple, wasn't it? If you have ideas on making it even simpler, we welcome all your thoughts at this email. Okay, now if you plan to serve video over the web, chances are that you want to take advantage of some of the HTML5 technologies that will allow you to provide a great streaming experience to your customers. This has traditionally been tough, and an industry standard was born to solve this called Dash. Dash stands for Dynamic Adaptive Streaming over HTTP, and it allows you to select the stream that will provide the best perceived quality depending on the client's constraints. Traditionally, this is bundled with the term adaptive playback. At Google, we use adaptive playback using Dash and HTML5 technologies like media source extensions to provide a great streaming experience on YouTube. For example, with VP9 and Dash, we've improved the key metrics of streaming videos, rebuffers. VP9 Dash videos have improved rebuffers by 25% in developed markets and up to 50% in emerging markets. Okay, we've heard from video developers that creating a Dash manifest for VP9 has been challenging. I'm happy to announce that we've worked with FFmpeg and are announcing a set of open source tools to simplify the encoding process. Let's now take a look at how to encode VP9 Dash videos and generate the manifest. Encoding a VP9 video to be compatible with Dash is very similar to doing a progressive encode with a few minor changes. For Dash, the video and audio has to be encoded separately into two different files. You also need to pass the extra Dash parameter to FFmpeg so that it creates WebM files which are Dash compliant. Now that you have the video and the audio files encoded, you can make use of the WebM Dash manifest tool to generate the Dash manifest file. The WebM Dash manifest tool is part of the WebM Tools project. You can download the tools we use to create Dash streams and the manifest from the links found on this slide. Okay, let's now talk about integrating a video player to play back VP9 videos using Dash. Just to reiterate, VP9 decoding support is already available in Chrome, Firefox, Opera, and Android. Together, they represent over 1 billion devices and browsers that can play back VP9 video. But creating a VP9 player to play back adaptive video is a little more difficult, although there are two players that makes it easy. To put together, they enable adaptive VP9 playback on two of the most popular platforms, the web and Android. First off, Android. YouTube open sourced a player called the ExoPlayer that supports adaptive playback of VP9. To know more about how to use ExoPlayer to enable VP9 Dash videos in your app, see the talk by YouTube on ExoPlayer. For the web, we added VP9 Dash support to Dash.js, which is a fantastic all-in-one media player built entirely in HTML5. For more information on how to use Dash.js to play back adaptive VP9 videos, you can follow the link on this slide. With these tools, encoding and decoding VP9 content has never been easier. Now it's your job to tell a great story or ship the next great video player. And of course, we're here to help. Drop us a line at webm-discuss@webmproject.org. Thank you.
Hey, I'm Chris Wilson. Like me, many of you probably have a guitar or two tucked away you like to noodle around on. Or like me, you have a basement full of synthesizer and studio gear. But for years now, I've been getting more and more excited by the powerful music software available for desktop computers, and lately even mobile devices. Now, I can replicate vintage synthesizer and processing hardware and software, which lets me stop filling up my basement while draining my checking account. Well, I'm here to tell you that all that exciting software can now come to the web platform with an amazing open web platform API called the Web Audio API. The Web Audio API was designed for several purposes. First of all, it's a great API for building sound for gaming. When we build games, we need to be able to make pew 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 sounds right when our users hit the button. You need to hear that massive explosion right as the screen lights up, or whatever. Now this was hard to do with the HTML5 audio element, which wasn't really designed for precise timing, multiple simultaneous sounds, or memory management. But the Web Audio API also lets you crack into the world of digital audio in a big way. You're in control of the audio path itself, with powerful but easy-to-use processing nodes to create effects like delay, filtering, reverb, and more. Now the Web Audio API lets you create rich, multiply layered effects by giving you the primitives you need to do the job, like delay nodes, gain control, filtering, even complex primitives like convolution. The goal isn't to give you all the complex final effects you could ever want. It's to give you all the primitives you need to build more complex effects. When I first started playing around with the Web Audio API, I wanted to see just how far I could take the processing system. So for a past Google I/O, I wrote a vocoder application. Now vocoding is a fairly complex process. It takes one sound source, like me talking to you now, and it chops it up by frequency bands. Next, it takes the volumes in those bands over time, and it applies them dynamically to the same frequency bands in another sound, usually a synthesizer sound.
Now you do this now with a robot. You can raise your brain. You can even change it engine or become a steam robot. Do, re, mi, fa, do, la, di, do.
You can also use Web Audio to create other audio processing effects, like chorus effects, or reverb.
Or pitch shifting. I'm talking to you, Kent.
Or you can become Alvin, Simon, or Theodore. Should I give the rest of my talk like this? No, probably not.
To implement each of these effects, though, I didn't write JavaScript code that acts directly on the sound buffers. I wrote code that combines the processing nodes that Web Audio gives me, and it does all the work. Okay, so you can perform real powerful processing with Web Audio, but where does that sound source come from? Where do you get started? Well, as I just demonstrated, the sound can come from the user's audio inputs. Via WebRTC's Get User Media API, you can hook the audio inputs of your computer. Sometimes that's just the microphone on your headset, but you can also have a pro-quality audio interface with a killer axe plugged in. Web Audio can also hook any media element's audio output, so you can grab the audio output from video or audio elements. This can make it easy to do just some basic processing, like gain control or filtering, on an audio element that may be streaming from the server. But sound sources can also come from audio samples that you load, through XML HTTP request most likely, and you can use Web Audio to decode from MP3, WAV, or OGG format to a buffer. When you play those buffers back in Web Audio, you can also change their playback rate, or detune them. This makes it easy to take a simple sample, like this one I recorded of me tapping a wine glass, and turn it into a playable musical voice. And finally, if you don't want to use recorded sound, you can use Web Audio's natively implemented oscillators. If you're an old synthesizer nut like me, you'll know that oscillators create a basic waveform, like a sine, square, sawtooth, or triangle wave. This makes it easy to produce basic audio blips, bleeps, and bloops. Of course, oscillators also make it completely possible to build much richer synthesizers without ever loading a sound file, like with this digitally replicated analog synthesizer I built. I tried to dig up a keytar to play this live, but I couldn't find one. Now, oscillators aren't just for building synthesizers. They're also the key to creating a lot of effects and complex sounds. Many effects, like the very common chorus effect, use oscillators in the background. Chorus is really just a delay with a constantly varying delay time. That variation is caused using an oscillator. This kind of control is possible because of Web Audio's powerful, flexible audio parameter and routing system. Most parameters can be controlled and scheduled at the rate of the audio. This makes for some amazing effects. For example, for those of you who remember the 80s, you can build FM synthesizers, similar to Yamaha's DX7, because you can modify one oscillator's frequency with another oscillator at an audible frequency, and that creates that classic FM synth bell-like sound. Working with the web audio system's routing and parameter schedule can be a little daunting at first, but think of it like a queue of notes that you need to keep full. It's sort of like when you sight read sheet music. You need to look ahead a bit of where you are to keep your playing fingers primed. The audio system is busy under the hood, generating and processing the sound stream, and keeping the sound output happy by pushing a continuous stream of audio bits at it. So really, the least you can do is give it a little heads up for what it will need to be playing soon. I wrote an article a while ago about web audio scheduling for HTML5 Rocks that can help you better understand this system, and it can help teach you to create rock-solid timing for musical applications, even with JavaScript's not always rock-solid event delivery timing. This makes it so you can easily build drum machine and sequencing applications that keep a rock-solid beat while still responding in near real time to parameter changes. One more critical piece to building musical applications is control. In the music world, nothing beats having a real physical instrument to finally control your sound. So we've been building support for a standard called the Web MIDI API that lets music controllers, like this, or this, or even this, get plugged straight into the web platform, so you can use them for direct control of your web applications. This lets me have direct, physical, immediate control over these great audio capabilities. Now, the Web Audio API is available on Chrome, Firefox, and Safari today, and Internet Explorer recently began development as well. But finally, I want to leave you with one mind-blowing revelation. All of these things I've been talking about, all the incredible power of the Web Audio API, all of this works on the mobile web as well, with modern mobile browsers. iOS, Safari, and Chrome for Android both implement the Web Audio API. In fact, Chrome for Android even has an experimental implementation of Web MIDI, so you can build amazing web music applications and take them with you wherever the web goes. So I hope I've inspired you with some of the things you can do with the Web Audio and Web MIDI APIs. Let's get out there and make the web rock.
Hello, my name is Jay Judkowitz. I'm the product manager for Google Cloud Platform block storage products. I'm here with some news, technical details, and best practices about block storage in Google Cloud Platform. At Google, we're always excited to bring new storage offerings to the cloud. That's because it's all based on the great technology we've built in-house to run some of the largest and most successful applications on the internet. When you use Google Cloud, you're taking advantage of the same great storage infrastructure as we do at Google. Block storage in the cloud is general-purpose storage that you attach to a virtual machine that appears as a disk drive to the VM. You generally format it with some file system and write files or databases to it. It's what you use to create your own self-managed data stores. This section will announce 2 new pieces of news about block storage in Google Cloud and quickly describe the 3 block storage options that we now have. Cloud Platform offers 3 types of block storage. The key difference between them is how many IOs per second, or IOPS, can be supplied by each gigabyte of storage. Higher IOPS per gigabyte trade off against cost and flexibility. The first option, Standard Persistent Disk, or PD, has been around since Google Compute Engine was first released. It utilizes networked hard drives. It's designed for security, high availability, and consistent performance. For use cases that need up to, say, 2 random read IOPS per second per gigabyte, this option is ideal. You get steady performance at a low price. The second option, SSD Persistent Disk, we're pleased to announce is in general availability now. It's like standard PD, but backed by networked SSD. As a result, you have a higher cost, but a higher performance per gigabyte. Use it like you would standard PD, but in cases where you need between 2 and 30 IOPS per gig. The third option is not yet generally available, but is now accepting trusted testers. It's a local SSD option. It offers the highest possible performance, but has availability, durability, and flexibility trade-offs I'll discuss shortly. Before we get too deep into the numbers, Let's give a quick overview of the similarities and differences between the two PD options and local SSD. First, the similarities. All of our block storage options are priced on a per gigabyte basis with no I/O charges ever. This makes planning simpler and eliminates surprises. All of our block storage options are designed to perform consistently between similar volumes and consistently over time. Third, all of our block storage options are encrypted on disk. And because PD is a network storage offering, the data is also encrypted over the wire. This is to give you the best possible security. Lastly, all of our block storage options support live migration and are therefore not affected by planned downtimes that keep Google Cloud data centers patched and maintained, which is what keeps your applications as secure and available as possible. Now for differences, starting with reliability. PD has additional reliability that comes from storing its data redundantly, so that volumes can survive the sudden loss of hardware. Local SSD does not have this redundancy. It's up to you to protect the data that needs to survive storage failures. PD also has built-in checksums. Whenever you read data, no matter how long ago it was stored, PD makes sure that it returns what was written to you and avoids silent data corruptions. Lastly, PD has a snapshot functionality that makes it easier for you to protect your data against user error and physical disasters. In terms of performance, while all the block storage options perform consistently, local SSD has much higher IOPS and is designed for sub-millisecond latency, making it ideal for the most performance-hungry databases. For flexibility, note that both PD and local SSD are very flexible. PD volumes are the more flexible in that they can be created in sizes ranging from as small as 1 gigabyte all the way up to 10 terabytes in 1 gigabyte increments. And it can be attached and detached from VMs on the fly. Local SSD, by contrast, can be allocated to VMs only at creation time and need to be allocated in 1 to 4 partitions of 375 gigabytes. While this isn't as flexible as PD, local SSD does not require special instance types with pre-specified amounts of SSD. This lets you right-size the VM, CPU, memory, and storage. So, given these three options, how do you decide which option is right for your application? Let's split it up by use case. First, boot volumes and bulk storage are great use cases for standard PD because those use cases require low IOPS and low throughput, basically just want to occupy the cheapest, reliable space available. Streaming I/O is a use case that works best for standard PD as well. While the other two options have a much lower cost per IOPS, the cost per throughput is generally better on standard PD. Reading large sequential blocks is what disks are good at. SQL databases, like MySQL and Postgres, and NoSQL databases, like Cassandra, Mongo, and Redis, tend to be transactional and IOPS heavy. Smaller instances might be able to be run on standard PD, but important production databases should usually be run on some form of SSD, either SSD persistent disk or local SSD, depending on how high the IOPS needs are. File servers, like NFS, Gluster, or Ceph, can be more streaming or more transactional depending on what the clients are doing. SSD PD is generally a great choice here. High-performance scratch disk, where keeping the traffic local is the right architecture, should go on local SSD. For Hadoop deployments, where I/O needs exceed what Google Cloud Storage Connector for Hadoop can provide, for that case, you should use local SSD under a Hadoop optimized file system. Here's another way to visualize the same information. As you can see, depending on the performance needs of file servers or databases, you have options as to which block storage product to use. To decide, you'll want to get down to the real numbers of space and IOPS. I'll go through some specific examples just a bit later in the presentation. But right now, let's double-click on persistent disk and talk about what separates the two PD options, their performance. With both options, standard and SSD, for both read and write, the more space you buy, the more IOPS you get. But SSD persistent disk grows in IOPS capability much faster than standard PD, which is why it costs more. Each gigabyte of SSD PD gets 20 times the write IOPS of a gigabyte of standard PD and 100 times the read IOPS of a gigabyte of standard PD. These high IOPS numbers are what make SSD PD ideal for transactional workloads like heavily used databases. Now, the SSD PD IOPS grow so fast that they reach the limit of the IOPS of a VM can handle at a relatively low volume size, which is why these graphs have this plateau at the top of the IOPS curve. We're always working to increase the per VM limits, and you should check on the current documentation for the latest numbers rather than coming back to the graph. Now, moving from IOPS to throughput, same pattern here. Performance grows with space for both options. Unlike the IOPS graphs, however, you can see that SSD PD's advantage in throughput is less dramatic, and both standard and SSD PD can hit the VM throughput limits at moderate sizes. This explains why we recommend standard PD for throughput-oriented applications that have low IOPS. While SSD PD has a much better cost per IOPS, standard PD has the better cost for throughput. Like with the previous slide, please check the latest documentation as we're always striving to raise the per VM caps on throughput, just like with IOPS. So, the idea of growing I/O with space is pretty unique, and many customers have asked us why we designed it this way. We made this choice because of the following benefits that we think are very important. First, simple and consistent pricing. With this model, there's no billing variations due to your app's I/O needs changing over time. The cost of a volume is the same from month to month, with no surprises because all the I/O is included in the cost of the space. Second, consistency of performance. This is critical. By selling I/O and space together in a safe ratio, we stabilize the overall storage traffic and keep volume performance consistent over time. This means your app won't suffer the noisy neighbor problem. Third, simplicity of in-VM management and snapshot management. Because larger volumes give you the performance of many small volumes, you're spared the upfront effort of scraping volumes together. And because each VM needs only one data volume, management of snapshots becomes trivial. Each volume snapshot is a copy of an entire VM's data at a given time. Lastly, we wanted to give you consistency across the product line. We've been able to make all three block storage options behave similarly. You don't need to pick between different price and performance models or plan I/O down to the individual IOPS level. We've tried to simplify everything as much as possible. You decide how much space you need, and you pick the storage type based on how many IOPS per gig need to come along with it. Now, at this point, I'd like to help you with the most important decisions you're going to make in implementing block storage. Given the three options, how do you decide which to use for which app, and how large do you need to make the volumes in order to get the performance you need? While I can't give you an exhaustive process or algorithm to answer all the use cases, I will walk through 4 separate examples to show you how you can approach the decision for your application. In the first example, we're going to have 300 gigabytes of space and a fairly modest amount of I/O, 60 random reads per second and 120 random writes per second. Here, simply 350 gigabytes of standard persistent disk will do the trick nicely, very economical cost, and give you all the I/O you need with some to spare. The second example is actually the trickiest one. Here, we're still going to go with 350 gigabytes of space, but this time with more I/O, 450 random reads per second and 600 random writes per second. We can quickly see that 350 gigabytes of standard PD will not give us sufficient I/O. While we could move up to standard PD, SSD PD, we don't absolutely need to. Because the price of standard PD is so low, we can actually create roughly a 1800 gigabyte standard PD volume, and it winds up meeting the performance needs while still being somewhat more cost effective than a 350 gigabyte SSD PD volume would be. The third example leaves us no room for doubt. Here we want 350 gigabytes of space and a large amount of I/O, 9,000 random IOPS. Here, 350 gigabytes of SSD PD meets the needs perfectly. In the last example, we're going to stay with 350 gigabytes of space, but this time a very large amount of I/O. We're going to go for 60,000 random IOPS. Here, you can use a single local SSD partition of the 4 that you could use. A single partition will meet both the space and the IOPS requirements. So now, let's switch over to general best practices, focusing on persistent disk here. Most of the best practices we're going to talk about are about performance. The first performance tip comes from the fact that PD works with 4 kilobyte I/O boundaries. Any misaligned I/O will dramatically lower the performance. All of the PD I/O should be multiples of 4 kilobyte and aligned to 4 kilobyte boundaries. Disk partitions and their file systems must be aligned to those 4K boundaries. The easiest way to be sure of doing this properly is to have a simple partitioning scheme with a single partition for the volume and to format that partition using the Google-provided safe format and mount script. The operating system and application stack should do everything else for you. Here's a syntax for that safe format and mount script. And keep in mind, if you don't use that script and you format your file systems on your own, please make sure to align on 4K boundaries. And if you mount your file systems on your own, please make sure to mount with the discard option. The discard option makes format times much faster, makes snapshots smaller, faster to take, and makes storing those snapshots less expensive. The next performance recommendation is about tuning your application properly for your I/O pattern. Starting with IOPS. PD attains its high IOPS performance through the use of parallelism on the back end. Therefore, for higher IOPS, we may need a larger queue depth or application thread pool. The more IOs you can issue at once, the faster the PD volumes can return the data. You'll need a queue depth of 1 for every 400 to 800 IOPS you require, up to a maximum queue depth of 64. Consult the application documentation on how to configure this, as it's different for every application. Now, if you need higher throughput as opposed to higher IOPS, there are different recommendations. When you need high throughput, the best thing to do is to increase the I/O size to 256 kilobytes or greater. Also, increasing the OS read-ahead cache using the command line here will improve streaming I/O, especially if you're forced by the application for some reason to use small block sizes. Please note that we intend for the values on this slide to change over time as we improve persistent disk. The concepts described here will stay true, but consult the persistent disk documentation for the latest values. Another performance tip is around CPU. It's important to note that Google does not require a special instance type for getting high I/O. Larger VMs can get higher I/O by virtue of their more CPUs. A quick rule of thumb is to have one CPU core free for every 2,000 to 2,500 IOPS. As with the last slide, we intend this value to change as well over time as we make persistent disk better. Please consult the documentation for the latest value. Now, like I mentioned before, the larger a PD volume is, the more I/O it can do. So you never need to create many small volumes and stripe them together to increase performance. For example, a 1 terabyte volume will give the same performance as 10 100 gigabyte volumes striped together. And because we support volumes up to 10 terabytes in size, you don't ever need to stripe volumes together for space either. One data volume per VM is all you should ever need. Last performance tip. Sometimes people mistakenly think there's a need to pre-warm PD volumes. This is not needed, as PD volumes are performed consistently over time and are ready for their top performance as soon as they're created. Trying to pre-warm the volumes will only waste time and resources. PD volumes are also consistent relative to one another. There's never need to create many volumes, test their speed, throw away the ones you don't like, and keep the ones you do like. All the volumes of the same size and the same type will perform the same way. So now let's move from performance to protection. As we know, mistakes can happen, bugs can happen, and disasters will eventually happen, all of which can cause you to lose data if you don't take the proper precautions. When using PD, please take snapshots frequently. This will protect you against software and human errors that may delete data, and will also protect you from physical disasters. Because PD has differential snapshots, snapshot time and storage costs will be as efficient as possible. Also, snapshots will never perceptibly pause your VM and will not affect your applications. Moving away from PD for just a second, remember that local SSD does not have the snapshot feature, so make sure when using local SSD, if you need to protect some of that data, that you use some backup mechanisms supported by the OS and application. The last tip we have is about moving data. If you want to move persistent disk volumes from one zone to another zone, the easiest thing to do is to snapshot the PD volume into Google Cloud Storage and then restore it to the other zone. Now, if you need to move individual pieces of data from a non-PD source into a VM, into the PD volume, you can use the gcloud push command. To do the reverse and move data from a PD volume in a VM to a non-PD destination, you can use the gcloud pull command. So here's a quick summary of what we discussed. First, Google's block storage is unique in its combination of reliability, security features, and performance consistency. Second, Google's block storage options offer a unique continuum with all of the block storage options scaling performance with volume size. This way, the block storage options can be compared in an apples-to-apples manner, and decisions can be made simply, mostly based on the performance needs. Third, all of the options have a simple price per gigabyte, never charging extra for I/O. You can always be assured that each option's complete cost is understood up front with no surprises later on. Lastly, please refer back to this presentation for our best practices on how to choose between block storage types and how to optimize I/O. If you follow these guidelines, you should be able to get consistently superb performance at the lowest possible price. I encourage you to try out all of our block storage options, especially the 2 new ones we're so excited to announce here. If you'd like to follow up on any of this presentation for more detail, please contact me personally or contact the bigger teams using the forms listed here. Thank you very much for watching.
At Udacity, we're reimagining education by teaming up with industry leaders like Google to create courses on the cutting edge of technology. Today, we're announcing 4 new courses developed with Google in Android, Cloud, Web Performance, and UX Design. For more information, visit udacity.com/Google.
Hi, I'm Rick Borovoy. I'm the lead product manager for Google Play for Education.
And I'm Julie Farrago. I'm the engineering manager for Google Play for Education.
So, I get you. You want to change the world with your mad software skills, but you don't know where to start. So in 5 minutes, we're going to pitch you on a rock your paradigm educational Android app that we are dying for someone to build that could transform a classroom into an amazing place for collaboration and exploration.
Really excited about this, but we're not just going to tantalize you with exciting ideas. We're actually going to teach you about the Google APIs that you can use that makes it easy to build these apps and really any app that you're excited about. And we've actually already created the Google Play for Education store that you can put your app there and super easily get it into the hands of teachers and students. So the biggest thing that needs to be done is just building that app. So let's learn how.
We want you to build an app that nails one of the most awesome, most popular collaborative tablet use cases in school. It's called the photo hunt, or sometimes the photo safari. As in, like, I'm the teacher, hey, kids, for our unit on energy conservation, go grab your tablets and take some pictures of examples of how we're wasting energy at school. Now, it's easy, and it's really empowering for kids to go and find some examples of waste with their camera, like a door left open when the air conditioner's running, or school buses belching carbon monoxide while they're sitting there waiting for the kids to come out, or an entire lab's worth of computers powered on but sitting unused.
Just turn them off.
Now, there are existing apps for this that support the basic sort of photo collection reasonably well. But as awesome as kids taking pictures around the school is, it's actually not the magic moment of the photo hunt. The real magic happens when the kids gather back together with the teacher and they look over what they've collected and they start talking about it and start pulling out ideas and really getting sort of focused on what they've collected. And it turns out that that focus can be a challenge. Teacher may want to sort of point out a couple of apps, a couple of photos, but the kids are wandering off. In fact, a teacher once told me that kids have like a superhuman ability to be on the wrong page at like the wrong time. So how about building something straight into the app, the Photo Hunt app, that lets a teacher walk students through particular photos so that they can control the focus and really make an awesome conversation?
Totally. So I love this idea. I think I get it. Let's walk through how to actually build it. So first of all, if you want to use the tablet as a camera, or for that matter, an audio sensor or a video recorder, please actually check out the Google Android Media and Camera APIs. These are going to give you all the tools that you need to capture and record multimedia so that when you're building for a tablet, you can actually take advantage of the awesome mobility and multimedia of that tablet. We want apps that just shine on tablets that you just couldn't do otherwise because the tablet form factor is so fabulous, and we think that you can build apps that take advantage of that. So, all right, let's say you understand how to take photos. What you're going to need is a source of identity. And when kids are gathering and commenting on photos, they actually need a way to say who they are. And I'm going to go a little melodramatic here, but bear with me. Because the thing that you want to be careful of is that identity is the first place where apps go to die. I know, intense.
Wow.
Yeah. But so we went to a classroom earlier this year in New Hampshire, and what we saw was 20 pages, 20 plus or minus, stapled together, mapping app name to kid name
to username to password. And there is nothing that will make a teacher abandon your app more quickly than wasting her, or even more importantly, her students' time. And requiring unique usernames and passwords for all of these students, it's just a waste of time. So you can make this easier with Google Login. So with really minimal effort, you can get a trusted registration system that's familiar to users, it's consistent across devices, and it just lets you skip all that time-intensive username and password entering, and it makes registration faster and more secure. And the awesome thing about this is that all the students in your classes are actually going to have Google Apps accounts. They're going to have Google Login available to them because you need it in order to use Google Play for Education. So 100% of those students are going to be able to click that sign-in button and use it for registration, use it for login, and just go. So no login, no password. Happy teachers, great.
Amazing.
Amazing. So now the next question is, how do we really get to the heart of what Rick was talking about earlier? How do we get students all talking about the same thing on the same page at the same time? And for that, we're actually introducing a new API, a new Android API, that lets an app go into lock-to-app mode. This API actually needs to be authorized through device management, so you want to be thoughtful about how you use it, and use it in apps like testing apps or classroom management apps, or in this case, a task-focused app, where you really want to keep all the kids on the same image, keep the discussion focused, and keep kids from kind of like getting distracted and going off to another place. So now what you can do is you can build this special discussion mode into your app so that when a teacher, for example, swipes between photos, the students' tablets follow along. So they can all look at this one picture of the exhaust pipe and all the gas coming out of it. And because you've used this lock-to-app API, all of the basic navigation buttons and the notifications are turned off. So they can't accidentally or intentionally switch out of the app and wander off. So you can find out more about this in the Android L preview release.
I love the idea about discussion mode. So that feels like that completely nails the Photo Safari use case. But I'm thinking, if you give kids this awesome power to collect these photos and discuss them and start to sort of think about the world around them, they're going to want to start arranging them in a way that represents the world around them. Like, they're going to want a map. Of course, we love maps at Google. But we also think it's an amazing way for kids to build together, to work together, to build an understanding of the world around them, and maybe even to use a map to advocate for like positive social change.
Totally.
Remarkably, there isn't a tool that makes this really simple for kids to do, to decide what matters to them and map it out. For example, a tool that would help our conservation-minded kids. Maybe they want to make their school more bike-friendly or find out how bike-friendly it is. So they want to map the surrounding neighborhood for sort of bike-friendliness. Maybe they want to map out 3 things. Where are bike racks? Where are bike lanes? Or where are like bike hazards that they should be aware of? So imagine a tool that you sort of let kids decide those 3 markers, fan out with their GPS devices, start marking on the map where those things are, take some photos, and then just like magically have it gather all together so they can study it themselves and then share it with other people.
I love this app. I want to use this app. It sounds fabulous. And the big question is, how do you do it easily? And the Google Maps API actually makes this really easy. You can build this functionality on top of Google Maps, and you can get a bunch of gnarly engineering work for free. So you can get a shared, cloud-synced set of map markers that are contributed to by a group of users. You can get GPS integration, fantastic and familiar touch UX, maps that span the entire Earth, and of course custom map markers. In fact, actually one of our schools earlier this year did this amazing experiment, amazing project, where kids went around their town and they took pictures of streetlights. Streetlights that were working, streetlights that are out, where they needed more streetlights. And using that, they actually made a shared proposal to their local town government about what they should do about their streetlights. And it was fantastic. But the challenge was actually that it required a ton of IT support and, of course, a ton of teacher support. You want the teachers supportive, but you don't want them to have to work long weekends in order to enable this project to happen. And so what we really need here is we want students all over the country to be able to do these types of things, teachers to be able to do it without having to invest oodles of time. And for that, we need an app, and we're hopeful that you'll build one.
Boom. Awesome. All right, so now we've got this app that lets kids collaboratively explore, document their world, organize it, but I don't think we're done. I think that the missing piece is that these kids want to do more than just collect photos. They want to collect data. Maybe it's not just the kids that want to collect data. Maybe it's the teachers that want to collect data. I have not met a teacher that isn't sort of really passionate about getting their kids to be excited about collecting and analyzing data. It's an ultimate 21st century skill. But there's a funny truth about how it often goes down in schools. It often looks something like kid in the back measuring the sort of the pH value of the puddle. And I think that's just less exciting than maybe teachers and we all sort of hope it's going to be. Kids somehow figured out that this isn't the way to a Nobel Prize. And that it's not the most exciting use of data. So what if we just took a lot better advantage of what we have to offer here? You don't just have one kid and one scientific instrument. You've got a whole classroom worth of tablets. Isn't there some cool way we could combine these tablets together into some sort of super scientific instrument? You ever been to the Very Large Array in Arizona?
I have not, actually.
It's totally awesome. It's like the modern day Stonehenge. There are all these radio telescopes. I'm not talking about that all work together. I'm not talking about making radio telescopes work together. But what if you could take 9 tablets and put them together in an array and then use that single sort of big array to go measure sound in the school? Maybe you take it into a classroom and you look and see how the sound travels in there. Or maybe you take it into an auditorium and you look and see how the sound travels there. Or maybe you take it out to the field and you look and see how sound travels there. And maybe you ask this question, what is the loudest room in the school anyway?
I love the vision. I love the vision of data fluency and helping teach our kids that. It's fabulous. And also creating these cool scientific instruments. And the question is, how do you as a developer enable this type of data fluency, this cross-device data gathering and analysis and collaboration? And you already know how to use the Android Media APIs because you've already done that, with the photos. But let's look at the APIs for data collaboration and for collection. So as it turns out, there are actually more than 30 million active apps for EDU users. These students and teachers use tools like Google Docs and Google Spreadsheets to create content and collaborate around it all the time, which is exactly what we want to do. So our Spreadsheets API offers the ability to create spreadsheets, add rows of data, manipulate individual cells of data, and basically you can use it as a place to store all that awesome audio data that your kids are gathering. And then those kids can go into Google Drive, they can collaboratively create charts and understand how sound travels through and compares across different locations. And then you can even do more things like use the Drive APIs for Google Docs or for Google Spreadsheets, which are all very similar. So we're really excited if you also checked out the developer site for the Drive APIs.
So bringing it all together here. Our goal with Google Play for Education, for all these awesome Google APIs, is to make it really easy for you to build some apps that make awesome collaborative learning activities easy for kids. And then to make it easy for schools to find those apps and just start using them right away.
Absolutely. So we want it to be easy for teachers, easy for you, easy for students, easy, easy, easy. So please go do it. We cannot wait to see what you're going to build.
The Android App Sandbox does a great job of keeping apps separate by default, but what can you do when the provided level of isolation doesn't match your application's model? Hi, I'm Jeremy Condra, and in this video we'll be talking about how you can use the Android platform support for different isolation models to make your app more robust and more secure. What you see here is a loose model of some of the most important layers of isolation Android provides. SE Linux protections that separate applications from system components. You see Linux user or UID separation, which keeps separate apps separate. And you see the process level separation between app components. So let's start off talking about process separation. When Zygote spawns an application, that application generally gets its own process. This prevents other applications from modifying its memory and isolates one app against a crash in another. So the fact that your app and someone else's terrible app are on the same phone doesn't impact your app's experience. It also isolates the application from system components and system components from each other. Zooming in a little bit, we can see that two apps which don't share a process can still communicate in a variety of ways, such as Binder or the intent system, or over legacy mechanisms like pipes or sockets. The thing to take away from this is that process separation isn't very restrictive. Since you can still talk across these boundaries, it's easy to get good isolation with little cost. And of course, when we're talking about isolation here, what we really mean is that if one process dies or gets compromised, other processes can continue to run correctly. So that's the default model, and it's a good one for a huge variety of apps. But what happens if that basic model doesn't give you the isolation you need? What do you do when you want to isolate one part of your app from another, like say a crashy service or network-aware component from something that handles keys or other sensitive data? Fortunately, Android's got your back. Activities and services both support the Android process attribute. This allows you to specify exactly what process you want to run your code in, and getting a new one spawned for that component if it doesn't already exist. In this example, we have a service that we don't want taking down the rest of our app if it crashes. By specifying that it should be run in a process called :crashy, we make sure that Android will run the service in a new process created explicitly for this purpose. Once you're done, the set of processes looks a little more like this. Because :crashy and the app process are separate, crashy can go down and not take down the rest of the app. You can also use this to better restrict your IPC endpoints. In this model, :crashy won't wind up indirectly talking to the IPC endpoints needed by other components. So why do we need the other layers of isolation? Why not just use processes for everything? The reason we don't use process separation for everything is because it doesn't come with a different set of persistent credentials. So while another process might not be able to modify your memory, if it has the same UID, it'll have the same permissions, it'll be able to read and write the same files, etc. As a result, besides being separated by process boundaries, Android applications are also generally run as their own user. This forms the basis for the app sandbox, as well as the separation between application home directories. In this way, Android provides a kernel-enforced guarantee that the application's data can only be modified by that application, unless the app decides otherwise. This gives a ton of flexibility and control to the application. There are two exceptions to this rule that every app gets its own UID: shared UID and isolated process. Let's talk about shared UID first. In this diagram, apps B and C are marked shared UID, while app A is not. Applications marked shared UID and signed with the same keys are able to do almost anything the other can do. So from a security perspective, marking two applications shared UID means that they can be treated as essentially the same app. And that's sometimes useful to help break up applications or provide access to resources in interesting ways, but in security we more often get the opposite question. What do I do if I want to break one app into several security contexts instead? And that's where isolated process comes in. To see why it's valuable, let's return to the example of the crashy service. Especially for native code, it may not make sense just to isolate yourself from the possibility that your code will crash. If the code is really suspect, like certain kinds of renderers or media codecs, you may not want to have very much to do with that code at all. In fact, you may want to run it in a completely separate process and user, essentially as its own separate app. And that's exactly what isolated process does. The net result looks something like this, with app A split into two components. Each is in a different user and process, meaning that the isolated part of the application is as separate from app A as other apps are. So, when should you use process, and when should you use isolated process? Use process when the isolated code is pure Java, when it doesn't contain an interpreter or similar, or when it needs to interact with other processes on your behalf. Use isolated process when the isolated code is native code, when it performs complex operations like rendering or encoding, when it contains an interpreter or JIT, and when it doesn't need to run as your user. That's it for isolation for Android app developers. Be sure to check out the other videos in the series, and thanks for watching.
Hi everyone, my name's Max and I'm an engineer on the Chrome team. Today I'd like to show you my favorite way to build amazing Android and iOS applications. Using web technologies, you can install Chrome apps on mobile devices. First though, a bit of background. Many of you are aware that you can build applications for Android and iOS that heavily leverage the WebView component, to the extent that your application is almost entirely built with HTML, JavaScript, and CSS. Now, to be clear, these are apps that you still install from the App Store. They have an icon on the home screen and full access to device capabilities like any other app, but they're built using web technologies. We often call these types of applications hybrid, because they're a blend of web and native technologies. On Android, one drawback of hybrid applications is that WebViews older versions of Android can be a bit limited. Chrome has seen a ton of improvements on Android, especially over the past year. But running on old web views means that you can't take advantage of those improvements. That's where the Intel Crosswalk open source project comes in. The Crosswalk project provides an embeddable Chromium web view for Android versions as far back as Ice Cream Sandwich. Using Crosswalk, hybrid applications can run on the latest version of Chromium, regardless of Android version. Similarly, on iOS, the web view has seen great updates since version 6, and now with iOS 8, the web view will match the full capabilities of the Safari browser. Now, what does this all mean? Well, it means that it's finally possible to build hybrid apps that use a modern web view and run on almost every Android and iOS device released within the past 3 years. Now, here's an HTML5 canvas-based game called Pop Pop Win, running on the Crosswalk web view. Smooth as silk thanks to a hardware-accelerated canvas. This wasn't possible a year ago. Nowadays, hybrid apps can use technologies like WebGL, WebRTC, WebAudio, accelerated 2D canvas, and modern web toolkits like Polymer, all at maximum performance without the need for browser polyfills. And it gets even better. Hybrid applications are not limited to just using web APIs. Since these apps are also native apps, you have full access to all Android and iOS device APIs, such as identity, cloud messaging, notifications, payments, Bluetooth, sockets, cameras, and much more. Here's an app written using Polymer, showing off some nice animations running polyfill-free. So it's clear that there's a lot to like about hybrid app development. But how do you get started? Well, over a year ago, our team started contributing to the popular open source hybrid application toolkit, Apache Cordova. We also took a look at the amazing work being done with Chrome packaged apps for desktop. So, in January, we released a developer preview of a tool called CCA, which allows you to build hybrid mobile apps using the Chrome packaged app format. Now, one of the most convenient aspects of web development is its extremely rapid workflow and short feedback loop. No compiling. You can just make a change and see it right away. Sadly, with hybrid apps, like all native apps, you do have to wait for compilation, so you lose that rapid feedback loop. Our companion tool, the Chrome App Developer Tool for mobile, changes everything. Let me show you how it works. I've connected to my device via USB, but you could also use Wi-Fi. On the device, I'm running the app dev tool. Now, I can type a command to push my app to the device and watch for changes. You can see that the app is transferred to the device and launched within the app dev tool. Now, that settings button in the top right corner, it's a little small, so let's make it a little bigger. I can open up the CSS file, and once I do, we'll scale it up by a factor of 2. Once that's done, I'll save the file. The change has been detected and pushed to the device, and the app is relaunched. The settings button's bigger, looks a little better, so we'll have our designers make us a bigger icon. Now let's go into that settings menu. Okay, it's not working, so let's look into that. I know the click handler's in weather.js, so I'll open that file. Right, I commented that out earlier, so let's uncomment that and save the file. Once again, that change is detected, and hopefully once it loads, settings now work. No recompilation. I can continue to iterate on my mobile app smoothly and instantly. We're also working on supporting this same edit refresh workflow on Chrome Dev Editor, which you can learn about during a live talk here at Google I/O. So there you have it. Chrome apps are a great way to target many platforms, including Windows, Linux, Mac, Chrome OS, Android, and iOS. With Chrome apps on mobile devices, you can leverage all the latest and greatest hybrid application techniques easier than ever before. We're excited to see what you build.
Mobile developers and designers use different approaches to achieve the same goal: creating 5-star apps that users love. While both development and design approaches are essential, they are usually considered separately. In User Experience Design for Mobile Developers, you'll learn how to integrate design approaches and techniques into your mobile development to build world-class apps. This is a design course for developers who want to give their users a great experience. For more information, visit udacity.com/Google.
Hi, I'm Mike from the YouTube desktop team, and I'm going to talk about how WebP helps to make YouTube faster. You may not realize it, but YouTube is one of the largest image hosting websites, serving tens of billions of video thumbnails every day. On many pages of YouTube, thumbnails can contribute up to 80% of total size. In fact, a typical page can easily contain more than a megabyte of image data. All those thumbnails add up. Client-side techniques like lazy image loading helps us to optimize rendering time, save bandwidth, and mitigate extensive backend load. But until recently, we had no way to significantly optimize the images by themselves. Fortunately for us, it turned out that another team at Google has been working on the WebP image format that delivers a significant improvement in image size, up to 30%, while maintaining the same quality, so we decided to give it a try. By the time WebP wasn't a complete stranger to us, as we already used it for image sprites, but all the data we had was relevant only to lossless compression. So, earlier this year, we ran an experiment to encode a fraction of video thumbnails hosted at YouTube in lossy WebP. We aimed to measure the bandwidth savings and confirm that WebP helps to improve rendering time of web pages. Knowing about the benefits of WebP, we still had to consider that introducing a new image format is not free. At a minimum, it meant that we had to store multiple variants of the thumbnail, WebP version for clients like Chrome or Android, and JPEG for all others. In addition, we had to remember that on the client, WebP does cost a little bit more to decode. So we wanted to see if the benefits outweighed the cost. This experiment displayed an average savings of over 20% of transferred bytes and up to 10% improvement in page rendering time, which translates to a huge improvement in overall user experience. Not to mention that on the mobile clients, like our Android application, bandwidth savings were particularly helpful, as images are a significant contributor to data usage, even compared to video. So we've got a lot of great feedback from the users experiencing a smoother and faster UI. Based on these results, we decided to start encoding new thumbnails in WebP along with JPEG, and as a result, WebP currently contributes to over 10% of all YouTube image traffic, saving terabytes of bandwidth every day, and we expect it to become as popular as JPEG in the near future, especially as we enable it on our iOS client, TV and console clients, and allow third parties to use it too. We're very happy with WebP at YouTube, and I encourage you to consider it for your site as well. Check out the WebP homepage to learn about the format and on how to get started. Thank you.
Hi, my name is Pong Ying, and I work on the Google Wallet team. I'm here to talk about the Wallet Objects API for native Android. I used to have a keychain full of these, different loyalty cards to take advantage of discounts and rewards. And these, I usually just end up leaving at home, unfortunately. I could have saved so much money. I don't think anyone but the most dedicated savers carry around all of their loyalty cards and offers all the time. To make it easier for everyone to carry around everything, Google provides the Wallet Objects platform. Wallet Objects is the concept of digitizing and storing all of your items in your wallet in the cloud and making them accessible from anywhere. And combined with a mobile app that has contextual information, we can make these items smart, so they appear when you need them. For example, I have a test object with the geofence of this building. Whenever I enter the geofence, my wallet object appears in Now, and it can notify me that it's available to use through an Android system-level notification. And we fine-tuned the contextual triggers so that these notifications won't trigger when, say, I'm just driving by the office. This functionality allows developers to do interesting things. Let's say you have an existing mobile user base, and you want to convert users from mobile to another physical medium. One example, it's a mobile game, and you want to convert the user to a console. In the game, you could add a geolocated wallet objects offer for a console title to incentivize user action. With the offer saved, the next time the user goes to a geolocation you specified, whether it's Fry's, GameStop, or Best Buy, or some other retailer, Wallet will notify the user that the offer is available to use. They buy the title, and boom! Now they're playing your game in the living room in addition to on mobile. Wallet objects can help with retail as well. Instead of all the coupons and offers that you need to remember to bring when you go shopping, you should just be able to save those offers from an app or from the web and have them notify you when they're relevant. Let's say I walk past a store in the mall and my phone notifies me that I have a coupon to save $20 off a purchase. I'm going to try to take advantage of that savings and check out if there's anything in the store that interests me. Cool. So you want to integrate, right? Let's go over how to create and save an object. The wallet objects flow is simple. You define the data representing the object and add a Save to Google button that calls our function createWalletObject with the object to save. The rendering is based on a template that gets populated by the information you define. To reduce redundancy, WalletObject stores data in two forms. It's somewhat analogous to programming. The class data represents information that's common to all users, like merchant details. The object data represents information that's specific to a single user, like a specific discount or a barcode. All this information is merged, then filled into the template. We have a number of fields here, and in this template, and any section without data is going to be hidden. Let's check out the code. First, we need to create the class. This code defines an offer class. We set the merchant and some offer details, some images, some subsections, and lat-long geolocations. Finally, we insert the class. Inserting the class needs to use a server-side REST API. Once you've created and inserted the class, you can create the object data in your Android app. This may look like a big wall of code, but it's your standard builder pattern defining an object. Here, I'm referencing a class I just created. I'm overriding some class fields and defining information that's specific to the user, such as barcode and messages. Once I have that, we can tie the object to a createWalletObjects call and tie that to an image button click, and we're done. So if you want to remind and incentivize actions for your users, integrate the WalletObjects API into your app today. For more information on the integration and a step-by-step tutorial, check out our developer documentation. I can't wait to see what you build. I'm Pong Ying, and thanks for watching.
Would you like to learn more about kiosk apps? I'm Vidya, and I'll help you explore what kiosk apps can do and how you can build them. Hang on tight and enjoy the ride. Unleash the power of kiosk apps with me. First, let's see some single-purpose devices in action. Although you might not even realize it, these devices are all around you. Here is a restaurant cafe with an interactive display showing the menu and specials for the day. A customer can walk up to the display and scan the QR code for a chance to win a meal. You might also find a device at a doctor's office where patients check in and wait their turn. Many grocery stores now support self-serve point-of-sale kiosks where customers can scan items and pay for them. Self-serve kiosks are also appearing at movie theaters where guests can purchase tickets. An innovative application is an integrated library catalog and Wayfinder kiosk showing the map of the library building. A guest can browse the collection, determine if a book is available, and locate the section that contains the book. These devices are also used in educational environments. Here is a 5th grade class where students are taking online tests in a lockdown secured environment. All of the single-purpose use cases you just saw could be powered by kiosk apps running on Chromeboxes. The possibilities are limitless. Gaming consoles, photo booths, displays in public transportation, billboards, ATM machines, all of this can be powered by kiosk apps. Did you know that the displays and registration kiosks at Google I/O have also been powered by kiosk apps on Chromeboxes? You may ask, why would a Chromebox be the best choice to run a kiosk? Well, there are many reasons. Chromeboxes are fast and secure. You no longer have to worry about OS patches or install antivirus software. OS updates are taken care of automatically for you. Further, the OS and the kiosk app running on it have independent update cycles. So as an app developer, you only have to update your app and Chrome OS keeps the rest fresh. And with the Chrome Management Console, you can easily deploy and remotely manage a fleet of Chromeboxes that may be distributed around the world. A kiosk app is just a Chrome app with HTML, CSS, and JavaScript. You can build powerful apps that interact with network and hardware devices, media tools, and much more. You can enhance the user experience through touch with virtual keyboard support and by listening for mouse and touch events. For example, you can build a point-of-sale kiosk app that uses the Chrome USB API to communicate with USB devices like barcode scanners, credit card readers, and printers. You can also use the Bluetooth API to talk to Bluetooth devices. However, there are indeed some differences between kiosk and regular Chrome apps. Now consider the display at an airport terminal using an interactive kiosk app. The app is set to auto-launch when the Chromebox first boots up and always runs in full screen, providing a dedicated user experience. Here, I check on the status of the flight from Minneapolis on one of the displays and click on Southwest Flight SWA 3236 for more information. The app updates the flight tracker with the route map of that flight. I realize that the flight has been delayed and want to get something to eat. I can scan the QR code on the display and grab the flight information for me to look at on my phone while I'm in transit. I now click on Dining, which brings up a map with the nearest places to eat along with restaurant ratings. I decide to go to Fresh Roll Vietnamese as it's got the best ratings and is close by. Google Maps gives me directions to help me get to the restaurant. As a bonus, I can also redeem a coupon for a combo meal if I scan the QR code on the display with my phone. I can also click on Weather, get the 5-day local weather forecast, and get some fast facts about the airport. It's interesting that there were 31,000 check-ins today. Lots of travel indeed. You might have noticed that when this app is running, the user cannot exit the app or switch to another task. However, the app could offer a logout button that allows the user to close all windows and terminate the session. To convert a Chrome app into a kiosk app, all you need to do is add the attributes kiosk enabled and kiosk only to the manifest.json file to ensure that the app will only run in full screen using single app kiosk mode. After writing a kiosk app, you can publish it to the Chrome Web Store. You can either monetize the app or just use the app in-house. You can also test the app in single app kiosk mode by firing up a browser and add the kiosk app at the Chrome extensions page. Installed kiosk apps will now appear in the tray under Apps in the login screen. You can then manually launch the app from the tray and test the app. As an app developer, you can choose to download and cache any assets you need so that the next time your user launches the app, the cached assets are available immediately, even when offline. The Chrome Management Console can then be used to deploy an app to a fleet of Chromeboxes. There is also an option to automatically launch the app on the Chromebox when the device first boots up. We're excited to see what kind of apps you will build. You can take it for a spin today by going to the links here. There are sample kiosk apps that you can play with. Let us know what you think, and thanks for watching.
It's undeniable. Website speed is a feature. Web performance optimization, developed with Google, explores performance patterns for world-class site speed. Dive into the critical rendering path, uncovering how browsers convert HTML, CSS, and JavaScript into actual pixels on the screen. You'll learn how to leverage recommendations from page speed insights and data from Google Chrome's developer tools to immediately boost website performance. For more information, visit udacity.com/Google.
Speed matters for applications. You could be doing intense image processing, complex scientific computing, or just delighting users with an immersive game. Portable Native Client brings speed to the web. I'm JF, lead engineer on portable code performance, and I'm going to walk you through how Pinnacle delivers the speed your users demand and you deserve. Going faster allows us for better games, makes users wait less when they interact with applications, and reduces the amount of energy used by the device. And as we all know, longer battery life means more game playtime and happier users. Modern processors have a treasure trove of performance that often goes unused. Let's explore a few kinds of parallelism that unlock this performance. One source of parallelism is at the task level, where independent work is conducted in parallel on multiple cores. This is achieved in Pinnacle through POSIX threads, which have been available since launch. Another type of parallelism is at the instruction level. Modern CPUs fetch an instruction stream and decode, reorder, schedule, and execute instructions using a plethora of functional units, all in a very deep pipeline. This parallelism allows the CPU to execute multiple different instructions at the same time and is mostly free for programmers. Typically, this has been the realm of compile engineers, but it turns out that those functional units are just there waiting to do something, and some of them are pretty powerful, yet usually go unused. If you don't use them, then your CPU isn't showcasing its full power. It's leaking power instead, trickling in small amounts of work instead of going to sleep. Let's zoom into one of the previously mentioned functional units. Programming languages typically expose scale instructions, shown here as a stream of 4 instructions. The CPU loads one input datum per instruction and then executes one instruction to generate one output datum per instruction. This is a scalar way to do computation, which gets the job done, but it doesn't fully use a CPU's capabilities. CPUs have more than just load, store, and scalar functional units. And that's where data parallelism comes in, where the functional unit takes instructions and performs the same work on multiple sources of data per instruction, generating multiple output data per instruction. This single instruction multiple data model is called SIMD. There's still a single instruction stream, but multiple pieces of data are fetched at the same time, operated on, and multiple corresponding outputs are created. The SIMD functional unit can perform 2, 4, 8, 16, or more operations in a single instruction. Let's look at some code. SIMD is usually expressed through architecture-specific assembly code or intrinsics, SSC and AVX on x86, and Neon on ARM. Pinnacle expresses SIMD using portable intrinsics that are very similar to those used on x86 and ARM, and those intrinsics lower to efficient code for each target architecture. You can see a great example of Pinnacle in action by taking a look at Google Plus Photos editor. The team took existing photo filtering software written in C++ and were able to use it directly in the browser. Photo filtering typically uses many forms of parallelism, including SIMD, and they operate very fast on large images by using fairly complex imaging pipelines, most of which are inscrutably complicated to me. But hey, they work and they're fast. Those complex pipelines deliver beautiful results and allow users to add some magical elements to their pictures. Using portable SIMD intrinsics was minimal effort on the photo team's part because some of their filters use a language called Halide, an open source language developed at MIT, which simplifies image processing by decoupling the algorithm from its schedule. Sometimes it's more efficient to compute images breadth first. Sometimes it's better to fuse value computations, use sliding windows or tiles, or even a mix of techniques. SIMD plays a small but critical part in using all of the CPU's capabilities, and Halide's biggest strength is in expressing image processing algorithms and mapping them very efficiently onto the underlying machine, as shown here. Applications which are suited to Halide's computational model should definitely consider using it. Here's another usage of SIMD as well as threads on the web. Folding at Home does protein folding for medical research to help cure diseases like Parkinson's, Alzheimer's, and cancer. Protein folding is incredibly complex, and the research greatly benefits from the web's huge reach. Merely using Pinnacle over the usual web platform increases performance by 2 to 4x. Using threads is a multiple that's roughly linear in the number of CPU cores, and using SIMD is yet another 2 to 4x. The Chrome browser enables these great speedups through Pinnacle with technologies like threading and intrinsics. That doesn't mean that your development process on other browsers have to suffer, though. Pinnacle offers a powerful toolchain based on LLVM, and we support generating Pinnacle executables as well as JavaScript ones, so you can fold proteins in all browsers. This is done through Pepper.js, which relies on mscripton. While this fallback comes with some caveats, we strongly believe in evolutionary improvements to the web platform as well as revolutionary ones, such as what I've just presented. This completes our brief tour of some of the latest performance improvements we've brought to Pinnacle. SIMD will be available in Pinnacle as part of Chrome 37 to be released at the end of August. For more, check out our site, gonacl.com. We're just getting started with performance improvements to the Pinnacle platform. On the SIMD side, performance will improve significantly over the next few releases, and we'll add powerful new intrinsics as well as fun features like auto-vectorization. It's now your turn to use all this power on the web. Thank you.
Hi, I'm Alex Nixay, a senior engineer at Google. I lead the front-end team at YouTube. Over 6 billion hours of video are watched each month on YouTube. That's almost an hour for every person on Earth. At YouTube, we want to get that video to you as fast as possible. Since last year, we've reduced the time to start video playback by over a second. That's 40% faster. So where did we start in this optimization? We analyzed data from our real user monitoring, and we broke down the time it takes to start playback into critical stages. And we realized that one of those stages is the same for every playback, initializing the player. So we asked ourselves, what if we reuse the same player? The answer? It's faster. By maintaining a persistent player, we're doing less work on each navigation, and by doing less work, we're making each playback start sooner. So how did we do it? We built a new JavaScript framework for page navigation. Structured Page Fragments, or SPF for short, is a lightweight framework that handles navigations and updates to page sections. When someone first arrives at the site, the content is sent from the server and rendered normally. We call this static navigation. But when going to the next page, only document fragments are sent and page sections are updated accordingly. We call this dynamic navigation. So what does this give us? It gives us the fastest possible rendering time for that first page, leveraging all of our existing performance techniques. And it additionally allows us to maintain a persistent, responsive interface using the same rendering code as before. This all creates a better user experience. No one is staring at a blank white screen waiting for a page to load. But what about the developer experience? This framework allows us to maintain productivity by using the same code for both static and dynamic rendering. And it gives us the flexibility to use any server-side language and template system we want. It also supports sending data for use in client-side templating. So let's take a look at how it's implemented. We'll start with requesting content. Here's a link. Clicking it will trigger a static navigation request. Here's that same link using SPF. Clicking it will trigger a dynamic navigation request. As you can see, we use progressive enhancement and a simple syntax to enable SPF for supported browsers. Now let's look at sending that content back. Here's the HTML of a response for a static navigation. In this example, we use a common layout of upper masthead, middle content, and lower footer. Here's that same response using SPF. Only the fragment for the middle content is sent because the masthead and the footer don't need to change. JSON is used for transport during dynamic navigation. As you can see, the fragments for static navigation map directly to those for dynamic navigation, and this makes implementation very easy. Now, we won't cover them in depth, but SPF has several optional features that can help you improve your site. In some web apps, HTTP caching is inappropriate, but SPF allows you to cache responses in client memory according to your application-specific parameters. SPF can also prefetch responses automatically or manually to predictively boost performance. And SPF supports streaming multi-part responses in chunks to enable on-the-fly processing. This speeds up navigation by starting the rendering early. Now let's take a brief look at when YouTube launched these features and how they each impacted performance. Here's real data from YouTube's Real User Monitoring. I've graphed the median time to start playback for both HTML5, Flash, and the traffic-weighted composite of both. But for clarity, we're going to focus on the 5-day moving average of the composite. Now, when we first introduced dynamic navigation between consecutive video pages, we didn't have a persistent player yet, and we only saw a minor reduction in overall time to playback. Despite this, users reported that the site felt faster. This showed us that there are some very real user-perceived performance gains that dynamic navigation brings. Now, when we added that persistent player between consecutive video pages in Chrome, we reduced the overall time until playback by 8.5%. Expanding all supported browsers was another 9% improvement, and enabling on-the-fly processing over HTTP chunking yielded a 5% speedup. By defaulting supported browsers to our HTML5 player, we reduced our overall player initialization time and generated an 8% improvement. And then by dynamically navigating between all pages on the site, not just consecutive video pages, we were able to preemptively create a persistent player before it was even used. And this reduced our overall time until playback by 7.5%. When we expanded our default HTML5 player to both videos with and without ads, we yielded a 2% improvement. And finally, enabling on-the-fly processing over Speedy yielded a 4.5% speedup. And that's how we made it 40% faster to play a video on YouTube. So what's next? The great news is that we've open sourced the framework, so you can use SPF on your site. Check out our project page on GitHub to learn more. Thanks for watching.
Hi there, I'm Emmett, a designer on the Android Wear team. In this video, I'll be introducing some of the main principles of designing for Android Wear. Let's start with a brief introduction to Android Wear. Android Wear is an open software platform for wearable devices like smartwatches. Android Wear can run on many different device types, even ones with square or circular screens. The UI is really simple and content is optimized for these small screens. Very simply, the core of the Android Wear UI is an automatically ranked stream of cards. It combines sources like Google Now, Android phone notifications, and contextual apps running directly on the wearable. Developers can create cards that appear right in this stream. At any point, I can swipe left to drill into more detail for each item, and swipe right to dismiss cards. We've also included the ability to speak to Google. Users can just say, "OK Google," to search the web and ask for answers, and also perform voice commands that we call actions. Developers can hook into these voice actions, which means that users can speak directly to your software. We'll look at the UI in more detail shortly, but first let's step back and think about some of the design implications of these devices. Wearables provide a brand new set of design opportunities and challenges, so it's important to be clear about just how different they are compared to other devices like phones or tablets. Let's start by looking at what exactly Android Wear does and what's different about designing for it. Android Wear provides just the right information at just the right time, allowing people to be connected to both the virtual and the real world. As much as possible, content simply shows up in the stream automatically. This is a significant change to the model that we're all used to of launching and quitting apps. Let's look at some of the principal design characteristics of an Android Wear experience. Android Wear is contextually aware and smart. These devices bring a whole new level of intimacy to computing. Rather than requiring attention and input from users, Android Wear devices are aware of their situation and state and helpfully offer the right information at the right time. Android Wear feels timely, relevant, and specific. These apps are glanceable. Wearable devices are used all throughout the day, even when they're just sitting in our peripheral vision. Effective apps provide the maximum information signal with the minimum of fuss, optimized to provide tiny nuggets of relevant information in many microsessions throughout the day. Think short, sharp, and immediate. It's also zero or low interaction. Staying true to the strengths afforded by a smaller form factor, Android Wear focuses on simple interactions, only requiring input by the user when absolutely necessary. Most inputs are based around simple touch swipes and voice, and inputs requiring fine-grained motor skills are avoided. Android Wear is gestural, simple, and fast. Finally, these experiences are all about suggest and demand. Android Wear is like a great personal assistant. It knows you and your preferences. It only interrupts you when absolutely necessary. It's also always on hand to provide a ready answer or complete a task. Android Wear is helpful, respectful, and responsive. By providing a smart connection to the rest of the world while respecting the user's attention, Android Wear feels simple and smart, unobtrusive but ever ready. Applications that respect these principles will feel most at home in the overall Android Wear experience. So, as a designer, the opportunity here is not to think about how to shrink a smartphone UI down to a tiny screen. Instead, think about the fundamental problems your design solves. How might the tasks that users accomplish with your product break down according to these principles? All right, we've established some of the concepts that should drive your design thinking. Now let's take a look at some examples and how they match these principles. Remember, these apps will all exist right inside that vertical stream of cards that is the core of the Android Wear UI. So this is what the Android Wear UI actually looks like. Here we see some cards in the main stream. Cards like this one appear at very specifically targeted moments, exactly when they're useful. Just like Google Now, these cards don't have to be launched or opened. Instead, based on location, activity like walking or running, time of day, the user's interests, and other factors, you can target content to appear at just the right time. These cards are contextual. Notice also how the content is simple, minimal, and clearly laid out. These layouts are optimized to be glanced at out of the corner of the eye or quickly checked while walking or running. These cards also respect our principle of low interaction. Rather than having lots of fiddly menus and buttons, the user can simply swipe to another page for more detail if necessary. In fact, throughout the Android Wear UI, you should make use of big gestures like swipes and full screen taps. Don't place multiple tiny tap targets on one screen. There are a number of common Android Wear UI elements that you should become familiar with. Cards, card bundles, action buttons, list selectors, voice input, confirmations, and more. By chaining these simple building blocks together, you can create a simple, instantly familiar user experience. I'll provide a link to find out more about these components at the end of this video. Now let's look at voice actions. OK Google, make a reservation at Cafe Robin for 7 p.m. Again, rather than thinking about launching apps, we're focusing on single tasks. Issuing a voice command from the wrist should be fast and smooth. Be careful not to design voice commands that require too much time or attention from the user. Get the job done as simply and unobtrusively as possible. I hope this has been a useful introduction. For lots of more detail, guidance, and resources, including sample apps and assets, check out the Android Wear Style Guide at this address. You'll also find information on more advanced topics, like designing immersive, full-screen apps for Android Wear. Thanks for watching, and have fun designing for Android Wear.
Developing scalable apps, developed with Google, is your guide to the most efficient way to build scalable applications on Google App Engine. Learn how to architect and build highly scalable, reliable apps by leveraging Google Cloud Platform. This class covers concepts like platform as a service, infrastructure as a service, data storage, caching, cloud endpoints, and more to help you develop a highly scalable backend that works seamlessly with both web and native mobile apps. For more information, visit udacity.com/Google.
Hi, I'm George Mount from the Android UI Toolkit team, and I'm here to tell you about the new Activity Transitions API that we're releasing in the L Developer Preview.
But before we get to activity transitions, let's talk a little bit about transitions. Transitions help give continuity to the user. In this app, I have buttons on the left and on the right, and when the user clicks on a button, something is happening, but it isn't clear what. Now, using the Transitions API released in KitKat, it only takes a few lines of code and it becomes clear to the user that the buttons are moving between the columns. The Transitions API is great when working with layouts, but what can we do between activities? The default activity transition is a scale and fade effect. I slowed down the transitions on my phone so that they are easier to see. We can customize activity transitions with, for example, a fade. We can also do a scale, slide, or rotate, but they work against the entire window and don't give the user the continuity we really want. For the new Activity Transitions API, if we wanted this continuity, we had to create this transition all on our own. Here we have an activity, Activity A, with a little yellow view that we want to transition into the new activity. Now, in the old way of doing things, the first thing we had to do was capture the size and position of the shared element. Next, we started the activity passing the location in the intent. Our new activity, Activity B, had to start as a translucent window with a transparent background. It also had to prevent the default scale and fade transition. The shared element view was then sized and placed in the position passed in the intent. The background was then faded in, and the shared element could then transition to its final location. And then the rest of our UI could come in. Wow, that's a lot of work. Let's see how we do it with the new Activity Transitions API. Here I have a contact grid with all of my handsome coworkers. When I click on an image, it will bring up the detailed contact information in another activity. I'd like to share the contact image to draw the user between the two activities. Because I can have any number of shared elements, I need to name each of them in my contract between my activities. I only have one, and I've given it the name Contact Image. To tell the framework which view is going to be the shared element, I give the image a name also. I've named it the same thing, so I don't need any code to glue the contract name to my shared element. I also want the shared element coming back to the grid, so I name that element as well. I then just launch it with an activity options bundle. Let's see what it looks like. It looks nice. We didn't have to do any of that hard work. When the orientation changes, the shared element picks up the final position from the calling activity and restores it to the right place. Amazing! My activities were doing a subtle fade in of the views other than the shared element. I'd like something a little more dramatic. Let's set the entering transition to use a nice slide effect so all the other views enter from the bottom. Previously, the calling activity didn't have any effect. I like to have the views around the shared element leave with an explode animation. Let's see what it looks like. The views from the calling activity push out from the scene, while the views from the entering activity slide up. I can also make the transition even more dramatic by having the entering activity wait for the calling activity to finish before it slides in. Now that you've seen how easy it is to add continuity between your activities, I know that you're going to want to add activity transitions to your applications. Make sure to check out more of our Dev Bites and the rest of our I/O videos. Thanks very much for watching.
Hi, I'm Brad, the lead engineer on our new in-browser native client development environment. I'm going to demonstrate how easy it is to use that environment to check out, edit, build, and debug a C++ application all in your desktop web browser or on a Chromebook. Also, with this environment, you can even work while offline. Visit this page to follow along. You'll need to install our new tools. I've already done that, so I'll go ahead and fire up the new dev environment. It looks a lot like a Unix command line bash prompt, because it is. Running inside the secure native client sandbox, so what you do in this environment stays in this environment. Let me create a work directory. Our new environment works like its own mini Unix system. Files you create are retained in local web storage, securely separate from your computer's main file system. I'll download a zip file containing my project using a command line program called curl. Once I have my project, I no longer need network access and can work offline if I like. Here's my zip file. I'll extract it. Let's look at what we got. My project uses a bunch of different programming languages. The core application is in a C++ file called Voronoi CC, which is combined with several C++ libraries. These are then built with NACL's GCC-based compiler, yielding a NACL executable, Voronoi Nexi, all of which is driven by a bash build script. Voronoi Nexi is then combined with some HTML and some JavaScript, which creates a NACL DOM element and routes UI actions to Voronoi Nexi, yielding the complete web app, which is then served up locally by a Python script, once again running in the NACL sandbox. Before we get going, I'd like to track my changes, so let's create a Git repository. Then add all the files here. Now I'll commit the starting state. Great, now let's build. Oh, that isn't right. It isn't building at the moment. Looks like the problem is on line 506. Let's open it up in Vim. We have a port of Vim to native client, but fear not, Emacs users, Emacs is coming soon too. The problem was on line 506. Let's go check it out. There's the problem. I've misspelled height. I'll fix it. Then save. Compile again. Victory. I can look at the diff using Git. I should really commit that fix. Now I'll fire up a local Python test server using our NACL sandbox Python and navigate to my test page. The Python server lets me view my entire virtual file system. In the /mount directory is an HTML5 local storage mount, which is where my home directory lives. Let's go into the work directory we created before. Then we can navigate to the Voronoi directory, which will load our app because it has an index.html page. Here's the sample running just on the main thread. Kind of slow. Let's crank it up to 32 threads and use all our cores. Uh-oh, it stopped. No worries, let's debug it using NACL's new in-browser GDB-based debugger. I simply open the developer console and select the NACL debugger tab. Our port of GDB allows you to attach to a running application, but will also automatically connect to a crashing one. GDB allows us to inspect the state of each thread, including local variables and call frame, to help us track down bugs in C and C++ applications. Let's get a stack trace. Bad things happened at line 485 in Voronoi CC. Let's go back to Vim and check it out. I see it. Do you? I botched value. Spelling is clearly not my strong area. Let me fix it. Save. Rebuild. Double check the diff. Let's commit that too. Let's look at my commit history as well. There are all my changes. Let's give this new version a go. Works like before. Now let's add some more points. That's really janky slow. Let's try our 32 threads again. Much better. Use native client and our new development tools to bring high-performance applications to the web, whether your application is written in C, C++, Python, Lua, or Ruby, with more languages and portable NACL support coming soon. Try this tutorial at the link above or visit our developer site for more information on how to use native client to supercharge the web. Thanks for watching.
Hi, I'm Rick Viscomi and I make YouTube fast. In this video, I'm going to share how we test web performance and a few tips for doing the same on your own website. The two test methodologies that we're going to look at are real user monitoring, or RUM, and synthetic testing. Real user monitoring, just as it sounds, gathers performance data from real users as they browse a site. For YouTube, this provides us with the ground truth about how users are experiencing the site. Synthetic testing, on the other hand, is more like a laboratory and is commonly used on demand to analyze a particular use case. Both methodologies collect performance data, but given these distinctions, RUM is especially useful for identifying how fast a page is, and synthetic for identifying how to make it faster. The simplest way to gather and analyze RUM data is with one of the existing analytics products. In fact, Google Analytics can do this for you. At Google, we use a custom solution called Client-Side Instrumentation, or CSI. RUM works on 3 basic levels. First, we instrument our client-side code to provide timing and page state data to the RUM JavaScript library. Then, the library packages up the data and sends it off to the analytics server for later use. And finally, the analytics server provides developers with a dashboard to view the results. Out of the box, most RUM tools measure the general page events published by the Navigation Timing API. But for us, one of the most important performance metrics is how quickly a video plays. The metrics you collect should be customized based on what your application does and what your users are actually waiting for. It's also important to include any contextual information that might have an effect on performance. For example, YouTube users may be exposed to experimental features, and we would need to know what effect that might have had on performance. By keeping track of these variables, we're better able to get insights into the performance of particular demographics. Also, note that the CSI beacon is sent unobtrusively after the critical path of video playback. This helps to ensure that testing does not interfere with the user experience. To analyze the performance data, we turn to the CSI dashboard. Here, we're able to look at the change in performance over time and compare experiments against controls. For example, in this chart, we're comparing the results of an experiment against the baseline control. The experiment times are lower or faster until the last point. We can use the CSI dashboard to slice data by various demographics to understand why this is happening. And when we break the data down by browser, it becomes clear that browser B is responsible for the regression. It's also worth mentioning that because we gather data from so many users, all of whom have different devices on different networks, we typically look at the 50th percentile or the median value to give us a representative view of performance data. Okay, that's it for RUM. Now let's compare it to synthetic testing. For that, we use Web Page Test, which is a free public tool. And instead of gathering data from real users, we configure synthetic tests to a particular demographic. The tests run in a laboratory-like environment to mitigate the effect of network anomalies, and this is achieved through repetition, so tests that are run many times are considered to be reliable. And finally, when the results are in, we're able to analyze our application-specific metrics along with the test network log. Web Page Test gives you full control over the type of use case for which you want to test. For example, we may be interested in the watch page performance in Chrome over a DSL connection. And being a free public tool, Web Page Tests are run on ordinary computers connected to the internet. To test YouTube, however, we need more privileged access to beta versions of the site. So for this reason, we run our own private instances of Web Page Test inside of Google. The results are shown on a waterfall diagram, which is a visualization of the network activity. In this view, we're able to precisely see the activity on the critical path to video playback. And finally, Web Page Test also annotates the waterfall with our application-specific metrics. This gives us the necessary context to better understand what exactly is contributing to slow values. So that's it for our look at synthetic testing. Remember that RUM is only as useful as the metrics you provide. CSI is just one of many tools that does it, but your solution should be just as unobtrusive and lightweight. Synthetic tests should be configured to represent common use cases, like a particular browser, connection, or page demographic. Also, by locating synthetic test machines inside of your own network, you can validate performance on a staging server before launching. To learn more about the Navigation Timing API, check out the Mozilla Developer Network article at this URL. Or for more information on using Web Page Test, check out the link over here, and also look out for my book coming later this year. Thanks for watching.
Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
Hi, I'm Jen King, the tech lead on the Drive Android API, and today I'm going to show you how to add Drive integration to your Android app. This API is a part of Google Play Services, which means that you can add a small amount of code to your app and get the benefits of these API features on nearly every Android device running Gingerbread or higher. There are a lot of reasons that Google Drive integration is great for users. Their files get automatically backed up to the cloud, are accessible on multiple devices including the web, and can be viewed and edited on mobile devices and the web using Drive-enabled apps, even when offline. So let's get started. I'm going to demonstrate how to integrate an app with Drive using our Receipt Collector sample app. This app allows users to take pictures of their receipts and store them in Drive to manage their spending. In order to use the Drive Android API, you first need to register your app as a Drive app by creating an entry in the Developer Console. The console asks you to specify the package name of your app and the fingerprint of your signing certificate so that the Drive API can authenticate your app. Creating a project ID on the Dev Console allows you to build versions of your app across Android, iOS, and the web and share a single project configuration for all of them. Once your project is registered, you can start using the Drive Android API by including the Google Play Services APIs in your application. Before integrating with Drive, our app just saves the receipts to the local file system on the device, which means they aren't easily accessible on other devices. If I lose or break my device, the data might get lost with it. However, it's easy to back up these receipts to Drive using the Drive Android API. To do this, we'll create a new file with the image bytes using the Drive API, which will sync the data up to the server. We need to write the receipt image to a contents object and create a new Drive file using this contents. For now, we'll just add all the receipts to the user's root folder, also called My Drive. To save the new file, we call Create File on the folder where we want to insert the file and pass in the contents object containing the data. The Create File call will return the Drive ID of the new file. Receipts will now get automatically uploaded to the user's Drive, allowing users to view and organize them in the Drive web UI. Next, we need to change our receipt list to request the list of receipt files from the Drive API instead of the local file system. To do this, we'll query for all files in the user's My Drive folder that are accessible by the Receipts app. This query uses the local Drive database rather than the server, so it will still work while offline. The Drive Android API will automatically sync metadata for files created from other devices. We'll change our receipt list view to use data from the Drive API by changing the adapter in our list view to use the metadata buffer object returned by the query method. We use the title field to generate an entry for each file in the list. Last, we need to display the receipt image and description when users open it from the list. To display the receipt image, get the Drive file for the receipt using driveapi.getFile and open the contents using drivefile.openContents. If the file content is already available on the device, the OpenFile method will return immediately, and if not, the Drive Android API will fetch the content from the server for you. Now, the app functions just as it did before, with the added benefit that users can open all of their receipts on any Android device, as well as on the web. There are 3 more cool features that can help us to make the user experience better: pinning files, the File Picker UI, and app folders. First, you can allow your users to save receipts for offline use, or pin the files, using the setPinned API. This API will ensure that the file content is on the device and will keep it up to date. To surface this feature to users, we'll add a pin button to our View Receipt UI, which allows the user to choose to keep the file on the device. Second, we're currently saving all receipts to the user's My Drive folder, but what if they want to be a little more organized? We can allow users to choose which folder to use for saving the receipts by launching the Drive File Picker. Once the user selects a folder, we save this preference to the device, and every time we create a new receipt, we create it in the selected folder. Last, it would be a lot better if this preference were consistent between multiple devices. We could store our preferences in a file in Drive, just like we do with receipts, but it would be better if we didn't clutter the user's Drive with preference files. Here's where our last feature comes in. App folders are a special type of folder where you can store files that only your app can see and manage. This folder still uses the user storage quota, and they can clear all of the folder contents if they want to stop using your app, but the files won't ever get in their way. So let's recap what we've achieved. We took an app that stored all of its content on the local device and added automatic backups, cross-device file syncing, offline support, and synced app configuration. You can add these features to your app too, so get started with the Drive Android API at developers.google.com/drive/android. I'm Jen King, and I can't wait to see what you come up with using the Drive Android API.
Hi, I'm Matthew from the Android Cloud team, and I'm going to talk about how your apps can efficiently use platform resources with the new Job Scheduler APIs, you lucky devils. So what are we doing here exactly? I mean, this is YouTube. You could be watching video game replays or fashion tips. But don't go just yet. I'm going to show off a new way to handle execution of background jobs in a way that will improve battery life and also developers' lives. So what background jobs? Well, there are different kinds of work your app needs to get done that aren't user-facing. Periodically hitting the network to upload user data or downloading config parameters. These typically don't need to be reflected immediately, if at all, to the user. For example, think of a network operation that would not update the UI. The types of jobs I'm talking about are also self-contained. One way to think of it is that we're interested in execution logic that can be easily refactored. Another way to think about it is that there's some bundle of parameters that you need to know to run your task. The name of your user, the list of rows in your database that are dirty, or the list of contacts that the user has requested be uploaded. So why create a new API? You might wonder at our rationale when clearly these things have been possible for as long as Android has been around. Well, not quite. Take network calls as an example. These are a strong candidate for the kinds of work we're interested in. Apps usually do them ASAP to kind of get them out of the way. This leads to unnecessary radio wake-ups where everyone is doing their own thing haphazardly. To tell you some more, let's take a look at how we might write code to periodically upload data, but without the job scheduler. There are about roughly two ways you could have done this. You could use a handler and post a delayed message if the period was small enough. But what happens if the user kills your app, or if the system does? At this point, you decide the alarm manager is for you because at least you'll be started when the alarm goes off. The problem is now that if the phone turns off, your alarm is gone. So you're stuck doing your own persistence. Then what if an execution time, the network wasn't available? You'd need to handle this and try again later. You'd have to register a broadcast receiver so you'd know when connectivity came back. I guess you could try writing a sync adapter, which kind of solves a bunch of these issues for you. And it's an excellent piece of code, but it's not intended to be used for scheduling. Regardless of route, it would be a mess and difficult to get right. So we've decided to get it wrong for you. We've taken pre-existing functionality, wired it together with new functionality, and are giving it to you in a nice palatable package. We've introduced the concept of idle mode, a window of time for which the system has determined the phone is unused and is not likely to be turned on soon. For example, having a job run while the device is idle and also charging is likely to happen at night when the user is sleeping with the phone plugged in next to them. The second thing we've done is integrated closely with new system APIs that inform clients when the network is active. This means that the handshake with the carrier has already happened. So when we batch your app's network calls to follow on shortly after, it'll circumvent the battery cost of you doing this handshake independently. Less pesky battery blaming and battery stats for you, and more battery for our users. So let's take a look at how to use this functionality. Here we'll see the sorts of work you might like to express. Run this when the phone is plugged in. Run this whenever an unmetered network becomes available, but make sure I run within the hour. Wait at least 10 minutes and then run this the next time the device is idle. Every 15 minutes, whenever a network is available, let me know so I can do some small health check. These 4 use cases, there are a number of constraints, and you can specify as many or as few of them as you want. The scheduler will only run a job that has all of its criteria satisfied, the one exception being when you set a deadline. When this deadline expires, it'll override the existing constraints. Let's take a look at how we do this practically. For this job, we're setting the deadline of an hour. But what will happen if the phone is in airplane mode after the hour has expired? Well, we'll talk about failure retry in the next and last section. For now, let's look at some other interesting things. My job service is the endpoint you provide. Here, you're identifying it so that the system will know where your job should land. Wi-Fi upload ID is this handle on your job to differentiate it from others as you schedule. So an arbitrary integer that you pick yourself. You take this job info object and you pass it into the system in the normal way, and voila. But where does my logic go? Okay, so you extend a service provided by the framework. The framework service handles all of the service lifecycle mechanics for you, leaving you with only the implementation of on-start job and on-stop job to worry about. Once the job has landed on your service, and you've done whatever it is you set out to do, call job finished, and you're done. And that's more or less it. Oh yeah, I mentioned it was really easy to request a reschedule if your job failed for some reason. In either on start job or job finished, you provide a boolean to indicate whether you need to be rescheduled. Bam, done. Okay, that's a lot of detail, but if you're still with me, you have it and are ready to use this stuff. The takeaway is that being good citizens should be as painless a chore as possible. So, thanks for watching.
Developers using Bluetooth Low Energy have a tough time today. The stability is inconsistent and it burns through the battery, which ultimately leads to your users unhappy with your app. The good news is that in Android L, we're fixing this. My name is Megan, I'm a product manager on the Android team, and I'm here to tell you about two key improvements: peripheral mode and improved scanning. Bluetooth Low Energy is a low-power form of Bluetooth communications. It allows devices like your Android phones and tablets to communicate with peripherals like fitness bands or Bluetooth beacons. Your Android phone in central mode can scan for advertisement broadcasts from peripherals, and it can also form connections to exchange additional data. Bluetooth Low Energy scans first landed in Android 4.3, and one of the biggest drawbacks was that scanning prevents a device from going into standby. If your app needs to scan frequently or constantly, say for nearby Bluetooth beacons, preventing your users' devices from going into standby will kill their battery. And trust me, no one likes an app that drains their battery. In order to address this problem, we have offloaded scanning to the background in a way that allows the device to enter into standby when it isn't detecting advertisements from nearby devices. But at any given part of your user's day, their device may be bombarded with advertisement packets from a myriad of devices in their vicinity. This would still prevent their device from entering standby. To address that, we've added new APIs that make your scanning even more efficient. These APIs allow you to specify filters to reduce the number of potential advertisement packets your application needs to process. You can set filters on specific parts of the packet like service UUID, service data, and manufacturer data. With these filters in place, your user's device will only wake up from standby and tell your app when it finds a packet matching your filters. You only get notified when Android finds a nearby device you're really interested in. Your user's device will keep scanning in the background indefinitely until you stop the scan manually. But your user's device may also be connected to other devices, like a Bluetooth headset. Starting in the L release, Android will optimize and balance scanning with other activities and power based on your requests. You can request to have Android scan with low latency. This will increase how quickly you detect the device you're interested in when it comes within range. But even background scanning consumes power, and scanning more frequently will consume more power. If detecting the other device is not time critical, like when the phone is in standby in the user's pocket, you can ask Android to scan less frequently and save power. We've added peripheral mode too. An Android device can now act as a Bluetooth Low Energy peripheral. It can broadcast advertisement packets and form data connections with other BLE devices. In fact, your apps can specify the contents of the broadcast packet, like service UUID, service data, and manufacturer data. This allows your app to produce more meaningful advertisement packets for your use case. But the space in an advertisement packet is limited. If another app has already filled it up, then there is no space for your app's packet contents. To fix this problem, Android now allows multiple apps to advertise concurrently, allowing each app its own packet. If your app needs to advertise more frequently to enable other devices to detect it quicker, you can request low latency. Of course, advertising more frequently will consume more power. If your use case allows advertising less frequently, you can request low power. Just like with scanning, Android will optimize how often to transmit your advertisement packets, balancing power and other demands on Bluetooth such as scanning or a Bluetooth audio connection. Now, try out our improved scanning and peripheral mode support for yourself. Thanks for watching.
Google I/O is just around the corner.
And we're really excited to show you what we've been cooking up.
For the first time, in addition to our live streams, we are rolling out over 100 I/O Bites.
Short videos to help developers like you dive in.
And experience I/O anytime, anywhere.
We're delivering more content.
And making it easier than ever to design,
develop, and distribute.
And making it even more accessible.
And it's all for you.
It's just for you. It's all just for you.
Learning to develop on Android is much more than learning APIs or shortcuts. It's training your brain to think like a mobile developer. Android Fundamentals, developed with Google, tells the story of Android's history while you build a real app, exposing you to current APIs and battlefield experience that will help you think and code like a seasoned Android developer. For more information, visit udacity.com/Google.
In the last few years, we've seen a staggering increase in video consumption on the web, while worldwide internet bandwidth has not kept the same pace. To help with this, my name is Vignesh. I'm here to talk about how you can take advantage of a new video format for the web. Video already accounts for more than half of the peak internet bandwidth worldwide and almost 2/3 of the peak internet bandwidth in certain parts of the world. The WebM project is a collection of open tools and media technologies that aim to tackle the challenges of media at internet scale and enable open and free communication of ideas through media. The WebM project develops two video codecs, VP8 and VP9, a media container, that's the WebM container, and an image format called WebP. These technologies together power some of your favorite Google services at a large scale like YouTube and Hangouts. They are also widely used on the web. For example, Netflix and Facebook use WebP. We announced VP9, our next generation open video codec, at I/O 2013. Videos encoded in VP9 see up to 50% improvement in compression efficiency. Today, VP9 video playback is supported in Chrome, Firefox, Opera, and Android. Since I/O 2013, we've improved both the speed and the compression efficiency of VP9. This has enabled YouTube to choose VP9 as their next generation video codec. If you're curious about updates to VP9 since I/O 2013, check out our video Updates to VP9. Additionally, if you want to deep dive into the encoding techniques used to achieve the compression performance, we highly recommend checking out our I/O 2013 session on VP9. It's called the New Open Video Codec. In this video, I'm going to focus on how to easily encode VP9 videos using open source tools, and then go on to talk about how we can play those videos back. First, the simple progressive encode. Let's say that you just want to encode a video and want it to be played back across multiple devices. In other words, all you want to do is just host a video and play it back using the video tag by using the hosted URL as the source. Here's how you do it. Progressive encodes are simple and will allow any supported VP9 player to download and play the file. Examples include Chrome, Firefox, and Android. Here's how you create a progressive VP9 encode. All you need to do is point FFmpeg to your input file and ask it to use the VP9 encoder. Here's how you play back this video. That was simple, wasn't it? If you have ideas on making it even simpler, we welcome all your thoughts at this email. Okay, now if you plan to serve video over the web, chances are that you want to take advantage of some of the HTML5 technologies that will allow you to provide a great streaming experience to your customers. This has traditionally been tough, and an industry standard was born to solve this called Dash. Dash stands for Dynamic Adaptive Streaming over HTTP, and it allows you to select the stream that will provide the best perceived quality depending on the client's constraints. Traditionally, this is bundled with the term adaptive playback. At Google, we use adaptive playback using Dash and HTML5 technologies like media source extensions to provide a great streaming experience on YouTube. For example, with VP9 and Dash, we've improved the key metrics of streaming videos, rebuffers. VP9 Dash videos have improved rebuffers by 25% in developed markets and up to 50% in emerging markets. Okay, we've heard from video developers that creating a Dash manifest for VP9 has been challenging. I'm happy to announce that we've worked with FFmpeg and are announcing a set of open source tools to simplify the encoding process. Let's now take a look at how to encode VP9 Dash videos and generate the manifest. Encoding a VP9 video to be compatible with Dash is very similar to doing a progressive encode with a few minor changes. For Dash, the video and audio has to be encoded separately into two different files. You also need to pass the extra Dash parameter to FFmpeg so that it creates WebM files which are Dash compliant. Now that you have the video and the audio files encoded, you can make use of the WebM-manifest tool to generate the -manifest file. The WebM-manifest tool is part of WebM Tools project. You can download the tools we use to create Dash streams and the manifest from the links found on this slide. Okay, let's now talk about integrating a video player to play back VP9 videos using Dash. Just to reiterate, VP9 decoding support is already available in Chrome, Firefox, Opera, and Android. Together, they represent over 1 billion devices and browsers that can play back VP9 video. But creating a VP9 player to play back adaptive video is a little more difficult, although there are 2 players that makes it easy. To put together, they enable adaptive VP9 playback on 2 of the most popular platforms, the web and Android. First off, Android. YouTube open sourced a player called the ExoPlayer that supports adaptive playback of VP9. To know more about how to use ExoPlayer to enable VP9 Dash videos in your app, see the talk by YouTube on ExoPlayer. For the web, we added VP9 Dash support to Dash.js, which is a fantastic all-in-one media player built entirely in HTML5. For more information on how to use Dash.js to play back adaptive VP9 videos, you can follow the link on this slide. With these tools, encoding and decoding VP9 content has never been easier. Now it's your job to tell a great story or ship the next great video player. And of course, we're here to help. Drop us a line at webm-discuss@webmproject.org. Thank you.
Hey, I'm Chris Wilson. Like me, many of you probably have a guitar or 2 tucked away you like to noodle around on. Or like me, you have a basement full of synthesizer and studio gear. But for years now, I've been getting more and more excited by the powerful music software available for desktop computers and lately even mobile devices. Now, I can replicate vintage synthesizer and processing hardware and software, which lets me stop filling up my basement while draining my checking account. Well, I'm here to tell you that all that exciting software can now come to the web platform with an amazing open web platform API called the Web Audio API. The Web Audio API was designed for several purposes. First of all, it's a great API for building sound for gaming. When we build games, we need to be able to make pew 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 sounds right when our users hit the button. You need to hear that massive explosion right as the screen lights up, or whatever. Now this was hard to do with the HTML5 audio element, which wasn't really designed for precise timing, multiple simultaneous sounds, or memory management. But the Web Audio API also lets you crack into the world of digital audio in a big way. You're in control of the audio path itself, with powerful but easy-to-use processing nodes to create effects like delay, filtering, reverb, and more. Now the Web Audio API lets you create rich, multiply layered effects by giving you the primitives you need to do the job, like delay nodes, gain control, filtering, even complex primitives like convolution. The goal isn't to give you all the complex final effects you could ever want. It's to give you all the primitives you need to build more complex effects. When I first started playing around with the Web Audio API, I wanted to see just how far I could take the processing system. So for a past Google I/O, I wrote a vocoder application. Now vocoding is a fairly complex process. It takes one sound source, like me talking to you now, and it chops it up by frequency bands. Next, it takes the volumes in those bands over time, and it applies them dynamically to the same frequency bands in another sound, usually a synthesizer sound.
Now you do the sound of a robot. You can raise your brain. You can even change your function or become a steam robot. Do, re, mi, fa, do, la, mi, do.
You can also use Web Audio to create other audio processing effects, like chorus effects, or reverb.
Or pitch shifting. I'm talking to you, Kent.
Or you can become Alvin, Simon, or Theodore. Should I give the rest of my talk like this? Yeah, probably not.
To implement each of these effects, though, I didn't write JavaScript code that acts directly on the sound buffers. I wrote code that combines the processing nodes that Web Audio gives me, and it does all the work. Okay, so you can perform real powerful processing with Web Audio, but where does that sound source come from? Where do you get started? Well, as I just demonstrated, the sound can come from the user's audio inputs. Via WebRTC's Get User Media API, you can hook the audio inputs of your computer. Sometimes that's just the microphone on your headset, but you can also have a pro-quality audio interface with a killer axe plugged in. Web Audio can also hook any media element's audio output, so you can grab the audio output from video or audio elements. This can make it easy to do just some basic processing, like gain control or filtering, on an audio element that may be streaming from the server. But sound sources can also come from audio samples that you load, through XML HTTP request most likely, and you can use web audio to decode from MP3, WAV, or OGG format to a buffer. When you play those buffers back in web audio, you can also change their playback rate, or detune them. This makes it easy to take a simple sample, like this one I recorded of me tapping a wine glass, and turn it into a playable musical voice. And finally, if you don't want to use recorded sound, you can use web audio's natively implemented oscillators. If you're an old synthesizer nut like me, you'll know that oscillators create a basic waveform, like a sine, square, sawtooth, or triangle wave. This makes it easy to produce basic audio blips, bleeps, and bloops. Of course, oscillators also make it completely possible to build much richer synthesizers without ever loading a sound file, like with this digitally replicated analog synthesizer I built. I tried to dig up a keytar to play this live, but I couldn't find one. Now, oscillators aren't just for building synthesizers. They're also the key to creating a lot of effects and complex sounds. Many effects, like the very common chorus effect, use oscillators in the background. Chorus is really just a delay with a constantly varying delay time. That variation is caused using an oscillator. This kind of control is possible because of web audio's powerful, flexible audio parameter and routing system. Most parameters can be controlled and scheduled at the rate of the audio. This makes for some amazing effects. For example, for those of you who remember the 80s, you can build FM synthesizers, similar to Yamaha's DX7, because you can modify one oscillator's frequency with another oscillator at an audible frequency, and that creates that classic FM synth bell-like sound. Working with the web audio system's routing and parameter schedule can be a little daunting at first, but think of it like a queue of notes that you need to keep full. It's sort of like when you sight read sheet music. You need to look ahead a bit of where you are to keep your playing fingers primed. The audio system is busy under the hood, generating and processing the sound stream, and keeping the sound output happy by pushing a continuous stream of audio bits at it. So really, the least you can do is give it a little heads up for what it will need to be playing soon. I wrote an article a while ago about web audio scheduling for HTML5 Rocks that can help you better understand this system, and it can help teach you to create rock-solid timing for musical applications, even with JavaScript's not always rock-solid event delivery timing. This makes it so you can easily build drum machine and sequencing applications that keep a rock-solid beat while still responding in near real-time to parameter changes. One more critical piece to building musical applications is control. In the music world, nothing beats having a real physical instrument to finally control your sound. So we've been building support for a standard called the Web MIDI API that lets music controllers, like this, or this, or even this, get plugged straight into the web platform, so you can use them for direct control of your web applications. This lets me have direct, physical, immediate control over these great audio capabilities. Now, the Web Audio API is available on Chrome, Firefox, and Safari today, and Internet Explorer recently began development as well. But finally, I want to leave you with one mind-blowing revelation. All of these things I've been talking about, all the incredible power of the Web Audio API, all of this works on the mobile web as well, with modern mobile browsers. iOS, Safari, and Chrome for Android both implement the Web Audio API. In fact, Chrome for Android even has an experimental implementation of Web MIDI, so you can build amazing web music applications and take them with you wherever the web goes. So I hope I've inspired you with some of the things you can do with the Web Audio and Web MIDI APIs. Let's get out there and make the web rock.
Hello, my name is Jay Judkowitz. I'm the product manager for Google Cloud Platform block storage products. I'm here with some news, technical details, and best practices about block storage in Google Cloud Platform. At Google, we're always excited to bring new storage offerings to the cloud. That's because it's all based on the great technology we've built in-house to run some of the largest and most successful applications on the internet. When you use Google Cloud, you're taking advantage of the same great storage infrastructure as we do at Google. Block storage in the cloud is general-purpose storage that you attach to a virtual machine that appears as a disk drive to the VM. You generally format it with some file system and write files or databases to it. It's what you use to create your own self-managed data stores. This section will announce 2 new pieces of news about block storage in Google Cloud and quickly describe the 3 block storage options that we now have. Cloud Platform offers 3 types of block storage. The key difference between them is how many IOs per second, or IOPS, can be supplied by each gigabyte of storage. Higher IOPS per gigabyte trade off against cost and flexibility. The first option, Standard Persistent Disk, or PD, has been around since Google Compute Engine was first released. It utilizes networked hard drives. It's designed for security, high availability, and consistent performance. For use cases that need up to, say, 2 random read IOPS per second per gigabyte, this option is ideal. You get steady performance at a low price. The second option, SSD Persistent Disk, we're pleased to announce is in general availability now. It's like standard PD, but backed by networked SSD. As a result, you have a higher cost, but a higher performance per gigabyte. Use it like you would standard PD, but in cases where you need between 2 and 30 IOPS per gig. The third option is not yet generally available, but is now accepting trusted testers. It's a local SSD option. It offers the highest possible performance, but has availability, durability, and flexibility trade-offs I'll discuss shortly. Before we get too deep into the numbers, let's give a quick overview of the similarities and differences between the 2 PD options and local SSD. First, the similarities. All of our block storage options are priced on a per gigabyte basis with no I/O charges ever. This makes planning simpler and eliminates surprises. All of our block storage options are designed to perform consistently between similar volumes and consistently over time. Third, all of our block storage options are encrypted on disk. And because PD is a network storage offering, the data is also encrypted over the wire. This is to give you the best possible security. Lastly, all of our block storage options support live migration and are therefore not affected by planned downtimes that keep Google Cloud data centers patched and maintained, which is what keeps your applications as secure and available as possible. Now for differences, starting with reliability. PD has additional reliability that comes from storing its data redundantly so that volumes can survive the sudden loss of hardware. Local SSD does not have this redundancy. It's up to you to protect the data that needs to survive storage failures. PD also has built-in checksums. Whenever you read data, no matter how long ago it was stored, PD makes sure that it returns what was written to you and avoids silent data corruptions. Lastly, PD has a snapshot functionality that makes it easier for you to protect your data against user error and physical disasters. In terms of performance, while all the block storage options perform consistently, local SSD has much higher IOPS and is designed for sub-millisecond latency, making it ideal for the most performance-hungry databases. For flexibility, note that both PD and local SSD are very flexible. PD volumes are the more flexible in that they can be created in sizes ranging from as small as 1 gigabyte all the way up to 10 terabytes in 1 gigabyte increments. And it can be attached and detached from VMs on the fly. Local SSD, by contrast, can be allocated to VMs only at creation time and need to be allocated in 1 to 4 partitions of 375 gigabytes. While this isn't as flexible as PD, local SSD does not require special instance types with pre-specified amounts of SSD. This lets you right-size the VM, CPU, memory, and storage. So, given these 3 options, how do you decide which option is right for your application? Let's split it up by use case. First, boot volumes and bulk storage are great use cases for standard PD because those use cases require low IOPS and low throughput, basically just want to occupy the cheapest, reliable space available. Streaming I/O is a use case that works best for standard PD as well. While the other 2 options have a much lower cost per IOPS, the cost per throughput is generally better on standard PD. Reading large sequential blocks is what disks are good at. SQL databases, like MySQL and Postgres, and NoSQL databases, like Cassandra, Mongo, and Redis, tend to be transactional and IOPS heavy. Smaller instances might be able to be run on standard PD, but important production databases should usually be run on some form of SSD, either SSD persistent disk or local SSD, depending on how high the IOPS needs are. File servers, like NFS, Gluster, or Ceph, can be more streaming or more transactional depending on what the clients are doing. SSD PD is generally a great choice here. High-performance scratch disk, where keeping the traffic local is the right architecture, should go on local SSD. For Hadoop deployments, where I/O needs exceed what Google Cloud Storage Connector for Hadoop can provide, for that case, you should use local SSD under a Hadoop optimized file system. Here's another way to visualize the same information. As you can see, depending on the performance needs of file servers or databases, you have options as to which block storage product to use. To decide, you'll want to get down to the real numbers of space and IOPS. I'll go through some specific examples just a bit later in the presentation. Let's double-click on persistent disk and talk about what separates the two PD options, their performance. With both options, standard and SSD, for both read and write, the more space you buy, the more IOPS you get. But SSD persistent disk grows in IOPS capability much faster than standard PD, which is why it costs more. Each gigabyte of SSD PD gets 20 times the write IOPS of a gigabyte of standard PD and 100 times the read IOPS of a gigabyte of standard PD. These high IOPS numbers are what make SSD PD ideal for transactional workloads like heavily used databases. Now, the SSD PD IOPS grow so fast that they reach the limit of the IOPS of a VM can handle at a relatively low volume size, which is why these graphs have this plateau at the top of the IOPS curve. We're always working to increase the per VM limits, and you should check on the current documentation for the latest numbers rather than coming back to the graph. Now, moving from IOPS to throughput, same pattern here. Performance grows with space for both options. Unlike the IOPS graphs, however, you can see that SSD PD's advantage in throughput is less dramatic, and both standard and SSD PD can hit the VM throughput limits at moderate sizes. This explains why we recommend standard PD for throughput-oriented applications that have low IOPS. While SSD PD has a much better cost per IOPS, standard PD has the better cost for throughput. Like with the previous slide, please check the latest documentation as we're always striving to raise the per VM caps on throughput, just like with IOPS. So, the idea of growing I/O with space is pretty unique, and many customers have asked us why we designed it this way. We made this choice.
Hi, everybody. Welcome to Taming Your Cloud Applications with Intelligent Monitoring. We're glad you can make it today. My name's Toby. I'm an engineering lead here at Google. I work on cloud logging, monitoring, and alerting.
And hello, everyone. I'm Dan Belcher. I'm a product manager in the same team. I'm what they call a noogler because I started at the company just last month when a company that I had co-founded called Stackdriver became part of Google.
Super happy to have you here, Dan.
Thanks, Toby.
All right, so if you've ever developed any sort of application and you had any user base whatsoever, there's probably a time when you've had this moment. That awful sort of oh crap feeling that accompanies that recognition that your users figured out an awful problem with your application and you had no idea it was going on. You're not alone. Pretty much everyone who develops anything has been in this boat at one point or another. But it sure doesn't make it any fun. When it happens, You're kind of pulling your hair out, and as you can tell, I must have been in these situations a lot. Because you already have a full-time job. You're just trying to develop the world's greatest application. And now suddenly you have 2 or 3 jobs. You're still trying to develop the world's greatest application. But now you're trying to fix that critical bug that your users were so helpful in helping you find. Thank you, users. And if it's just you and another person, like maybe me and Dan, well, you might be on the hook for sending email and apologies, writing blog posts, maybe even calling up customers and saying, hey, we're on it. We have this. We're going to fix it for you. You totally don't need to go look at the world's second greatest application. Why does this happen? It doesn't need to. Especially in the cloud, we have all sorts of information about how applications behave that can help save you from this sort of thing. That sounds nice, but it's not always that easy. So first of all, just a quick show of hands. How many of you here are completely new to cloud development, have never done it before? All right, there's only a handful of you. That's fantastic. And we welcome you to the cloud sometime soon. But if you are coming from a more traditional sort of application development environment, you might be used to a world where you write your code, you test the hell out of it because you want to make sure you're giving the best product to the customer that you possibly can. But at some point, you just kind of have to throw it over the wall. You have to package it up and ship it out there. Someone buys it. They install it on a computer that you have absolutely no visibility into. When that happens, you're just left wondering how your application's behaving in the wild. And if that's the environment that you're used to, you might not have any expectation that there is more to be learned, that there is logging and monitoring information about your live running applications that you could have. So I guess the rest of you are all die-hard cloud developers who've been around the block for a few years. You folks might have a different sort of perspective on what's available out there. There's a lot of really great vendors doing fantastic things in the logging, monitoring, and alerting spaces. But you have to go out and find them. You have to do some research. You have to understand what's available. You have to pick and choose from this a la carte sort of offering. Instead of just being able to rely on your platform to provide a single pane of glass to the core functionality that your application needs. Wouldn't it be nice if something just gave you that out of the box? We agree. We think that it should be easier than this. And so that's why we're so excited to be talking to you about Google Cloud Monitoring today. With Google Cloud Monitoring, you don't even need to know it exists. If you're just getting started and you're coming from a more traditional background, you might not even think, oh, I need to set up logging. Ooh, I need to set up monitoring because I'm going to care about it later. We do that for you, so when you do care about it, the data's there for you. But we're also able to grow with you. If you're more sophisticated and you've been looking at other vendors and maybe you're even using some of them today, we can give you some of the core functionality that you need without ever leaving the Google Cloud Platform sandbox. You get all the information about how your application's behaving in one place. That's why I'm super excited that Dan's up here on stage with me. He and his team with Stackdriver developed a world-class cloud monitoring application. And now they're bringing their real-world experience, their domain expertise, and most of all, a fantastic product to Google Cloud Monitoring. They really form the pillar of what we're going to be talking about today. And with Stackdriver and with Google Cloud Platform, you can go from knowing absolutely nothing about logging and monitoring to setting up sophisticated dashboards and alerts in no time. Dan's going to talk a little bit more about the types of data we get together and give to you to help you understand your applications.
Thank you, Toby. So this is all about visibility. And so what we set out to do is give you visibility into your entire application stack running on the platform. And just a quick overview in terms of how it works. So we think of the application stack in 3 layers. The first layer of the application stack at the base is the cloud platform itself. If you're using App Engine, if you're using Compute Engine, Cloud SQL, Cloud PD, and so forth. And so that's the bottom layer in the stack. On top of that, you have the systems layer, right? So these are typically VMs running in Google Compute, where historically it's been difficult to get really good information in terms of the performance of VMs themselves. And whether it's Windows or Linux, we support a variety of operating systems. And we have an agent that we use to integrate with the VMs. And then on top of that, you have your application stack. For the many of you who have been developing in the cloud for some time, you're probably using one or more of these components, whether it's Redis or Nginx or Apache or Cassandra or Elasticsearch and so forth. And we use the agent framework to integrate with those services natively. So we are able to monitor those services as well. And when we think about giving you visibility, what that really comes down to is log data, metric data, and metadata. So we're capturing all this data from all 3 layers in the application. We're storing it in massively scalable databases, and then we're making it useful for you. And so that starts with visualization. We'll talk a lot about really rich charting and dashboard capabilities here. But beyond visualization, if you're looking at a chart, usually you're trying to analyze the data. And so what we've done is built tools into the platform to analyze the data on your behalf. So that's the analysis capabilities in the product. And then finally, it doesn't really help anybody if the platform discovers an issue and you don't know about it. And so there's a really flexible notification framework to let you know when issues occur, whether you're at lunch with your teammates or, unfortunately, asleep at 3 o'clock in the morning. So that's how the system works as a whole. We think a lot about the 1 or 2 developers working from a home office or a garage and the experience for them getting started. And so to illustrate that, we'll talk a little bit about the walk share application. So this is an example application that you might build someday. If you didn't catch the I/O keynote, the walk share application is a simple app that basically tracks your sort of walk around San Francisco, for example, and makes it easy for you to share that with friends. The walk share application has 3 App Engine modules, and it uses a number of Google services. What we'll focus on here is the front-end interface that connects to a leaderboard module on App Engine, and then that module itself connecting to a set of Redis nodes, a cluster of Redis nodes on Google Compute Engine. And so we'll use this as an example of how you can get going with cloud logging and monitoring. So in terms of this App Engine module, the leaderboard module, the first thing that you might want to ask yourself is it up and running and available to users? And so we'll show you how you can configure endpoint or uptime checks to notify you when it goes down completely or when it's inaccessible to users. Then we'll talk about default dashboards, so dashboards and charts that give you insight into the performance of that module. We'll talk about how you can use log data to get to root cause.
Yay, logs.
And also how you can create very, very simple alerting policies to notify you when issues occur in the future. Okay? So we'll start with getting started monitoring that module that's running on App Engine. The first thing that we'll want to do is configure an endpoint check so that we know if the leaderboard is no longer available at all. And so Toby's going to go to Services and Endpoints, and he'll configure a check to basically connect to a specific host name every minute, to poll it every minute. And what this is basically doing is instructing our infrastructure of probes deployed around the world to connect to that host every minute and confirm availability. So we'll specify a protocol and a path and say that we want it to happen every minute. And Toby will test the endpoint to be sure that we're connecting.
Huzzah.
So we had a successful connection in the test, and we would save this, and now it's up and running. That will just keep running. And you can see that we have an existing endpoint check in place, and from each of our 5 regions, we are actually healthy right now. So this means that we've gotten a 200 response from each of the regions, and we're good to go from that perspective. So we're up and running. Next, we'd want to see if there are any performance issues related to the App Engine module. So we'll go to our App Engine dashboard, and this gives us an overview of the performance for this App Engine project. Right? And so on the left, you'll see that the format here is of kind of an operational dashboard. So we have key configuration information on the left, and then key metrics on the right. And if we scroll down looking at the metrics, we can see latency, network I/O, response codes, response styles. And actually, Toby, response codes, it looks like we have something interesting here.
Hold the phone, Dan.
Yeah. So we have what looks like a spike in 500 errors that happened at some point over the last hour. So first, I might want to zoom into that time period. So we can just click and zoom right on the chart, and that'll zoom all of our charts into that time period for the module. And so we can see if there are any correlating issues. Looks like there was a slight increase in latency, a little bit more network load, and again, this spike in 500 errors. So what we don't know now is which module is emitting the errors. So we'll click on the Modules tab, and we'll see the same metrics broken out by module. So we can scroll down to the 500 errors, and then highlight over the ones where we see the spike, and discover that this is our Redis module. That's the leaderboard module.
It's always Redis.
It's not always Redis. So this is the leaderboard module. It looks like there's an issue here. And now we want to try to get to root cause, right? Why are we seeing this increase in errors? And one great way to do that is to take a look at the logs. So we'll go back to our developers console. We'll click on logs. And then you'll see that we bring all the log data from our App Engine projects into a single place. And we can filter the module to only that Redis module. And sure enough, we see that the errors are abundant. And Toby, what do we see if we look at the details on this one?
That we're sad.
Yeah, that we're sad.
Oh, it looks like an invalid password, Dan.
All right. Well, the good news is we found the issue, and also it's a pretty quick fix. What this means is probably the Redis module is having trouble connecting to the Redis cluster. We're using the wrong password there. So maybe one of the teammates here in the audience could fix it. But maybe, Toby, why don't we turn on live streaming for the logs to confirm that it's still happening right now? And indeed, it looks like it is. All right. So that's how you can use the logs from App Engine to get to root cause on an issue. Okay. Now, finally, the good news is that we found the issue. We happened to be looking at a dashboard at the time. I don't know who here likes to spend all day staring at dashboards besides Toby and I. So what you'd want to do is configure an alerting policy so that you're notified if the issue occurs in the future. So we'll go and we'll create an alerting policy. And we'll specify that we'd like to be alerted when 500 errors increase for that specific module. So we'll select the module. And then on the next screen, we'll say that we want it to alert on 500 errors when they go above, say, 10 per second for more than 5 minutes. And one good thing that we do here is give you kind of a preview of the metric, or a historical overview of the metric and how frequently it would have fired if you set it at that level. Okay? So I've saved that condition, and now I can configure a notification. So this is to say whether you want it to email you or send an SMS and so forth. And so here we'll say, we'll generate an email. And because maybe we're just getting started, and that's Toby and I in our garage, we'll send an email to both of us when we see these 500s. Okay, so that's how you can create a simple alerting policy that notifies you when there's an issue in App Engine. Okay. So we've demonstrated how you can configure an endpoint check that will notify you if there's an issue, if it goes down, if the front end goes down. We've demonstrated how you can get access to rich metrics for App Engine. That'd be a very similar experience if you were looking at the other Google Cloud Platform services. And then how you can dig into the log data to get to root cause, and finally how you can now configure alerts to notify you when issues occur. Okay? So that's getting started. Now, if we were very fortunate and our project worked out, things would get serious after a while as we have more customers and a more complex system and a larger team.
We're totally getting serious, Dan. So right, when you're first getting started, you just want things to get out of your way. As you're starting to get serious, you want more sophistication from your monitoring and logging platform. And we're here to help you with that. But what do we mean when we say we transition from getting started to getting serious? I mean, we have a couple cute slides, but what are we really talking about? So when you're getting started, typically you develop on machines. You might only have 3 or 4 of them in your whole fleet. You probably care very deeply about each and every one of them. They're all special flowers, and they probably all have names. You probably have one that's running your front end. You probably have one that's running your back end. There's probably a couple that are running your data store or something like that. When one of those goes down, it means something catastrophic for your application. As you start getting serious, that becomes less true. You start thinking less about individual machines and more about clusters. You start understanding a little bit less about the entirety of your architecture, and you start to understand, well, I basically know how this thing works over here, but there's other folks who are working on that who know a lot more about it than I do. When something's broken when you're getting started, again, you just have these 3 or 4 machines. It's a big deal. If that front end goes down, your entire site is gone. If the back end goes down, all of your fantastic data is gone, and you can't show anything interesting to users. When you're getting serious, well, you think about things, because for the most part, when things get large enough, something's always broken. So really the question you want to answer is it something I care about? So if you have those same 3 or 4 machines that you used to use for everything when you were getting started, you might have repurposed them into a Redis cluster a long time ago. And now, if all 4 of those go down, you just might not care. That's something you get to on Monday morning while you're having your coffee. But on the other hand, if you're experiencing 500 errors that you're throwing to your users, you always care about those. That is something that you want to have you wake up in the middle of the night for. So you need to understand what the difference between these different types of failures is when you're getting serious. When you're getting started, the development team is just you. Like I said, you have everything in your head. You know the entire system. This is your baby. As you start getting serious, you might have a team of 10, 20, 30, 40 people. Your grasp on the particulars of what's going on is starting to slip a little bit. You still talk a good game in meetings, but really you don't know exactly what's going on all the time. So Dan's going to talk now about what it means when you start getting serious and how we can help you still understand your application.
Thanks, Toby. And so the WalkShare application is actually an app that's on the verge of a serious app, right? Because with this Redis cluster, things start to look more like a distributed system. And so some of these patterns that Toby talked about are going to emerge, right? With the cluster, we'll talk about how you can get visibility into that cluster that's running on GCE and get the right metrics out of it. We'll talk about how, now that you have a distributed system that's fairly complex, you may want to create a view that's all your own, and how you can take information from different parts of the platform and create custom dashboards. We'll talk about how you can get log data, access to log data for VMs that are running on Google Compute Engine. And then finally, how you can create alerting policies that are cluster aware, right? This is a really important part of managing distributed systems in the cloud. And so we'll show you how things look when you're kind of getting serious. In this case, we'll start with the homepage for cloud monitoring. One thing you'll see on the left here is that we've identified a couple groups of nodes, right? The first is this Redis cluster that we were talking about. And so we've discovered these groups by analyzing some metadata around the VMs. In this case, we saw that there was a pattern where you had a lot of machines that the name started with Redis. Right? And you could define your own groups. The great thing here is that they're filters. They're dynamic. So if I add a new Redis node, the machine will automatically be added into the group. And you can do this. You can define groups based on accounts or regions or tags. There are lots of different ways that you can do this. Okay, so this notion of a group is really important as you scale up. And now we'll want to get visibility into that group of Redis nodes. And so we'll go and we'll take a look at our dashboard for the Redis nodes. Here you see the same operational dashboard where on the left we have the configuration of the service, and on the right we have key metrics. Now, out of the box with no configuration, what you'll have is visibility into CPU, as well as network and storage I/O for the VMs. But if you deploy the agent, you'll have access to much more detailed system-level metrics. So this would include CPU steal, memory, how full each of the disks attached to the VM are, and then also information on specific processes running on the machine. Okay? So this is the visibility that you get into kind of the core system stats. But also, with a simple configuration file, you can tell the agent to monitor Redis on those machines. And once you put that file on the machines, then the agent will know to pull Redis stats and send them to our service. And then you're done. What will happen is the Redis statistics will show up on the dashboard automatically. We'll know that they're Redis machines. You don't have to do any other configuration to get visibility into the Redis stats. And here you see we'll have Redis connections and memory and expired keys and so forth. And these metrics are also now available throughout the system. Okay? Now, if we saw an issue as we had with the App Engine module, we could dive in and take a look at the logs. But before we do that, let's take a quick look at how we would create a custom dashboard that gives us visibility into different parts of our app. So first, you see we have our custom dashboard. I've added a couple charts to this dashboard as defaults. The first, on the left, you see an overview of production CPU across a larger cluster. Right? Now, if you've managed large environments, you know that it can be a little bit difficult sometimes when you have too much data on a chart. Anyone had that experience? Yeah, I guess a bunch of you. One great thing here is we can go to full screen mode for that chart to get a broader view. And then it looks like there's some interesting activity here. So what I'll do is we'll go into X-ray mode. Right? And X-ray mode is a way, especially when you have a lot of time series on a chart, a way that makes it easier for you to see the trends. So you can see here we have a set of machines, it looks like in the cluster, that are hovering around 40% CPU utilization. We also have this band of machines that are hovering right around 60. And then there's some noise right up at the top. So what I'd like to do is sort by volatility in the legend to see what the most volatile machines are. And in fact, it looks like there's one machine, this alerting API, that's much more volatile than the others. So this might be a case where we want to, often we want to terminate the node and start a new one, but in this case, we may want to dive into the logs to see what's going on with that node. Okay. So again, we could go back to our Cloud Console and access the logs. And now, for the first time, we have rich access to the logs for the machines running on GCE. And the great thing here is you don't have to SSH into the machines to get access to the data. All of the log data from all of the machines come into one place. Right? And it's easily sortable and filterable and so forth. Okay? So this is how you would go into the log data for machines that live on GCE to help diagnose issues in this cluster. Okay? And then finally, in this case, we can also look at the live updating logs. Finally, and probably most importantly, alerting. Right? So this is a cluster. It's dynamic. We're adding and removing and recycling machines all the time. And so what I want to do is create alerting policies at the cluster level. Right? And because we have this group capability, we can do that. So we'll specify here that we want to create a policy to tell us if more than a third of the machines in the cluster are, let's say, overutilized. So CPU is over 50%. Okay? So this will only trigger if more than a third of the machines in the cluster are over 50% CPU utilization. And this doesn't matter if you add 10 more machines to the cluster, it will automatically incorporate those into the algorithm. Here again, we see a preview. We can now add a second condition. So because I'm thinking about the cluster, I might want to think about the health of the cluster overall. So I'll aggregate the metrics. I could do, say, the average CPU across all the nodes in the cluster. And so we'll select our metric. We'll specify the Redis cluster. We'll choose CPU. And then we'll say if the average is over 40% across the cluster. Maybe this is a case where it's telling us we need some more capacity. Okay. And we could have just as easily done it based on the standard deviation of the 95th percentile or 5th percentile or otherwise. Now also, given that we have two conditions, we didn't just create two alerting policies. We created two conditions for the same policy. And that's important because we may not want the alert to fire unless both of the conditions are true. So you could imagine that you have a metric for your App Engine module connecting to Redis, and you might want to look at two different metrics as conditions and then only fire the alert if both of the conditions are true. Okay. Here, we have a larger team. As Toby showed, we're a successful crew. We have 40 engineers, and maybe this is a serious enough issue that I want to email everyone. Right? And so right in the notification framework, you can say that you'd like everyone to be notified. But as Toby said, not everyone knows exactly what's going on in every component of the system, so we can also add README information to the policy. So to say, if this occurs, maybe you want to try these 3 steps. Right? So that's how you can create an alerting policy in a more sophisticated environment. And you'll see that there are lots of options in terms of making it really effective to alert at the cluster level, right, in a distributed systems environment. Okay. So this is how the monitoring system can scale when you get to a larger environment. Finally, what Toby will show us, talk about is some of the lessons that we've learned. One of them is take advantage of some of the integrations that are built into the platform. So as you get larger, it might be fine to get an email alert when things happen getting started. But as you get larger, you may have a team that hangs out in chat rooms because you're spread around the country. And so you may want that to trigger into a chat room, in this case, Campfire, or a HipChat, or whatever you use. You may also have an operations team and on-call rotations. So if you use PagerDuty, there's native integration with PagerDuty so that we can escalate issues directly there.
All right. Well, thank you, Dan. As Dan said, we know we've given you kind of a whirlwind tour of Google Cloud Monitoring at this point, and we really don't expect you to remember everything that we showed or all the fiddly little menus that we went through. But if you remember nothing else, just take away a few things so when you do start using this, you can be successful with it and really make the most of it. First of all, we talked a bit about groups, but groups become vital as your team grows. When you're just getting started, you might not care all that much about groups, but once you start getting even 10, 15 machines, this starts to become invaluable. You don't need to keep track of which individual machines are associated with Redis, which ones are associated with Cassandra. As these things grow and contract, your alerting rules and your monitoring dashboards grow and contract to take advantage of these things. Plus, it's just a great way to navigate the complexity of a sophisticated system. Second, go nuts. Be your own person. We provide a lot of personalization with the dashboards. We have reasonable suggestions for things like App Engine and Compute Engine, Cassandra and Redis, but that's just our guess for what these dashboards should look like. If you disagree, go change it. Add the metrics that you want. Add the screens that you want. You can bring in any information, any data. You can have any number of these graphs on screen. You can even do things like drag them around and change this color scheme if you want. This is your system. Make it your own. And finally, we've talked a lot about alerting, but we really can't emphasize enough both how powerful and potentially useless and dangerous alerting can be if you don't use it right. So be thoughtful when you're setting up your alerting conditions. Understand the questions that you actually want to answer and go from there. If you're alerting on, say, one Cassandra latency problem that lasts 1 minute, and you're waking someone up at 3 in the morning, your team is not going to be happy. By the time they wake up, the problem's probably resolved itself. Even if it hasn't, the rest of the cluster is probably behaving normally. Dan showed a few examples of the sophisticated sort of rules that you can apply to do the things that you actually want to accomplish with your system. So think about those. Set the alerts up so that they're meaningful for your team. And revisit them occasionally as well. The things that are useful now might not be the same things that are useful 3 months from now when you've again doubled in size. And that's it. Thanks so much for coming and listening to us talk about Google Cloud Monitoring. We're super excited about it, and we hope you are too.
Yeah, and we're really excited that you decided to spend an hour on your Thursday afternoon with us. We're also excited because today we started the Trusted Tester program for Google Cloud Monitoring. And that means that if you're a current Google Cloud Platform customer, if you log into your developer console, you'll see a new link on the left for dashboards and alerts. If you click on that link, you can request access to the Trusted Tester program. It's also, yeah, we can show you exactly how that happens. So you'll see dashboards and alerts. If you click there, you'll see a button to request access. Unfortunately, we can't grant everyone access right away, but certainly we'll do it as quickly as we can. And then secondly, if you're not a current Cloud Platform customer, it's also a good day. And that's because you can claim a $500 credit to get started on the platform. Okay. And at this point, thank you very much, everyone. We'd welcome any questions or feedback that you have. We'll just ask you to use the mics here in the center aisle. Any questions? Sure. Right here in the front.
Hi, guys. Thanks. Great talk. I was very impressed by the metrics and alerting that was demonstrated. And I'm wondering if there is a way to alert on a single metric that is comparing itself to a different time.
Oh, not yet. Not today. This is a request that we've gotten in the past. Great feedback, something that we'll take into consideration.
Hi.
I'd like to ask if it's possible to create custom metrics and custom notification.
So custom metrics are not yet available. They are something that we hear loud and clear are very important. In fact, it's been our #1 request so far. Custom notifications, what you do have the ability to do is configure a webhook as a notification endpoint. And so then you can just specify the path of the webhook, and we'll send the data there.
Thank you.
Yeah, thank you.
Very impressive tool, I have to say.
Oh,
as an experienced user on GC. A question is referring to the extending of the agent. That's what the custom metrics, I guess, you're referring to, right? At the moment, it's impossible to extend the agent for my own application?
Today, it is not supported to add new plugins or metrics to the agent. The agent is based on collectd. It's a package of collectd, which is a really popular open source agent framework. Today, we don't support custom plugins to collectd. But as I said, support for custom data coming into the system is really important for us, so we know that it's an important request.
Right, and the second question is, what is the mechanism to send my own logs to the log infrastructure that you provide?
We have a FluentD agent that we're using on GCE instances that you'll be able to configure to point to your logs.
All right, and there's an endpoint I should send the log to? Somewhere. I should install the FluentD agent on the instance and send the logs to wherever endpoint.
You can just specify where the logs are stored, and we can configure the FluentD agent to find them there.
All right, cool. Thanks.
Great, thanks for your questions.
2 questions. Does this add extra cost? If I have a lot of logs flowing in, am I paying for an instance to maintain those, or is that sort of free as part of the rest of the system?
So the capabilities that we showed you here today are available to trusted testers at no charge. We don't have pricing finalized for the service, but it's our intent for native things at a minimum, the platform services, to not charge for the core monitoring for those. Okay, and then the logging, is there any
charge? No, there's no charge for monitoring right now.
No. Cool. And does this provide, or will this provide more information about the containers and the external, sort of the equivalent of the physical PC, or is this mostly just about the operating system and inside?
Oh, could you restate the question?
So this seemed to monitor things like my Linux and my application. Are there statistics also for the outside, the virtual PC, the container, or what I'm running on in the cloud?
The VM? Well, out of the box, so before you deploy the agent, there are some metrics that are available basically with the hypervisor looking at activity between the hypervisor and the VM. So that would be kind of core CPU usage and network and storage I/O. But beyond that, no, I don't think so. Not really.
Okay, cool. But those come from the hypervisor, then the core CPU?
That's right. Yep. Yeah, great question. Any other questions or comments? All right. Well, thank you again, everyone.
Thank you so
it looks
much.
like, or you could come up and ask questions after as well, but it seems like we have one more here.
So maybe a heretical question, but you started being an amazing monitoring tool on AWS. Now you were acquired by Google. Will you be able to do this for both my AWS and my Google Cloud usage?
Well, we can't really, comment on future plans. We're going to let our customers, help to, inform that decision in the long run. So certainly, there are existing customers using the Stackdriver product. We plan to continue to support them, in perpetuity. The support for AWS and Google together and other cloud platforms and Google together is something that we're looking for, our customers to help us decide.
Thank you.
Okay. All right. Thank you, everyone, for your time.
Thanks again.
At Udacity, we're reimagining education by teaming up with industry leaders like Google to create courses on the cutting edge of technology. Today, we're announcing 4 new courses developed with Google in Android, cloud, web performance, and UX design. For more information, visit udacity.com/Google.
Hi, I'm Greg Rosenberg, User Experience Lead for the AdWords platform. I'm here to show you another side of Google design, one perhaps you're unaware of, designing our advertising products, many of which are listed right here. Specifically, I'm going to tell you about designing AdWords, our flagship product used by customers who create ads on Google search results, those results you see marked with the yellow-orange ad tag in front of them. These customers can be small businesses like your corner grocer, or a large advertising agency that manages online advertising campaigns for big spend brands. Like all design work at Google, this is fun and exciting work. However, it's truly unique as it has the biggest impact to businesses and the biggest impact imaginable on Google. Advertising revenue is our primary revenue source. I'm here to show you how critical fast, intuitive, and beautiful are when literally billions of dollars are on the line and the resulting challenge that creates for the designers that create these products. Okay, so imagine you're a designer working on AdWords. Every design decision you make could have a huge impact on the customer's business, and that customer feedback works back into the product's design. Big pressure? Yeah, sure, but also a really big reward. Let me tell you about our challenges and goals. We deal with tons of data coming in from lots of different back-end systems and factor them into our designs. Let me show you an example. This is our simple and elegant alert system in AdWords. We have a red bar that goes across the top for critical alerts like an expired credit card, or in this case, having to review terms and conditions. And we also have this simple menu for less critical alerts. Clean and simple. This all looks really straightforward, right? But it's not. By digging deeper, you can see by looking at this diagram that this really simple UI actually pulls in data from lots of different sources, and a lot of logic has to be applied to figure out the right alert to serve at the right time to our customers. Our designers not only have to figure out what the UI looks like, but have to figure out in what order to show things, how much to show, and what to show and exactly at what time, depending on the user's context. Our job is also to make the complex and powerful into something really simple and intuitive. This is the keyword setup screen in AdWords. This is one of the screens customers go through when setting up AdWords for the first time. Keywords are either single or a combination of words that trigger the customer's ads to appear on Google search based on the query that was entered. Okay, for example, if I own a music equipment store and I create an ad for it with the keyword buy a drum set, my ad will appear on Google search when someone Googles buy a drum set. Setting up keywords is one of the critical aspects of AdWords for customers to do effectively so they get the most out of it. Our old keyword entry screen shown here wasn't as intuitive. It assumed a lot of existing knowledge on the customer's part. It was cluttered, and as I mentioned, it was pretty unintuitive. Our new one here is much cleaner and inviting. It gives the customer an automatically added set of suggested keywords that would work best, including search popularity for each keyword, a cleaner way to add their own keywords, and a widget that tells the customer what their reach will be for the keywords they've entered. We let the data become the UI and get the UI, etc., out of the way. We recently redesigned AdWords. This is the before. As you can see in this design, a lot of the screen is taken up by this big green bar at the top. There's a white header above that. There's additional links on the top right. And generally, the user interface is lacking polish. In the new design, or after, we've consolidated the top two header bars into one, updated the visual design style to match the general Google style, so the gray top toolbar, red buttons. By bringing in these changes, customers can focus more on their data and less on the controls and widgets that get them to their data. This is in Google's DNA. You see it every day on our famous and simple homepage, and that design philosophy is also being reflected in our advertising products. What have we learned as a team? We've learned that beauty and design quality of our advertising products not only improves them aesthetically, but makes advertisers more effective. Specifically, Refined design gives advertisers confidence in the product. With a variety of design improvements that have come to AdWords, both large, like the redesign I showed you, and feature-focused changes like the alert system and keyword entry system, we've seen our customers more engaged with the product, and we receive positive feedback that they feel better about the experience of AdWords meeting their advertising needs. With our recent redesign, we've also received a lot of feedback that the product was faster, but no performance changes were made. It was all design. This is the power clean and simple design can have. Clean, well-designed products feel faster. Don't overwhelm customers with every possible option. The alert system I showed is a great example of this. We used to show customers all alerts all the time, just stacked on top of each other, burying data that they couldn't see without scrolling. We did this because we were concerned customers wouldn't find alerts if we didn't expose them. We found with a cleaner design and some alerts even hidden behind a menu that customers are not only finding them better, but acting on them more than ever before. Interested in learning more about being a designer at Google? Check out our Google by Design site. And for more information about AdWords and other advertising programs, check out our Google Ads site. Thanks for watching.
If you're writing a 2D game on mobile, chances are that you care a great deal about rendering performance. But one of your biggest perf problems could be coming from a weird combination of alpha blending, overdraw, and how you create your texture atlases. But let's start at the top. Modern 2D games are awash in awesome graphics to create the visuals for their scene. But when you start to break it down, you realize that drawing your environment is actually a complex dance involving drawing multiple layers of graphics. For example, the background layer, ground info, sprites, and finally UI data. And every now and again, though, we'll see some weird additional layers pop up that don't end up contributing to the final scene. In reality, these extra draws create a lot of wasted performance, which is a scarce resource on mobile platforms. There's really two ways to look at how you render your graphics in your scene. The first is back to front order and generally involves drawing geometry farther from your camera before geometry that's closer to your camera. The end result is the last drawn pixel with the closest distance to the camera. Front to back order, on the other hand, draws images closer to the camera first and then progressively gets further away. Although the rendering order of both of these techniques produces the same final pixel color, back to front produces 2x more work that doesn't contribute to the final scene, or as we prefer to call it, overdraw. The reason for the performance difference has to do with how modern graphics APIs work. You see, OpenGL ES and all of its desktop brethren support a mode called depth testing, which allows you to avoid processing any pixels that don't contribute to the final image. Here's how it works. When a pixel on the screen is updated with color information, we also store its depth from the camera. When the rasterizer attempts to draw another pixel at that location, we first test the depth of the incoming pixel against that of the existing pixel. If it's farther from the camera, then we discard it, saving cycles since we don't have to compute any of the color. Now, if the incoming pixel is closer to the camera, on the other hand, then we continue on, compute its color information, and write it back to the color buffer. Overdraw is a term used to describe how many times a pixel on the screen has been redrawn in a single frame. For example, drawing a large background image like this, and then drawing a box on top of it, another one on top of that, and then finally putting some font on top of that. When you turn on your profiler's overdraw mode, you can see the parts of your screen that have been processed the most times. If your screen is super red, like this one down here, then chances are you've got performance problems. Any work you do on a pixel that doesn't contribute to the final scene is wasted work. Now, for 2D games, alpha blending is the single biggest source of overdraw. Generally, a majority of the scene has to be rendered with alpha blending turned on because those textures use some geometry that have an alpha channel component in them. When you render your objects in your game with alpha turned on, you're forced to render your scene in back to front order. This is because during each draw, the alpha operation needs existing pixels in the color buffer to blend against, which increases the number of times a given pixel on the screen gets redrawn. The truth is, the order in which you draw your game geometry has a profound impact on the performance of your game. In an ideal world, what you want to do is render all of your opaque geometry in front to back order, which will reduce the amount of overdraw that occurs, while rendering all transparent geometry in back to front order, which we're forced to do anyway in order to get the look we're after. But this is easier said than done, trust me. I ran an analysis over 1,000 games from Google Play and found the majority of them are packing both transparent and opaque images into a single texture atlas. Typically, this is a bad idea. Texture atlasing software that's used to do this operation doesn't always export the type of per-image information that allows you to know what was originally transparent and what was originally opaque. The result is that you're forced to assume everything in your scene is transparent and render everything in front to back order, regardless of the performance problems involved. To fix this in your game, it's actually pretty simple. When creating your atlases, split your alpha and opaque objects into separate textures. This will allow you at runtime to sort geometry based on what type of texture it has before rendering them to the final scene. The new process will help reduce overdraw and will help make your scene render faster. Oh, and one more thing. Once you've separated your opaque textures into their own atlas, make sure that you properly compress them with GPU texture formats. ETC, PVR, and DXT are supported all by various levels of hardware and will reduce distribution and GPU residency sizes of your textures, which is something everybody loves, right? Anyway, the truth is that you shouldn't take alpha blending lightly. Besides giving you the look you're interested in, there's a load of performance issues you may not be aware of. So think twice, alpha once, and as always, remember, perf matters.
Hi, I'm Dan Amanzadi, an engineer on the Android Wear team. If you build Android apps, you may be wondering how to update your app to work better on a wearable form factor. To give you a better idea of the changes you might want to make, in this talk I'll tell you how we updated Google's own apps to better support Android Wear. I'm going to focus on 4 apps that showcase different aspects of the Android Wear APIs: Gmail, Hangouts, Camera, and Google Maps. Each of these apps illustrates a different set of features of the Android Wear APIs. Let's start with Gmail. Gmail generates 2 types of notifications on your phone. A notification like this when you have one email, and a notification like this when you have multiple unread emails. The notification for one email has a snippet of the email and 2 actions, archive and reply. Without changing Gmail at all, the notification would be bridged from phone to wearable, and it would show up as a card in the stream. You could swipe on the card to select reply or archive. The problem is that the reply action would do exactly what it did when selected on the phone. It would open up the Gmail app on your phone so you could type a response. So the first thing we wanted to do was to allow people to speak quick voice replies to their watch so they could answer emails directly on their wrist. The Android Notification API now lets you annotate a notification action with a remote input, which tells Android Wear that you'd like to collect a bit of freeform text via speech before performing the action. When we build a notification in Gmail, we attach a remote input to the reply action. Android Wear sees this remote input, and instead of firing the action immediately, it first launches a transcription UI to collect a spoken response. Then it puts the transcribed text into the intent before firing the intent on the phone. When Gmail starts up and sees this text, it knows that it has what it needs to complete the reply action, and it can go ahead and send the email without bringing up any UI on the phone. So adding voice replies really just required 2 small code changes. First, changing the reply action to include a remote input, and second, modifying the activity that received the intent from this action to see if the intent included a text response. What's cool is that the notification experience on the phone is unchanged. If you select the reply action on the phone's notification shade, Gmail starts the same activity, but since the remote input isn't populated, it displays the compose window as usual to let you type a response. Now let's look at the multiple message notification, which uses the multi-line inbox style. Instead of putting a bunch of short lines of text onto a single card, we wanted to have one card for each email in an expandable stack. These bundles, or stacks of notification cards, are a new feature in the Notification API. Instead of posting one notification with all of the email threads coalesced, we post multiple notifications, one per email. But all of these notifications are marked with the same group key, indicating that they're related and they should be grouped as a card bundle on the wearable. Now we get a nice stack of cards, which you can fan out by tapping the bundle and read the cards individually. Notice that each of the cards in the bundle can also have its own actions, so we can now reply to or archive a single email from within the group, just as we did with a single email. Notification bundles also have a sort key, which you can set to control the ordering of cards within the bundle. You can mark one notification in the bundle as a summary notification, which is representative of the group as a whole. For Gmail, we flag the original inbox-style notification as the summary. The summary notification is displayed on the phone's notification shade, and the bundle without the summary is displayed on the wearable. Next, let's look at Hangouts. Hangouts messages are automatically bridged to the wearable too, but we wanted to make some changes to fine-tune the experience for Android Wear devices. As with Gmail, we wanted voice replies, but the Hangouts notifications are a little bit different. They don't have a reply action, just a content intent that opens up the app so you can type a response. This shows up as an open on phone action on the wearable. Fortunately, the notification API now lets you specify a distinct set of actions on phone and wearable. The phone actions will only be displayed on the phone, and the wearable actions will only be displayed on the wearable. This allowed us to add a wearable-only reply action, which includes a remote input without changing the phone behavior. Hangouts also uses another new notification feature, notification pages. We thought it would be useful if you could swipe sideways on the main message card to see a second page with the recent conversation history. This isn't really necessary on the phone because you can just open the app to see the conversation history, but on the wearable, it's nice to get a little extra context before speaking a response. To do this, we use the add page method of wearable extender, which allows you to add extra pages of content on the primary notification. We put the chat history into a second big text style notification and add it to the primary notification as a second page. Once again, the notification experience on the phone is unchanged, but on the wearable, we get the second page of content showing the chat history. Here's a full example of Hangouts on the wearable. This is a picture message with one page for just the photo, one page with the chat history, and a reply action for recording a quick voice reply. Let's move on to camera. We wanted to add a fun little feature to Google's camera app that would let you trigger a shutter release from your wrist. You've probably seen high-end cameras with remote controls, and the idea here is the same. You put your phone on a tripod, or maybe you lean it against a wall, or you give it to someone to hold, and then you capture a photo by tapping a button on your watch. With Gmail and Hangouts, we did entirely phone-side integrations, using only the notification APIs, but for this use case, it made sense to build a wearable app for a couple of reasons. First, it wouldn't really make sense for the camera app to post notifications to the phone shade when it was already running full screen, so we knew that the behavior on the phone and the wearable had to be asymmetric. Also, we thought that for this use case, it would be appropriate to take over the entire screen of the wearable with the shutter button, instead of confining the button to a card in the stream. So we built a simple app to run on the wearable that communicates with the main camera app using Google Play services. When the camera app is ready to take a picture, it sets a data item indicating that it's ready to accept remote shutter messages. This data item is read by a service within the wearable app on the watch, which displays a shutter button. Tapping the button sends a message back to the phone to trigger a shutter press. Finally, to preview the photo you just took, the phone app creates a thumbnail and sends it back across to the watch as an asset within a data item. The wearable reads the asset and displays it full screen for preview. Here's what it looks like end to end. I open the camera app on my phone and I see a stream card. I can tap the card to launch a full screen activity with a shutter button. I tap the shutter button, and after a countdown, my phone takes a photo and I see a preview on the wearable. Not a bad selfie. Let's move on to Google Maps. During turn-by-turn navigation, we wanted to show direction prompts on your wrist. These can be especially useful when you're walking, since it's awkward holding up your phone, and it can be more convenient to leave it in your pocket and refer to turn descriptions on your watch. Because we wanted fine-grained control over the layout and the presentation of the directions displayed on the wearable, we decided to build the Google Maps Wear app that rendered custom-drawn cards as local-only notifications. We modified the Google Maps phone app to update a data item with the description and the icon for the next maneuver and info about the navigation state. The Maps Wear app listens for changes to this data item. With each change, it reads the new data and updates the card on the wearable. To draw the card, the wearable app uses the new display intent feature of Wearable Extender. You specify an activity to draw the content within a notification card. This lets us draw whatever we wanted on the card, instead of being constrained to the standard notification styles. Cards in ambient low power mode, or in this peaking state, still have to use standard notification templates, but when you swipe the card up into full view, the system crossfades the card into a custom view drawn by the custom display activity. It's a bit of a bummer that you have to use standard styles in peak mode and in ambient mode, but Android Wear does introduce some new wearable-specific notification templates, like Big Action style and Content Icon style. One last feature. We also wanted to let you start a navigation session by speaking a voice command, like navigate to donuts. To do this, the Maps Where app has an activity with an intent filter for the navigate voice action, which creates an intent like this. The Where app receives this intent and sends a message to Google Maps on the phone that contains a destination and a travel mode. The Maps Phone app receives this message and starts a navigation session to the destination, and off you go. That's how we made Gmail, Hangouts, Camera, and Google Maps all ready for Android Wear. I hope it gave you a good overview of what you can do on the Android Wear platform, and I hope it inspires you to customize your own application to support a better wearable experience.
Hi, I'm Alex Danilo from the Google Developer Relations team. One of the things I found really hard as a web developer is making compelling animations on a site. It seems easy enough at first to throw some CSS animations onto a site and watch the browser fly stuff around you and you feel all chuffed when you first see it. But if you're like me, you want to make your site really stand out, be memorable, not just another pre-canned clone of something people have already seen. So I started experimenting with different web animation techniques and right away hit problems with doing fancy things. Like for example, I wanted to make two things animate in perfect sync, but couldn't find a way to do it really easily. My solution took 1,000 lines of code and was extremely choppy and riddled with jank. If only there was a better way. Now this is the kind of thing I wanted to build, a 3D hardware accelerated view of the world with silky smooth, jank-free animation and total control. Well, now there is a better way. A bunch of browser writers and animation experts got together a couple of years ago to look at this with a fresh set of eyes. Lots of eyes, in fact. We spent a lot of time discussing what web developers need, how animation designers work, and a whole lot more. What we came up with is Web Animations 1.0. We aim to take all the existing web animation primitives out there and unify them, and also bring new capabilities that weren't just more powerful, but would run faster and smoother as a result. Now, one of the best APIs to play with animation from JavaScript is, of course, Request Animation Frame, especially if you want fine-grained control of everything that's happening on a frame-by-frame basis. So let's take a quick look at how animation works when you use Request Animation Frame. Now, using Request Animation Frame gives great control, but forces JavaScript execution on every frame. Now, this is fine if you're not doing much in your JavaScript, but we only have 16 milliseconds for each frame, and that includes paint and layout time too. So if you run out of time, you know what happens? Skipped frames, resulting in jank, which some people call jitter. Now, this is the main reason it's a good idea to decouple the animations from JavaScript execution itself. So we wanted the flexibility of control from JavaScript, but not the jank, and so this is what we designed. The Web Animations API lets you create animations from JavaScript, then offload the animation calculations to the browser so it can take care of all the heavy lifting for you. And in many cases, it can take advantage of hardware acceleration, so there's very little work to do for each frame. Now what this means, it enables proper hardware accelerated animations to happen via the use of a JavaScript API, but without the slowdown from recalculating lots of stuff each frame. This is something we didn't have before, which is pretty cool, huh? I know what you're thinking. Yeah, but we already have CSS animations that are hardware accelerated. Right, well that's true, and by unifying everything,
So hi, welcome. My name is Melody McFessel, and I'm an engineering director at Google. I'm responsible for the developer tooling and infrastructure for our cloud platform and for Google engineers.
And my name is Thomas Istol. I'm a software engineer, and I'm the tech lead for Managed VMs.
So we're really excited to be here today to talk to you about DevOps at the speed of Google. Google builds some of the world's largest applications and services. Google.com, Gmail, YouTube. And the reason our developers are able to work efficiently to build and run these services is because we have a great set of tools. We've spent the last 15 years building and developing these tools, and we're so happy to be able to offer them to you. Today, we're going to talk through what Google offers you, developers, for getting code out the door to your users. But what do we mean by DevOps? You all probably have a somewhat different definition. DevOps is a way of bringing software developers and operations together. And I think the key here is integration. Learning and improving your code by bringing dev, writing your code, and ops, running your service and your code in the cloud closer together. Automate away the parts of ops you don't need to worry about. The goal should be faster development, faster deployment, and ultimately more predictable operations. So I've worked on a bunch of projects, experimental projects, as well as massive legacy systems. Some with small communities and others with hundreds of millions of users. And it can be so energizing, right, and invigorating to work on these apps. But it can also be frustrating and exhausting. We want to build cool features, but we end up spending a huge amount of overhead time. Overhead on release and deployment, or on operational work just to keep things running. And just to tell a story here, but I remember sleeping with my pager in my hand under my pillow for months at a time. And I still have nightmares of waking up in the middle of the night with that buzzing in my hand of some failure I needed to fix. So at Google, we think the cloud is about much more than just giving you raw VMs and storage. We can offer you much more than that. You deserve to have a platform that can automate away the time-consuming tasks that you don't need to worry about. To just get rid of repetitive DevOps tasks so that we free up your time to work on new features, apps, or new business ideas. So today we're going to show you some of the first steps that we're taking and the direction we're heading. We're going to focus and start when you already have a working app, and we're going to show you how to track down performance issues with your app, test it, deploy it, how you make sure that it stays running smoothly.
So we announced managed virtual machines at the Google Live event in March this year. With managed VMs, we combine the flexibility of Google Compute Engine, our infrastructure as a service offering, with the ease of use and reliability of App Engine, our platform as a service offering. If you're an existing App Engine customer today, you only need to change one line in a configuration file to take advantage of everything managed VMs has to offer. For this session, we'll use managed VMs to power all our demos. When you run your app on managed VMs, we set everything up automatically, so you get access to version deployments, software updates, automatic health checking. If a VM goes bad, we try to heal it by basically kicking it and restarting it. We do load balancing, scaling, logging analysis. We hook up debugging tools. We do performance tracking, and so on. So can we switch to the demo, please? Oh, and well, best of all, of course, let's not forget this. Google has a really good site reliability team spread out all over the world. So whenever there's a power outage, network cut, hurricanes, or anything else impacting the data center where your app is serving, you can trust us that someone from Google is awake and he's on track to fix it already, which means that we carry the pagers and you don't have to. Can we switch to demo? So having confidence that your app is running is just the start, right? Another key part of DevOps is understanding how your app is performing. So a benefit of managed VMs is that we hook up the infrastructure you need to answer questions like, how's the performance of my app right now? So here, I have the, I have loaded the Walkshare demo app. You might have recognized this from the previous session and from the keynote. So we got a bug report that says that as you load a lot of comments, this app is starting to get really slow. So I'm going to jump into a debug UI here that we implemented that can reproduce this issue. So to jump in to really reproduce the problem, we heard that whenever there's more than 5,000 comments, things get really slow. So I'm going to load here, and then we're going to see if we can reproduce it here live as well. So OK, there it loaded. But I could probably count to like 5, 1, 2, 3. OK, so at least a 3-second latency just to load the next 50 comments in our app. So this is obviously not what we want as we launch this app to customers. So a new feature in Cloud that we've been working on for some time is cloud tracing. This allows you to go in and look to see which RPCs your app is making. Let's load up the Cloud Trace UI here and dive in to see what's going on. So here's a list in the new Cloud Console that shows us the RPCs that are made by this app. So we see here we just had a request to the comment admin page running at 5,000, fetching comment 5,100 and forward. As we dig in here, we see here that, OK, the entire response took 2.3 seconds, so really slow. We spent some time in data store run query, but we also spend a lot of time just fetching additional data store results. So my suspicion here is that instead of fetching just the 50 comments that we care about, we actually fetch 5,000 comments, and then we fetch the 50 comments we care about. Clearly not good. So I'm going to load our source code viewer. This viewer is hooked up to the Git repository that's serving your app. So this is basically allowing me to browse the prod code we have right now. Well, I see here sudo install do not use offset, it is slow. OK. So this means that when I did an offset query, if I had read the documentation, I would have known that it's actually fetching everything up to the offset I'm looking for. Also in the documentation, it says that query cursors is the way to go. So I'm going to just delete this one, delete the code here, and I'm going to switch to this conveniently placed cursor implementation right below. And then commit it, so switch from set to query. As I hit commit here, we have hooks that notifies our build, test, and deploy pipeline that a change was made. And this is going to trigger first the compilation of all our source code. This is Java, so we need to compile it. Then it's going to trigger all our unit tests. And if everything is green, it will push it to our staging environment. So let's see how it's doing. As we load this page, we see that, well, now you guys don't. OK, here we go. We see that the deployment is in progress, but our prod app is still using the old version. So we don't have to worry about pushing things to prod by accident. So can we switch back to slides, please?
All right. So pretty cool stuff. We're going to talk a little bit about continuous delivery in a second, but I wanted to share some numbers behind the scale of Google's internal developer tooling and infrastructure. So each and every day, Google engineers will execute 800,000 builds, generating over 2 petabytes of build output, over 100 million test cases run, with over 30,000 change lists each and every day. Now, those numbers may seem large, but that's the type of scale that we want to deliver to you as part of your DevOps experience. So let's talk a little bit about the importance of continuous delivery. So understanding application performance, it's important, but it's just one part of the development lifecycle. The lifecycle starts with an idea, right? A feature. And then that turns into code. it gets tested, and then finally shipped. And reliability of delivery is important. You want to know for sure that the changes you're pushing are not going to break production. You don't want to just push and hope, just pray that everything's going to be okay. And you certainly don't want to be that, waking up in the middle of the night with that pager alert. So getting to live faster, it makes you happy, right? It enables us to innovate faster. Whether you're, working on a feature or fixing a simple bug, you want to see that change live in minutes, right? Not hours or days. And this allows you to update your application incrementally, right? With faster deployment, you have more frequent and smaller releases. So, right, you're updating your application incrementally so that you know if something goes wrong, it's easier for you to trace back to the issue and potentially roll back. So I know nobody likes it when changes take forever to get to production. But I think what's even worse is not knowing where your changes are. So deployments, we believe they should be visible and predictable. You shouldn't have to have a crystal ball or have to chase down a release manager or someone else on your team to know which bits are where. So from that Git commit that we made earlier, we triggered the push to deploy pipeline. As soon as we detect that new commit, we triggered a Jenkins-based job to build, test, and deploy the application. So Jenkins is an open source framework that provides a very easy-to-use continuous integration system. It enables developers to update their projects and attain a fresh build. And that's what we're using behind the scenes for the push-to-deploy workflow. So these changes should already be deployed in our staging environment. But now we want to promote those changes from staging into production so that our end users can benefit from this. And this really highlights the idea of DevOps, right? We're writing code, we see there's an issue, we track it down using tracing, we make the fix, we commit it again, we verify that it's in staging, and then we're ready to move it on to production. So let's take a look at our release pipeline. Can we switch to demo, please? All right. So I'm going to peek back and forth here. So you can see here that our change was uploaded successfully. And I think that the multi-stage release pipeline work, this enables us to bring together multiple projects and multiple environments. And the whole goal here is to make it easy for you, right, to bring those pieces together, to get your code out to your users with a push of your code or a click of a button. So here we can see it happened successfully. But let's actually go check to make sure that the fix that we committed worked as we expect. So I'm going to go back and I'm going to look at list comments. I'm going to click more. Seems pretty fast, right? OK, well, let's go look at the trace to be sure. Nope. All right, it's taking a second here. Reload it. OK. Seems like it's got updated. Demo gods in our favor, please.
At least everyone knows it's live, right?
Oh, there we go. There we go. So yeah, you can see here that the change is taking significantly less time. So that makes me feel better about pushing out to production. So now I'm going to go back to the release pipelines page in our dev console. And I'm just going to click promote. And that's it. In the background, we're going to start up another Jenkins-based job to build, test, and deploy our app to production so that our users can see the change. And the push will only happen if the build and test, if the results are all green. So switch back to the prezo, please.
So testing is important, but it's only important if you actually run in production what you tested earlier, which is why we're so excited to talk about the new Docker support for managed VMs. We had a full session about Docker and containers yesterday, and if you Google search for containerizing the cloud, it should be the first hit, and you can watch the recording of it. So a Docker image is a bundle that contains your application binaries, but it also contains all the dependencies of your application. This could be any static files you depend on, any operating system libraries you depend on, or maybe even the entire operating system you depend on. So all these files are shipped around as a bundle, which gives you confidence that whatever you run on your laptop is the same as you run in prod. So from a DevOps perspective, this is great because it gives us a testable bundle that's portable between environments. We can develop on our laptop for quick iteration. We can push it to staging. We know it's exactly the same bits as we test on our laptop. We run a big suite of tests on it in staging, and then when it's all green, we can choose to push to prod. And again, it's the entire environment of your app. So the build, test, deploy pipeline you saw here, it is a Jenkins build. It is compiling your source, but the actual build artifact it's producing is a Docker image. So here we bundle in your app, your libraries, whatever other dependencies you had, together with a super minimal Linux distribution, well, by default, if that's what you want to run. And we put this into Google Cloud Storage so that it's accessible from all the VMs reliably and quickly as the VMs boot up. So putting all this together makes managed VMs a really great way to package and run your Docker containers. So why containers then? Well, at Google, we're super excited about the increased external popularity of Docker containers. So internally, we're huge container users. We have been using containers since 2006. And we contributed C groups back to Linux kernel. We're continuously contributing our improvements, both upstream into the Linux kernel and into Docker Inc. Today, at Google, in production, we start over 2 billion containers per week. And we're really excited to take our experience with running containers and contribute that to the customers of Google Cloud Platform. So can we switch back to the demo, please? Well, we just pushed the fix to production. Now, let's go back and see if we actually improved performance. So in production, we could do the same small test as we just did in staging by checking individual RPCs and seeing how things are going. However, what you actually care about is whether this change improved performance or made things worse for our users. So with cloud tracing, we allow you to generate reports where you slice and dice your RPC data to figure out whether latency increased, decreased, whether error rates went up, and so on. So since we just pushed to production, I'm going to use data from earlier this week, since we don't really have any real production data just yet. So this is data from the same fix that I did a couple of days ago. So we see here, as we look at the latency profile of these RPCs, we see that the orange line is the new version. The median latency went down to 43 milliseconds. The resolution is so low here, so I have to scroll all the way over to the right to see the tail latency of the old implementation. But you see here, previously, the old implementation was running out in up to 4-second request response time, so not very good. And as you debug these tail latencies, it's really useful to be able to dig in deeper to figure out, OK, I see this request was really slow. So we allow you to go and look at representative traces in a given latency percentile. So I'm going to go in here, and I'm going to look at the old implementation, say the 90th percentile latency, and see what could go wrong here. And again, we see the step method with the data store calls just keep on getting repeated. Here, we fetched 8,000 150 comments before we got the 50 comments we were interested in. So this gives you the ability to really dig into your changes and make sure that whatever you push to production is actually improving what your users see. Can we switch back to slides?
Great. So I'm going to talk a little bit about testing. So server-side and web ops are just part of the story, right? Most services have mobile components too. And the mobile landscape is diverse, and it's changing all the time. And for developers, this presents us with great opportunities, but also significant challenges. So for example, 6 different Android OS versions each have a market share of over 10%. And other popular Android devices cover an even bigger span of screen sizes and pixel densities. So as a developer, we have to make sure that the apps we're building will work on our users' devices. And releasing with confidence in this type of environment that's changing so quickly, it demands testing across an extensive matrix of devices, API levels, and even languages. So let's see how the power and scale of Google can make matrix testing fast and easy. So can you switch back to demo, please? Go on the other side. OK. So I'm developing a new feature for the WalkShare app that we've been talking about. And I wrote some, and I'm doing that in Android Studio. And I wrote some tests using the Espresso framework. So I've tested my application against a local emulator, but now I want to test it against some of the most popular configurations for my customers. And I start running the tests in the usual way, but in addition to local devices and emulators, I see I have this new option here, Run Tests in Google Cloud. And I'm going to select that. And note in this dialog box here, you can see that the tests are going to run in my WalkShare Google Cloud project. So let's go in here. OK, so here I can pick the configurations I want to test against. And I have an existing set of matrix configurations already defined. You can see them here. I have some smoke tests. These are basic tests that I run with every change. I have some release tests. These are more extensive tests that I run with every release. And then I have some sample tests. Google will even use Play Store statistics to come up with a set of configurations based on the statistics that they've found. So I also have an option here of some configurations that will cover the most of my user community. And if I wanted to, I could even select all of the available test configurations to run. And it looks like there's over 1,700 here. But what I want to do is I want to dig in on the smoke tests. So I'm going to pick my device here. I'm going to pick Nexus 5. And I'm going to pick the platform. I'm going to pick API 18 and 19, or Jelly Bean and KitKat. I'm going to pick the locale, English and German. And I'm going to pick the orientation, which is portrait. So I can see here that my tests will run, these 4 configurations will cover 20% of my current users. So I also have this option down here to run tests on physical devices. And as you heard yesterday, we're very excited to welcome App Purify to Google. App Purify has a great interface to enable developers to test their apps against physical devices. And the interface is great. It provides very actionable feedback so that you can fix things that are wrong with your mobile app. App Purify shares Google's passion about making great mobile applications across both Android and iOS. So I can't talk about the specifics right now, but I can say that we do have plans to offer App Purify's platform as a cross-platform service for all of our developers. So now that I picked my configurations, I'm just going to hit OK. And I'm going to hit OK again. And we can see here that that Android Studio is building my application and running all of my tests. And it's going to upload them to a Google Cloud storage bucket. This is so it's not coming up quite yet, but from there, Google's going to run all of my requested tests in parallel. And as the tests finish, the results are going to stream back to the results viewer so that I know exactly what's going on. And as the tests complete, I can go dig in and look at the details. So you can see here that those 4 test configurations are still running. So we're going to do a little Julia Child, since they take a couple minutes. And we're going to switch over to the same configurations, but the tests have already completed. And it's interesting. Here I can see in the hierarchy the different API levels. And I can see that I have a test that's failed. And it's on API level 18, or Jelly Bean. So from here, I can actually go look at the code. Oh, you can see. I had a check in here to test for whether or not we're running KitKat and to throw an exception. So this is an example of being able to really dig in and find issues that you need to fix. Failure on particular APIs, it's a pretty common problem. But sometimes test assertions, they don't find all the issues that we need to know about. So with a couple of additional lines of code, my espresso test will take screenshots. Google will capture those screenshots and stream them back to me so I can look for issues that may exist in the UI that will affect my user's experience of the app. So I'm going to pick on this test that completed, and I'm going to go take a look. And I'm going to do some comparisons between my configuration. So remember, I picked English and German, kind of like this morning. Wanted to have US win. OK. So I'm going to scroll through these now. And you can see the comparison here. So OK, this is the second screenshot comparison. I can see it looks like there's a cutoff of the translation here. So that might be an issue. But OK, that looks pretty good. Looks pretty good. All right, here's another issue. Right? It's not lining up correctly. So, yeah, so I probably want to fix that. So neither one of these issues, would have been triggered by a test failure, but it's pretty convenient, pretty easy for me to be able to check for these types of issues. And be able to fix them so that my users have the best experience. We think you should be able to run matrix testing whenever you want, right? Not with release. And it should all happen in parallel, and it should be easy, and you shouldn't have to leave your IDE to do it. So we covered a lot in this testing section. You saw how we were able to run Android tests across multiple devices, OS versions, API levels, languages, all in parallel. And you also saw how you could look at the results. You could drill into the actual code to find out what was going wrong. So matrix testing with Google Cloud can help you develop and release quickly and confidently. And no matter which device your users are using, you'll be able to fix the issues and push those releases out to production. So can we switch back to the presentation, please? So we've covered a lot of content in this session, so I just wanted to quickly recap. We started out with managed VMs, Google's way of offering the benefit of platform as a service with the full power of virtual machines. Then we showed our new ability to capture trace application traffic, and then use that to identify performance issues. But DevOps wouldn't be complete without deployment. We've built upon the push-to-deploy concept and are expanding it to include multi-stage release pipelines. So you can know which code is where, and you can promote easily between your environments. And then finally, we showed cloud testing, an easy way to offer matrix testing for your build, test, and deploy cycle. So Google's working hard to deliver a full-featured DevOps stack for you. And the part that I'm most excited about is that we're just getting started. So thanks so much for coming today. Thanks for coming to I/O. We'd love to hear your feedback. We have a sign-up page there for managed VMs. And we also have this offer in terms of getting started on our cloud platform. We're happy to take some questions for a couple minutes if you'd like. And thanks again for coming. Come over here. Oh, and please use the microphones if you're going to ask questions. What's the other slide? Oh, yeah, thanks. All right.
Okay.
Thanks. Oh, okay. You're in the back.
Big room.
Give you time to walk. Sorry about that.
All right. Hello.
Hi.
So the question is, great stuff. So we've been seeing a lot of stuff on wearable and TV. So is there anything you can share in terms of where there's automation around testing for that stuff in the future, where that's going?
Not at this time.
Damn.
I don't know.
Okay.
We could try and hunt down the answer for you, but I can't tell you. Thanks for asking.
Hi. Everything looks really cool. So on the stuff with Android testing, is there just going to be support for Espresso's testing library to run with matrix testing, or are you going to support like Roboelectric, Robotium, all these other testing frameworks as well?
So yeah, we do want to support other testing frameworks. I think our philosophy is that we want to meet engineers, right? Meet developers where they are, and so decisions around using Jenkins, for example, to write plugins to support the build and test and deploy cycle is that's just one example, but I just used it as an example today because that was what we did for the demo, but we do want to support other types of testing frameworks. Yeah.
Cool. Thank you.
Thanks.
Great stuff. What actually did the screen capturing? Is that an API call within the test, or was that done by the CI job?
I think that was done by the actual test.
Okay, because we actually use Espresso over at Twitter, and I don't believe there is an API for taking screenshots, at least a stock API that comes with Espresso, so I was just curious about that.
So yeah, we've been doing this, we've been doing it internally at Google, and if you stay after, I'll get you connected with the folks on the team that have done it.
Great, thank you.
Hello.
Hi.
As far as I know, you use Jenkins to do the testing before deploying and stuff.
Sure.
Is it possible to get access to the UI of Jenkins, for example, to see reporting and stuff?
Yeah, that's a good question. We've written you saw the wrapper around it, because we wanted to make it as easy as possible for you to interact with the UI. But yeah, there is, well, if you can stay after, we could talk about it. But part of what we were trying to do with that is just, to make it simpler and easy to use. Have you spent a lot of time using the Jenkins UI?
Yeah, I've got an own Jenkins to do the reporting stuff, so
it
would be great to have it in just one place.
There. Yeah, we should talk about that after. But yeah, there's some challenges with the Jenkins UI. We've talked with the folks, Kasuke and such about. I think there's some great collaborations we can do there around making improvements to it. But yeah, it's a good question.
I will come by afterwards.
Yeah, thanks.
Hi. So most of the stuff you have demonstrated today started with the build.
Mm-hmm.
Do you guys have any plans to integrate code review tools like what internally Google uses, for example?
Where are you from?
I used to work for Google. So.
Okay, there you go.
And then the second thing is like dashboards, like TAP.
Yeah.
Like I ran tests like, okay, this test started actually failing with this commit essentially.
Yeah.
I want to know the history of the test essentially.
So you have the inside scoop, right?
Yes, but
so, yeah,
those things naturally fit as like the next steps.
Yeah.
So do you guys have any plans with respect to those things?
We've been doing a lot of thinking about that, and we're really excited about some of the things that we're going to be working on this year for customers. Great questions.
Thanks.
Hi, I used one of the first versions, I think, a few months ago, that you released with GitHub integration. So it builds Maven builds automatically, I think.
Mm-hmm.
The question is, we use 3 different builds. We have the continuous build, we have integration test, and then the larger one. How does that fit with what we currently have? You have those integration pipelines. Are they fixed somehow?
So, sorry, the question is...
I want to release to production
Okay.
as soon as the integration tests are completed, but that
Okay.
takes about 20 minutes.
Okay.
I want to release to some kind of demo environment after, I'd say, the continuous fast tests run through. So how are those release pipelines configurable? That's the main question.
Oh, good question. So you want the ability to set up basically multiple pipelines, right?
It might be related to the Jenkins UI, I think, to that question.
Well, it sounds like you want the flexibility to be able to say, okay, I want this kind of release pipeline for this particular type of application, and you want to be able to group those together.
Right.
So yeah, we've definitely been talking about the ways in which we can bring together different projects and different environments to make it easy. You're just seeing the first little steps that we're taking to do that. We're excited to do a whole lot more. But yeah, we want it to be as easy as possible for you to configure and set up different release pipelines so that you can manage them effectively. Okay. And it sounds like set up triggers around certain conditions as to when things will run.
Mm-hmm.
Okay.
Okay, thank you.
Great, thanks.
Hi, very interesting stuff, but you're hiding a lot of things, the Jenkins part.
Yeah.
And in the demo, you said you fix the bug, you build, you test, you deploy to staging.
Uh-huh.
And then when you show you deploy to production, you say you build again, you build, test, and deploy again. When you go to production, you just want to deploy the same thing as what we did in production. So if we don't have control on this, just wondering how much we will be able to... are you going to say you deploy like this? You build and deploy like Google decide, or can we choose?
No, you want to do binary promotion, right? So you want to make sure that you want to promote the Docker containers, so not only the build artifacts, but everything, the world as it looked when you ran the tests.
And when you say the button, the promote button, you're using the promote plugin, and you have a build job and deployment jobs configured in Jenkins, or?
This is just around the corner. It wasn't in this demo, but it's just around the corner.
Okay, thank you.
Just so I heard you correctly, the key there is that you really want the ability to configure at each stage what exactly happens, right?
Well, at least to know what happens.
Yeah, of course. Yeah. Forgive our demo magic a little bit. So, thanks.
Hi, somewhat related to the last question, how do you manage different configuration settings for your staging versus production environments? So you click promote, but you don't want necessarily the same application configuration used as you go up the stack.
So you basically different flags in different, well, they're completely separate projects, right? So you could imagine that you have configuration stored in, for example, a data store that contains your flags that allows you to go in and edit it before the next version. So that's one way you can do it. You might want to have configuration files separately.
So we didn't show any of the administration behind this at all. Okay. I don't know if the pipelines, if there's going to be another pipelines talk, but if you can stay after, we can get you some information. We did a couple of them, I think, at the sandbox, but it'd be good to, I think, probably give you some more insight into that because, yeah, we definitely didn't cover that today.
Yeah. Sure. Thank you.
Sure.
Hi. I was wondering, I've seen in all your demos that they're Maven-based. Do you support Gradle?
Yes, we're working on that. We're working on Gradle integration. We're looking at integration with other build systems.
Okay,
so,
perfect.
Yeah, I think the idea is to support what our customers, our developers are using.
Yes.
Yeah.
Thank you.
Thanks. All right, thanks everyone so much for coming. I know it's late in the day on Thursday. We appreciate it. Thanks for coming to I/O.
Mobile developers and designers use different approaches to achieve the same goal. creating 5-star apps that users love. While both development and design approaches are essential, they are usually considered separately. In user experience design for mobile developers, you'll learn how to integrate design approaches and techniques into your mobile development to build world-class apps. This is a design course for developers who want to give their users a great experience. For more information, visit udacity.com/Google.
Hi, I'm Will Haldane-Brown, and I'm a software engineer on the Android Wear team. Today, I'm going to talk about writing full-screen immersive apps for Android Wear. Many technical aspects of designing apps for Wear will be very familiar to you, as they work the same way that normal Android apps work. However, there are two big differences I'm going to discuss: how users leave your app, and how to design and implement your app to look great on a round screen. Let's start by talking about how users leave apps on Android Wear. On a phone or a tablet, users would use the back button or home button to exit an app, but those buttons are not present on Android Wear devices. Instead, there are two ways users can leave your app: by swiping from the left edge and by long pressing on the app. With Android Wear, we're introducing a new window attribute, Window Swipe to Dismiss. This window attribute can be specified in the theme of your activity. When the Window Swipe to Dismiss attribute is set to true, your activity will be dismissible when swiping from left to right. This swipe dismissal works similarly to how a view pager works. If the content inside the activity is itself capable of scrolling, the window will not be dismissed until the user scrolls to the edge of that content and then swipes again. This allows you to create awesome, stream-like experiences that are still dismissible by swiping. All Android Wear apps should either use the device default theme or a theme that inherits from it. This will ensure a number of styles are set correctly on your app to make it look great on Wear. It also enables swipe to dismiss. We recognize that some apps are not going to be able to use swipe dismissal. For example, a Maps app with an infinite canvas will never reach an edge. If you don't want to use the swipe gesture, you can disable it in your theme by setting the Window Swipe to Dismiss attribute to false. For apps that aren't swipe dismissible, we recommend that you use a long press in your app as a gesture to bring up an exit button. To inform users that your app supports long press to dismiss, you should show users a long press hint when your app is started for the first time. As you can see here, a long press anywhere on the screen brings up an exit button overlaid upon the app. Tapping that button finishes the activity, which brings the user back home. To make it as easy as possible to add long press to dismiss to your app, we've made a view that implements much of the UI logic for you, called Dismiss Overlay View. To integrate it into your app, start by adding it to your activity's layout XML. Make sure it's added in a place that will cause it to be drawn over all the other views in the layout. You should also ensure that the view is sized to cover the full screen. Here, I added as the last child of a frame layout and set its height and width to match parent. This will ensure that it draws full screen and over everything. Now let's look at your activity class. In its onCreate, pull the Dismiss Overlay View out of your layout and set its intro text. This is text that will display the first time your activity runs, as an overlay on the rest of your content, and should tell the user that they can long press to go back to home. Then, call Show Intro if necessary. That will display the intro overlay only if this is the first time the app is run. Next, you need to wire it up to display when your activity is long pressed, using a gesture detector and a simple on-gesture listener. Using these framework classes will ensure that the timing around the gesture feels consistent across all apps. When you get the long press callback, call Show on your Dismiss overlay. That will display the exit button. If the user clicks the button, your activity will be finished. But if they don't click the button, the Dismiss overlay will hide itself and wait for the next show call. Finally, still in your activity, override the onTouch event method and pass received touch events into the gesture detector. If the gesture detector returns true, you should return true and not pass the event to the normal activity onTouch event method. If the gesture detector returns false, use the normal activity touch handling. Now, let's talk about something different: how to make your apps look beautiful on the round screen of the Moto 360. First, let's take a look at the screen dimensions of the 360. It's a circle with a diameter of 320 pixels with a 30 pixel chin at the bottom. The system therefore reports its size as 320 by 290 pixels. As we learned during our own development process, the chin can cause some unintended results when porting existing layouts. Looking at the action cards in the stream, for example, we wanted to place the action icon in the center of the screen. But when we set the layout gravity to center vertical, the blue circle is offset by 15 pixels. We decided that it would be best to preserve the expectation of the center of a layout be in the center of the screen circle. In our device default theme mentioned earlier, the window overscan attribute is set, and the root of the view hierarchy is therefore measured at 320 by 320 pixels. This causes your app's top-level view to be measured at the same 320 by 320 instead of 320 by 290, and centering in your layout works as expected. How can you detect that your activity is running on a round screen? Your views can request to apply window insets and get a callback with a window insets object. That tells you the shape of the screen, and on the Moto 360, it tells you that the bottom inset is 30 pixels. You should use this value wherever you need to lay out around the chin. Using the insets passed in here will ensure that your app looks great on any future device. To save you from writing all this boilerplate code, we added a view called Watch View Stub, which allows you to inflate one of two different layouts, depending on whether your app is running on a rectangular or round device. You can use a Watch View Stub as the root of any view hierarchy you want to look different on round screens. To use it, create a new stub in your activity or fragments on Create. Once you've done that, you'll need to give your stub two layouts, one to inflate for round devices and one to inflate on rectangular devices. There's one snag though. Because these layouts aren't inflated until the view is attached to the hierarchy, you can't access the child's views yet. Instead, attach an on-layout inflated listener, which will be called when the appropriate inner layout has been inflated. Both Dismiss Overlay View and this Watch View stub can be found in the Wearable Support library, which also provides a new layout manager called Box Inset Layout. It extends frame layout and allows developers to use the same layout on both rectangular and round screens. In this example, we have a text view at the top left, a cancel button at the bottom left, and an OK button at the bottom right. When the same layout is used on a round screen, we want the view elements to be placed on the edge of the circle, not the square. This is achieved by adding the wearable layout box attribute to your layout. It defines the set of edges, left, top, right, and bottom, to be aligned with the inside box of the circle. This makes it easy to have backgrounds bleed into the full circle, but contain other elements to non-clipped areas. Here, you can see a text view boxed into the center square of the round screen. On a square screen, the layout box parameter is ignored. I'm really excited about the new platform, and I hope you all are too. I can't wait to see what apps you build.
Hi, I'm Tim Kilborn from the Android Framework team, and I want to talk about building great apps for Android TV. Android TV apps are developed using all the familiar components and tools from the Android Framework, so if you already have a great phone or tablet app, you're on your way to bringing that experience to the big screen. However, there are some key differences between developing for a phone or a tablet and a TV. In particular, the information density on a TV should be much lower than on a phone or a tablet. No one wants to read a wall of text on a TV. Also, the way we interact with the TV is through a D-pad, like a remote controller or game controller, rather than touch. So make sure all of the important elements of your app are focusable. Let's look at an example of an app written for Android TV. This app uses minimal amounts of text, and everything is reachable with a D-pad. Navigating to find something to watch is easy with these layouts. In fact, because this browsing concept is so common for a TV app, we've built a new support library to help you create beautiful, easy-to-use apps for the big screen. By using the widgets and fragments from this lean-back support library, you will be able to quickly create apps that work well on TVs. The lean-back support library is based on the model view presenter pattern. We've made it straightforward to separate the way you display your content from the model objects you use to store the data. The model objects come from your app. We don't put any requirements on them, so it should be possible to update an existing app to run on a TV without changing your model. The views are the standard Android views that you know and love, like text views and image views and so on. What's new for Android in this library is the presenter. Given a model object, the presenter binds the data from that object to a view that the library code can use to display your items in all the screens of your app. In particular, the same item can be rendered in different ways in different parts of your app simply by replacing the presenter. Let's look at some examples. Here we have a screen that lets the user browse through a content catalog. This is implemented using a browse fragment from the lean-back support library. The fragment is instantiated and given an object adapter that contains the model objects and the presenters used to render them. The library code in the fragment takes care of the rest, calling the methods in the presenters for each item to show the views in the rows. Next, we have a details screen. The same model object that was previously rendered using a small card view can now be rendered to show more details simply by using a different presenter. We also see rows of related content below the details overview, with presenters creating each of those views as well. In-app search works in the same way. Your app will receive the text of the query as the user enters it, and the search fragment uses the object adapter and presenters that you provide to show the results. There are a few other things you'll want to do to make your app look great on a TV. We've designed a new launcher that's optimized for getting you into the content you want to see as quickly as possible. And that starts with content recommendations. Using the existing Android Notifications API, your app can publish recommendations for videos or other content that viewers will want to see next. You specify the data, including the card image and the text, and the launcher will show the recommendations prominently on the home screen. The order of all these recommendations is determined by how the user interacts with them, so make sure you're creating high-quality recommendations that will make people want to return to your app. You can find more details and sample code for presenters, fragments, and content recommendations on the new developer site for Android TV. Thanks for watching. Now go make some great TV apps.
If you're an audio buff writing Android apps, then there's some exciting things showing up in L Developer Preview. My name is Andy, and today we're going to talk about sample rates for digital audio and how to give the best sound to your users. But hold on, let's start at the top and talk about audio sample rates. There's devices, content, and connectivity, and each one approaches sample rates differently. For example, this phone has a device audio rate of 48 kHz, but that doesn't guarantee apps on it will be using all of it. Game apps often use 24 kHz and 32 kHz sample rates. Streaming music comes in at 44.1 kHz. Streaming video, 48 kHz. Meanwhile, my hands-free Bluetooth is chugging along at 8 kHz, which means it's a jungle out there with sample rates, even just considering the smartphone. So what is sample rate anyhow? Simply put, given an analog audio signal, it's how often you sample its waveform. So when a game uses 32 kHz, we need to use a resampler to convert to the 48 kHz the phone needs. As you can expect, this process of resampling can cause lots of issues. Generally, the one problem everyone talks about is aliasing. Aliasing can occur when the audio frequency is too high for the sample rate. Then the high-frequency signal looks like or aliases as a low-frequency signal, as shown with the green signal on the right. The maximum audio frequency without aliasing is half the sample rate, also called the Nyquist frequency. In order to get rid of aliasing, we use a low-pass filter. A low-pass filter removes the high frequencies which cause aliasing. It has 3 bands. The pass band is for the audio frequencies, the stop band prevents high frequencies from aliasing, and the transition band is between them. So what makes a good resampler filter? First, finite length. With finite length, ripples occur. This is Gibbs phenomenon. Second, we want the ripples in the passband to be small to avoid distorting our audio. Third, we want ripples in the stop band to be small to avoid raising the stop band and allowing high frequencies to alias. Last, we want a narrow transition band. A shorter filter length means a wider transition band. It's related to the uncertainty principle between frequency and time. You want a narrow transition band. As you might imagine, designing really good filters are hard. Halving the transition bandwidth doubles the filter length, doubling the stop band attenuation doubles the filter length. Ugh, design trade-offs. Good news. In Android, we compute the resampler filters for you. Check out these links for information on how that works. There's lots of resamplers out there. Where do the ones Android Audio provides fit in? Like plants and animals, there are polynomial resamplers and filter resamplers. On the polynomial side, you've probably heard of linear interpolators and cubic splines. Those are typically used for images. We're a filter-based resampler. This is more typical for audio. In particular, we're using a windowed sync filter. Now, let's talk about Android Audio, where we've improved the resamplers. We have increased quality. In a spectrogram of a sine sweep, or chirp, we expect a single line. This means one input frequency corresponds to exactly one output frequency. This should also be true after sample rate conversion. Our example shows 44.1 kHz to 48 kHz after sample rate conversion. Before is the top. See that basket weave pattern? That's aliasing in harmonics. Bad. After is the bottom, which is much cleaner. This is at a low quality setting and means music for many devices will sound better. We dynamically compute filters for your frequencies. In a spectrogram of 48 kHz to 32 kHz, before is the top. Aliasing is present on the old resamplers as shown in the reflected line down. After is the bottom. Again, we clean things up. This is at our high quality setting and means we have less audio artifacts at different frequencies. We've also expanded the frequency range for use to any frequency between 8 kHz to 48 kHz. So resampling can be used for effects or reduce synthesis computation. We've increased speed. Our resamplers are about twice as fast as the older resamplers for comparable or better quality. This means more processing for other tasks and better battery lifetime. We've made it easier for you to use digital audio on Android. We'd like you to feel liberated to use different sample rates. Now it's up to you to make something great. Please follow these links for more information. Thanks for watching.
Everything has a location, whether it be the photos you took, where you are, the places you like to hang out, where you bought that special gift, or even the last place you met your date. I'm Megan Boundy, Product Manager for the Google Maps mobile SDKs. Today I'm going to show you some cool ways to use Google Maps mobile SDKs to help you both bring these experiences alive and delight and engage your users. In this session, I'm focusing on the Google Maps Android API v2, but all of this functionality is available in the Google Maps SDK for iOS as well. This is great if you're looking for cross-platform consistency for your apps. When developers think of having a map in their app, they often think of something like this, a marker on a map. This is great for showing your location or marking out where you might want to meet someone. But did you know that you could add Street View to your app like this? Or make cool apps like Santa Tracker that follows Santa around the world as he delivers presents. Let's take a look. Our docs show you how to embed a Google map in an Android activity. Then it's easy to add markers to your map. You just use the Add Marker method and specify a few options to customize the marker. For example, you can set latitude and longitude, change the color of the marker. You can also set what shows up in the info window when the user taps the marker and the info window pops up. You may even want to use photos as your marker. Maybe you want to show where the photo was taken on a map and associate it with an event, rather than just showing a strip of photos in your app. Now that you've seen markers, let's take a look at Street View. Most excitingly, you can add Street View imagery to your apps. In this demo, you can see the split screen with the Street View imagery in the top half and the Google Map in the bottom half. By long pressing the marker and dragging, Street View imagery updates and shows you the location where you drag the marker to. So how do you do this? A very similar demo is available in the demo examples in the Google Maps for Android API v2 itself, so the code is all there. Here we've split the layout into two parts. It's one fragment for the Street View panorama and one fragment for the Google Map. You then set the same initial location for the map, the marker and the panorama, and we've given our marker a custom icon which is Pegman. When you drag the marker, you listen to a drag event from the marker and use the callback to position the location of the panorama. When the panorama change event occurs, the listener will give you the precise location of the panorama, and you can feed this back to the marker to update its position completely accurately. So what else can you do with Street View? You may want to add Street View to your store locator, see an area around a hotel, or view a museum or an aquarium. Street View also provides you with seamless access to Google's indoor Street View imagery. You can set the Street View panorama to be of imagery within the aquarium, or set it outside the aquarium and have your users navigate inside if they wish. Of course, you can do this for stores as well if the store has indoor business view imagery. This would be awesome if you're a store owner and you want your customers to see what's available inside to entice them to come and visit you. Okay, moving on. How can you make your users feel more immersed?
Our world has changed so much since I was a kid that things that I want to do now weren't even possible for me to imagine.
I don't even know if I knew it was called computer science or programming.
It all sort of happened by accident.
I was always excited about technology in some way, and people.
I thought that was just really neat to be able to control the technology instead of just having it control you.
I think a lot of people wake up and they have an amazing idea. When you know how to code, you can go and actually make that a reality.
I'm the Deputy Innovation Officer. I'm a design lead, a UI designer, support engineer, software engineer, developer programs engineer,
Chief Product and Design Officer.
I'm a VP. I'm the CEO and founder, co-founder.
I am a coder.
By learning about engineering, computer science, and other technical fields, you can solve the really big problems.
We're trying to do things that could radically improve the world.
Things like transportation and health.
Making our cities better places to live and making people more connected.
A place for city kids to build and create.
I created a moon TV system to project video on the moon.
Computer vision technology.
Open source hardware company.
Measure air pollution with your mobile phone. I love helping people do the things that they love to do more easily.
I really, really, really enjoy the fact that I get energy from so many people.
I just hope that I can see the world change in my lifetime. That inspires me.
So build it around something that you like.
Find something that interests you.
What are you passionate about?
Know what's the thing that's going to keep you going.
And you can really, really have an impact on the world.
Hi, everyone. Welcome. I am Pavni Divanji. I'm a VP of Engineering at Google. And I was so stoked when Natalie asked me to introduce this session. I've been, from very early age, very fascinated with robots. A lot of my childhood conversations were dominated by R2-D2 and C3PO. At home and at school. There were two factions at school in the geek crowd, you know. There was the R2-D2 faction, and then there was the C3PO faction, and we spent endless hours debating virtues and vices of those beloved robots. So, and I have to say, nothing really has changed. A few months ago, I was sitting at my Sunday breakfast family place, and my daughter, we were eating pancakes. And my daughter blurted out very suddenly that she wished Siri was more like Jarvis. Now, I kind of know that she's an Iron Man, Tony Stark fanatic, but it still kind of took me by surprise. Normally, our conversations are not that interesting. It's normally about school and Minecraft and Pokemon, and the robots show up in the conversation. So I'm like, okay, take a deep breath. And I'm like, tell me more. And so, but before she could answer, my younger daughter, Maya, who's 8, was not going to be left out of the conversation. And she jumped in and she says, well, it's obvious why she likes Jarvis more. I'm like, why? Well, Siri just doesn't get kids. I'm like, oh, is that the reason? So I'm like mentally getting prepared to explain to them why it's such a hard problem to recognize different types of voices and stuff. But before I get a chance to actually get into the conversation, there's a sibling rivalry going on, and Ishani, who is a teenager, gets back into the conversations. Like, that's not it at all. You know, I really like Jarvis because it has a real personality and an attitude. So I'm like, okay, now we're talking about robots with a personality and an attitude, okay? So anyway, where this conversation ended was my 8-year-old is like telling me, like, I want to build a robot. And Mommy, I think I can build a better robot than Jarvis. And like parents do, I'm like letting it pass. And next day, she's like relentless, right? Few days following. So I'm like scratching my head what to do. And so finally, I ended up getting her a Lego Mindstorm kit. And here she is. She built a little robot a few months ago. And the reason I tell this story is it's a silly family story, but I like to tell it because I find fascinating that robots never cease to be an interesting topic, no matter how old you get. And I remember at a very early age going through thought exercises on how to build C3PO, and Yeah, I was in that faction. But and it was kind of hard. You have to imagine a time where I was in India. There's not that many resources available. TV had just arrived. No internet, no cloud, no Google, right? It's kind of hard to imagine bringing C3PO to life. But now the landscape has changed, right? We have fast networks. We have maps. We understand the terrain really well. We have the cloud, we have Google, right? Robots don't have to do it all alone. If they have the cloud helpline, as I like to call it, oh, I don't know how to recognize this object. Let's dial the helpline, right? I don't know how to, I don't quite understand the language. They can also ask the cloud. So indeed, it's like a really different, exciting time, and a lot has changed. I feel like robots are amongst us already. It's hard to imagine a future without them. Whether it's like cuddly toys we're talking about, or robots helping us in emergencies, or robots like helping us with the car assembly line, or driving cars for us, or navigating on Mars. They are here to stay, and they are here next to us, helping us for the future. So today, I am super excited because you're going to hear from 3 awesome Googlers who have built robots to assist a person in need, assist a community, and assist humanity at large. And I would like to invite Yoki, who's our Vice President of Technology at Nest, to kick off this very exciting session. Welcome.
Hello, everybody. I'm so happy to be here today. At Nest, for those of you who know Nest, and as well as those of you who are getting introduced today, we actually reinvent unloved products in your house, such as thermostats and smoke detector. And we actually today launched a developers program. Yay! Unplugged. So, and then and one of the things actually we do is that we build beautiful products that used to be unloved. Now people start to love. And not only beautiful to look at, but also beautiful to interact with. And the kind of things that we do is to really understand how humans learn to interact with certain devices and then have machine learning to interact together. And this synergy is where we can make the experience beautiful. So that's what we're going to talk about, except that this is where I'm going to stop talking about Nest, and I'm going to actually tell you a little bit about robotics and a little bit of a history of how I got to Nest. And really, I'm going to talk about enabling human experience. And again, this machine learning and human experience combination, really what I like to do is to enable who you want to be. So just take a thermostat as an example. How many people actually like to save energy? Almost everybody. OK, that's great. So how many people who are staying at the hotel and remember to turn off your air conditioner or heating right before you left the room today? Not enough. And that's pretty common. But don't worry. What we can do with the technology, through understanding who you are, you want to save energy, but you sometimes forget because you're human. Well, we can augment for that together. See, this is kind of the synergistic thing that I'm talking about. So you want to be an energy saver? Great. We'll enable it. Well, I actually wanted to be a tennis player. So a technology that could enable me to be a tennis player would be great. But as I grew up playing tennis and then I was competing at international level, I started to get injured all the time in college and have come to realize that maybe I'm not going to be the #1 player in the world. So at that point, I had to reinvent myself and said, well, what am I going to do next? Well, I know tennis. How about if I built a little tennis buddy for myself? It's made of robots, has legs and arms, and it has buttons in the tummy. And then if you push a certain button, it might make the robot to be really, really amazing and then a great robot to play with. Or another button that you can press, which will make it a little bit weak on the day that I'm feeling a little down and I want to beat something up. So that's the kind of things that I was imagining. Wouldn't that be great if I could build something like this? So throughout college, I started to do much more of an engineering, and I got involved, and I even went to grad school to build a humanoid robot that looks like this. This is called COG. And I joined a team to build arms and hands and to really try to approach the human-level cognition to intelligence to movement that we can mimic like humans. Well, but a couple of years later, I realized that it's really hard to do that with, at that time, the technology of artificial intelligence and machine learning. And I felt the reason is because we just don't understand the human brain and how it works well enough. So I jumped across. I studied neuroscience so that one day, I was still hoping that I can build a tennis player that could play tennis with me. But throughout this whole sort of journey of migrating to neuroscience, what I've come to learn is that there are a lot of people who have neurological disorders who could get help by all the knowledge that I've already had in machine learning, AI, and robotics. So that's when I started to think, maybe, just maybe, what I like to do is to really help other people somehow sort of reach out to those people using some things that I already know and trying to see if I can help them become who they want to be. So that's pretty much what I did. I was a professor for over a decade, really trying to invent this field called neurobotics, or you might know as a brain-computer interface, brain-machine interface. It's really about taking some of the brain signals and then extracting it, and technologically speaking, and then enhance it, and then put it back on either a limb that's paralyzed or a prosthetic limb for those people who lost their limbs. So this is a tool, as well as the future prosthetic limb that I built, spending a long time trying to understand how humans make such an amazing motion in their hand, using their hand. This is so simple for us, yet for a robot to just even do this, this is almost completely impossible even today. So why is that? Is this a mechanical secret, or is this something that our brain is sending? So really dove into the scientific deep end of trying to understand how we can enable those people who lost their movement. And through that research, actually lots of nuggets have been found. And some of the nuggets have gone into actual prosthetic device that thousands of people wear now. This is called Touch Bionics iLimb. And so those are really exciting little nuggets, but primarily, I was really thinking about people about 30 years down the line. But it didn't just have to be about wearable devices. It could be something that just sits on the ground. This is a robot, and that sits on the ground, and then somebody, this is a student from Harvard, but pretending to be somebody who had a stroke, and sitting and then interacting with the robotic device safely. As he's interacting with it, now the robot is gathering information about the person. The person wants to recover. The person who had an injury and maybe have half the body paralyzed can actually try to start to exercise. And then the robot side can understand, is this person tired? Is this person learning right now? Is this person able to get pushed a little further? And can have this synergistic activity between human learning and machine learning so that we can get just the right amount of exercise and rehabilitation to make them better. And we even tried to miniaturize it. This is somebody who's playing a virtual goggle video game as she is getting her movements exercised in a way that she was not possible before. So all of this was great. And I was a professor, and then I loved teaching. But I was getting a lot of emails on the side from people today who were injured and really needed some help. And they read about my research and said, well, is there anything that you can do? And eventually, it tickled me enough to the point that I thought, you know what? It's great to push the boundary of science, but at the same time, I would love to be able to do something for people today. So I built a foundation on the side. It's called YokiWorks. It's really about making something, technology, especially the intersection of machine learning and human learning, to enable you to become who you want to be. So we did things anywhere from, a kid who wanted to become a faster swimmer but had an amputation. Is there something that we can build? And then another project that I'm going to highlight today, just as an example, is called Project Maria. And Maria was a 7-year-old girl who came when YokiWorks and said, actually Maria's parents came to us and said, is there anything that Maria can do? She has cerebral palsy. She basically had stroke when she was about 7 months old. She lost almost all the movements from her body. She was wheelchair bound, and there was absolutely nothing on her body that really could move with her wish. And we got together, and then we watched her, how she moved, and then if there's anything we can bring out from her. As we watched, what she had was this on the wheelchair. This is called a communication board. And all she could do was to move just in a general direction of maybe 4 corners. But she had no motion that could allow her to stop at any of the squares. So all she could do was to say, yes, I'm in pain. I have to go to the bathroom. That's about it. But her parents said, and I felt the same as we were watching her, that she has something inside. She's a very, very smart person inside. And we wanted to enable this. So as parents and I were talking, and the therapist was there, Maria got bored. I mean, any 7-year-old would get bored of parents talking about something that's pretty serious. So she asked in sort of her way, and then the parents noticed that she should probably look at the iPhone pictures. So her dad gave her the phone, and as I watched in the background, she was swiping like this. I was like, wait a second. So if she was motivated enough to want to look at something, she can actually make those swiping motion even though she's unable to stop at a specific location. So we said, aha, why don't we take advantage of the fact that she can make those motions and maybe allow us to, so we should build a technology that can adapt to her motion over time and then maybe just understand how much she can be pushed to learn, and then we'll build a technology around it. So we went to, nonprofit has no money, so we went to Toys R Us, and we had found an electronic drum machine. And we said, oh, this looks really good. They have like areas that she can go to. But wait, this is pushing motion still. She can't make pushing precisely. So we also bought rubber balls, cut it in half, and then we put them instead of those little, the surface, the piece. Now, as she moved to swipe like the iPhone into different directions, she was able to knock down on different corners. And now, this is actually beautiful Maria. Just she's learning how to use this device. As you can see, the drum set with the rubber ball attached to it. Of course, we were shooting then, and she was a little shy in front of the camera. But you will see her sort of general swiping motion, the kind of things that she can do. So she's able to actually be told which one she should go for and then trying to target toward those the directions. So what I loved about this idea was not only that we were replacing those communication in a much more precise way. She just had to knock one of those over with the motion she already has. But now we started to say, you know what? If she can get good at those 4 corners, she can actually start to build a vocabulary around it. What if left top and the bottom right was letter A? What if some other combination was letter B, and so forth? And if we learned it together, she could actually learn to spell. She could learn to form essays. She could take SAT. She could go to college, and she could get her own job, and she could live on her own. And that just was so exciting to be able to do. So this is the kind of way that we wanted to mix the machine learning from the side of really understanding her capabilities and trying to adapt, even build devices to accommodate and then to make her give the human experience. Thanks. One of the things that YokiWorks has taken, of course, is something that's not just for her, but we wanted it to be for a lot more people. Devices for disabled people, of course, is not something that you can mass produce. It's sort of a good thing and a bad thing. So, we were hoping that through this work, we can even find hundreds, maybe just thousands of people who would use same technology, and then we could work with them to get, just enablement of these lives. So, just to close, I wanted to sort of really highlight this idea of machine learning and human learning intersection. And I'm really excited to keep working this intersection in both consumer product as well as for individuals. Thank you. So now I'm happy to introduce Gabriella Levine. She's on the Rapid Eval team at Google X, and she travels all over the world, and we'll hear all about that.
Thank you. I'm Gabriella Levine, as introduced, I work on the Rapid Eval team, part of Google X. What the Rapid Eval team is tasked with doing is coming up with new moonshot projects. So this means crazy, out-of-the-box technological solutions to projects that potentially could solve some of the world's largest problems that affect billions of people. What we value is to work hands-on, to build things, to dive right in, and to work with tools that we can feel. But we embrace failure, and we like to fail fast. Today, I want to tell you a little bit about the type of work that I do and what got me here on the Rapid Eval team. I've always been really passionate about working outside in nature and dealing with things that were harsh conditions. So this led me to spend a few seasons as a wildland firefighter based in Oregon. I was on a hotshot crew, which meant that we would travel all over the US to America's largest fires. So we would be in the middle of the forest, no access to roads, food, far from anything. It was super mentally challenging and physically demanding, but it was one of the most exciting jobs I ever had. But I was around lots of big machines that tried to fight the fires, and often it was efficient, but sometimes it was really not the best way to use these big machines that cost a lot of money, took a lot of manpower. So sometimes it was even just to show nearby towns that there was a lot of airspace happening, even when a fire was too big to get near. It was often really the ground crews that made a lot of difference. So it really got me thinking about automated machines and robots, and especially those that dealt with the environment. From there, I really just started prototyping and wanted to build my own robots that could go into the environment and potentially solve some natural disaster issues. So I ended up building a lot of bio-inspired robots and a lot of snake robot prototypes, which are called SNEAL. That's a story for a different day. But this led me to keep building and learn as I went, and eventually co-create a startup called Prote, dealing with a robot that could go into the environment and mitigate natural disasters. This startup led me to another radical experiment. It was called Unreasonable at Sea. I was one of 10 tech startups last year on a 4.5-month journey around the world by ship. So this was my home. I was one of about 30 social entrepreneurs on the ship, but it was a partnership with Semester at Sea. So it was all of us part of this accelerator program with business mentors and about 600 university students. It was weird, but it was really amazing. So we traveled together from San Diego down to Mexico, across the Pacific Ocean, around Asia, India, and then all around Africa up to Barcelona. Together, we were working with each other, the businesses and the students, working with the mentors, working with people at local communities in the ports, just innovating together, brainstorming, and we were deploying our robots. So the startup that I helped start and grow is called Prote. Prote is an open source, shape-shifting sailing robot meant to explore and preserve the ocean. So eventually, it's going to be unmanned, fully sustainable, as well as autonomous. But it moves like a snake through the water, and the purpose is so that it could carry long and heavy material behind it, like sensors, or payload for cleaning up the ocean, like this oil-absorbent polypropylene tail. But the biomorphic body actually moves like a snake and curves in the wind, presumably increasing efficiency during the tack. So the idea is that with this flexible body, it could increase efficiency, have lower drag, and decrease the reduction of energy as it moves through the water. But Prote is a fully open source hardware project, which means that we document the designs really to enable local communities to take a hands-on approach to whatever environmental disaster they're trying to look at with an autonomous surface vessel. So you could take out the central electronics, and right now it's just a remote control talking to an Arduino on board that changes the shape of the boat as well as the trim of the sail. But you could put a Linux computer on, or even an Android. You could put any sensor you want on the boat to measure any type of data that you want on the water, or exchange the radio for something like an Iridium satellite in order to, an antenna, to presumably have this vision of multiple boats swarming around the world anywhere, and then you could be at home controlling the boat from the comfort of your own home, much like on a video game interface. Prote is being developed to solve some of the biggest natural disasters. For example, the oil spill. It was inspired by the BP oil spill in 2010, and something like this might enable all the fishermen who ended up helping and getting skin diseases and lung diseases to be taken out of the picture so robots could end up doing that. It's also being developed to map plastic trash in the middle of the ocean by having an optical camera on the front of the boat that water streams through so it can measure the particles and the microplastic size on the surface of the water. And it's being developed to map radioactivity on the coast as well as in the water. For example, near Fukushima after the Fukushima Daiichi nuclear meltdown. So wherever we went on Unreasonable at Sea, we worked with local communities, seeing what their needs might be to have an autonomous boat. And we deployed the boat, and we really tried to understand the needs and the people, as well as how the boat would work in different types of environments. When we got to Ghana, we learned that oil had just been discovered 8 years ago. Now there were oil rigs all along the coast, as well as the fishermen would go and fish right along the oil. We wanted to see how could Prote be used to understand the relationship between the fishermen, the fish, and the oil. Now at night, the fish would gather around the oil rigs, which had bright lights, which was something that never used to happen. Instead of just going and interviewing and talking to some people, we met some friends. We head directly to the beach and got on a fishing boat. We rowed out with them and ended up fishing with them. I was really sick this day and actually throwing up over the side of the boat as I paddled, but it really didn't matter. It was amazing, and I just kept paddling as hard as I could. When we got to Hawaii, we learned that every island has its own rainbow beach, modeled with plastic trash that comes in from the ocean. We worked with some of the scientists there to see how Prote might be used to map plastic trash in the middle of the Pacific Ocean. Now we're continuing efforts with these scientists to see what Prote might be able to do all over the world. Finally, Prote is engaging with a project working with the disaster that happened in 2011, the Fukushima Daiichi nuclear meltdown after the earthquake. This is one of the biggest disasters of the century, and it's going to affect people for centuries to come. We wanted to see if Prote could help map the radioactivity off the coast of Fukushima, as well as in the water, something that I never had seen data about before. There's an organization called SafeCast, based in Tokyo, and they handed out open source Geiger counters in 2011. This allowed people to collect data all over the country, and they crowdsource mapped the entire country based on radioactivity levels. We wanted to see, could Prote do this, but for the water? And all we needed was a boat to put one of the Geiger counters on. So this gave us 9 days to build a boat between Hawaii and Japan, which was very early on in the journey. So imagine building on a boat. It's not very easy. We were on the second level deck, way below the waterline, and it was like trying to solder on Space Mountain roller coaster as it pendulums back and forth. Plus, we ended up hitting one of the worst storms that the seasoned British captain said he's ever seen. At one point, he got on the loudspeaker and he said, "Everybody, get to your rooms. Things are looking grim." So we didn't care. As I was soldering the PCBs for Geiger counters, student interns were epoxying the outside of the boats. And we kept working even as wood was flying everywhere as the boat shook, and electronics and epoxy. but we had to finish the boat by the time we got to Japan. So after countless nights of not sleeping, we finally were finishing as we pulled into port that morning. And this was a huge relief. This was one of the most beautiful sunrises I had ever seen as the seas finally calmed. So we head directly to Safecast's headquarters. We modified the Geiger counters so that we could put them in the water as well as get data from under the water. And we head off in a car with some of the Safecast team, drove through the night to Fukushima from Tokyo. In the morning, we finally arrived, and it was like a post-apocalyptic scene. It was totally destroyed, and the landscape was desolate. It was a ghost town. But we drove as close as we could to the last possible barrier that had been opened up. We were 5 miles from the nuclear plant. We put the boat in the water with the sensors, and we didn't know if we'd get any data. But it was really exciting. As we lowered the sensors down to the mineral layer of the ocean floor, we were actually able to see trace amounts of radioactivity. So this was really exciting, and Prote's continued collaboration with Safecast and aims to go back in October to continue to map radioactivity there and all over the world in the ocean. So sometimes when I've been faced with crazy problems, real-world problems, natural disasters, I've been forced to think of crazy solutions and try them out right there on the spot. Sometimes they've been total failures, but regardless, I've learned a lot from it. So just by trying, just by diving in and not being afraid to fail, that sometimes led to crazy, wild ideas that, like weird snake boats that might potentially solve some of the world's biggest challenges. So thank you. Thank you. So now I'm going to introduce somebody else who works on Google X and some crazy robots that deal with harsh environmental terrain, this time on Mars.
Hi. My name is Jamie Wado. I am a systems engineer at Google X, where we work on self-driving cars. But I want to talk to you today about not an Earth self-driving car, but a self-driving car on Mars. Let's start with me in 8th grade. And I can't believe I'm showing you this picture. This is over-permed hair that was very fashionable at the time, I promise you. I have decided in my life at this point that I'm going to be a professional musician. And then I go to a science class, and my science teacher is talking to us about Mars and space, and he's telling us about the NASA missions like Viking that happened in the 70s, where 2 Viking landers actually landed on the surface of Mars and collected data and maybe not found evidence of life. And I'm like, gosh, that's amazing. I'm doing that. Now, at the time, NASA is not going to Mars. There are no Mars missions on the books. We haven't been to Mars since the 70s. I'm not that old. And so we now need a way to get there. But that's my dream. That's what I'm doing. By the time I get to high school, I realized that to go to Mars and to go to NASA, what I really need to do is work at NASA's Jet Propulsion Laboratory, or JPL as we call it. And I need to probably be a mechanical engineer. So that's what I decide to do. I go to college in mechanical engineering, and I end up waiting tables at Perkins Family Restaurant and Bakery, which is like a Denny's maybe. And I am waiting tables, and a guy comes in, and turns out he's just retired from JPL. And he has just moved to Bozeman, Montana, where I'm working and going to school. And he says, come over to my house, and we'll talk about it. So, of course, I go to a stranger's house in the middle of nowhere, because that seems like a good idea. And I get an interview a week later. I have an internship a week after that. which is pretty amazing. And so these are the early years at JPL for me. The early years were really focused on testing and proving out the landing systems to get 2 twin rovers, Spirit and Opportunity, safely to the surface of Mars. And I ran a huge test program, and these are the guys that worked for me. You can see me. At the time, I had red hair in the back, and then all of the guys helping me pull off all of those tests. And by the early 2000s, I had been assigned to work on my first child. And this is her. Her name is Curiosity. She was slated to go to Mars in 2007. Turns out we launched in 2009. But I'm in charge of all things mobility. And so what does that mean? That means, yeah. Differential, the suspension, the wheels, everything on your car that makes your car go. The same things are on a rover that make a rover go. They're also the same things on a self-driving car. And so it all kind of ties together, right? I'm working on this. One of the things we work on is the wheel. And that was my team, me and a bunch of guys who worked for me. And so the wheel is really special. When you go to Mars, it gets down to 135 below centigrade. And it gets up to 70 centigrade. And so you can't go with traditional materials. So the wheel's actually made out of an aluminum rim. And that wall thickness of that skin of that tire is 30 thousandths thick. To put that in perspective, that's the thickness of 3 sheets of paper. And that's what makes that wheel round and hold. People continually ask me, why did you make it so thin? Especially right now with the story I'm about to tell you. And the reason is, there are 6 wheels on the vehicle, and so every ounce of material you put on there is multiplied by 6. And so we're constantly, one of our key constraints is that we have to make it lightweight. Another one is that we have to be able to climb large rocks. This is a mobile platform that wants to climb up a mountain. And another thing is that we have to really cushion the way the vehicle drives. So you can see these spoked wheels in here. It's 6 titanium flexures, kind of like a spoked bicycle wheel, but now in 3 dimensions. And that's the design we propose. And we start testing it. Now, you may know Curiosity is pretty special. It's a brand new landing system for NASA. So we actually have a jetpack that flies her close to the surface of Mars, and then she drops down from the jetpack and lands on her wheels, which sounds so easy, and in all of the videos that they show about it, it's super benign. But imagine you don't get to pick your landing spot. So there can be slopes and there can be rocks. So we actually test that. And we started out with some of our early prototypes, and this is high-speed video. I promise we're not moving that slow. And so that wheel is coming down, and we're testing to see what happens when you land on major rocks. We want to make sure we're designing a wheel that works. And so the wheel's going to come down, and it's going to hit this rock, and you'll watch the rock puncture through the skin of the tire and totally deform it. But then it almost all bounces back, and all you've got are these little cracks in the wheel. And then we tested that, and we drove it over a whole bunch of terrain to make sure that those cracks don't do what we call propagate or spread out. And we made sure it was good to go. And so we tested all of that. We also took her out into what we call the Mars Yard at JPL, where we simulate the Martian terrain. And if you know a thing or two about mobility systems for Mars, you know that you really want to design a mobility system that can climb 1 wheel diameter. But for me and my team, that wasn't sufficient, so we got extra credit, and we can climb 2 wheel diameters. We don't ever let her do that on Mars, I promise, but she can do it. This is her early prototype, just so you get a little bit of a story here. Her name is Scarecrow, and we call her Scarecrow because she doesn't have a brain. It's just a little button box we drive her with. We also tested, so those were tall rocks. Now we're testing wide rocks. And one of the things we found when we drove over wide rocks is this phenomena where the vehicle actually gets 1 wheel on one side of the rock, 1 wheel on the other side of the rock, and then starts lifting those rocks up off of the ground. And those really do damage to the wheels. And so we thought, well, gosh, what are we going to do? We're getting close to launch. This is a bad idea. We need to fix this. And so I said, I know. We'll just tell the drivers, don't drive over wide rocks. So that's what we did. And they don't drive over wide rocks. They're doing a great job. We also test her inside the clean room. And so this is me and my friend Peter. And we're making sure that when we tell the wheels to go forward, the rover goes forward. And we tell her to go backwards, she goes backwards. And when we tell her to steer, she steers the right way. So a very basic test to really build the confidence that we've built the right vehicle. And then the extreme tests we do on Scarecrow to make sure that we've done everything right. Then we launch her. This is out of Cape Canaveral, and we say goodbye. And gosh, this is really like postpartum depression for a rover mama. And so our baby's gone. Yeah, which is an exciting day. It's like you've sent her off to college, but she's never coming back. She gets to Mars, and she takes a selfie, says, "Hi, I'm here." She really does. That's her taking that. We don't fake that, I promise. And so everything looks good, right? And I go on my merry way. I go off to Google X, and all of a sudden the phone rings. And they say, "Jamie, have you seen what we're driving on?" And I look, and this is the picture I have. And the rocks are like nothing we've ever seen on Mars. We've landed on Mars at NASA quite a bit, and we're, in fact, fairly good at landing on Mars. We have never seen rocks that look like this. They're basically knife-edged pyramids, and we're driving over a lot of them. And I'm like, well, how bad is it? This is the next picture they sent me. And these are the wheels, Sol 564. So a Martian day is called a Sol. It's 45 minutes longer than an Earth day. And so we're about a year, a little more into the mission. We want to go for 2 years, and we've got holes all over it. And they're pretty significant, right? That's not really what we designed. We did design holes in the wheels. Does anybody know what the holes say? Yeah. JPL and Morse code, that's right. Leaving our fingerprints all over the surface of Mars. See, engineers have fun, right? So, yeah, we basically have the equivalent of a Martian flat tire. And I realize that I'm in the situation where there's not going to be a right answer. We are completely over-constrained. And so I say, well, the first thing I would do is I would drive backwards. And they're like, what? And I said, well, what we did is we designed Curiosity so that whatever trouble she gets into going forward, she's actually better at driving in reverse. So turn her around. She's a robot. She doesn't care. Turn the camera around, and you're good to go. Just drive backwards. You're at least doing damage to different wheels. And so they do that. They don't really like it because they don't have as good a view of the cameras, but she's doing great. Then I tell them, can we not drive on those rocks? So we start driving on sandier soils, but sanding soil isn't fun either. Curiosity is like a little kid in a sandbox. She gets in, and she can start throwing up sand all over herself. That gets on the science instruments and the cameras, and she can actually bury herself. The reason we actually put JPL in the wheels is well, we wanted to put our fingerprints on Mars, but it's also because we know how big the wheel is, and we know how far apart those asymmetric tread patterns should be in the surface. And so we can measure the distance in our cameras. We know how far apart they should be. We know how far apart they are. And that difference is how much she's slipping, so that we make sure she's not burying herself in, like Spirit did. So we do that, but it's slow going. And you can see here, it's a lot of slipping and a lot of dust being thrown up everywhere. So again, the scientists aren't super happy that we have to do this, but it's better than tearing up those wheels. Another thing we do is we take a lot more pictures. She's not taking selfies up here anymore. She's taking selfies of her shoes and making sure that we're tracking the damage that's happening to those wheels. We have 2 twins now. You see Scarecrow. There's another twin. I'm not really sure what her name is. It was VSTB for Vehicle System Test Bed. We're not always fun when we're engineers. But this is the Mars yard again. And what we do now is we've got orbiters that fly over Mars. They take high-resolution pictures of the surface of Mars. And then from that, we mock up with interns carrying rocks all around what that terrain is going to look like. We test it on Earth, and we make sure it's OK, and then we can go on Mars. You can see that's a huge amount of work, a ton of logistics, and very time-consuming. But we do it to make sure that she's doing what she's supposed to. Another thing we do, we just don't drive as much. So we sit here. This is a place called the Kimberley because apparently it looks like the Kimberley in Australia. And she's sitting there right now, actually, drilling and doing a lot of really great science. But it's a compromise. Everything is a compromise. The scientists want to be at the top of that mountain. And we're just probably not going to get there. And that's really unfortunate when you're a mobility engineer and you've designed this thing to give the scientists all of their dreams come true. But what I've realized through this is that the thing that I'm most passionate about in engineering is being on those problems, the problems that are completely over-constrained, the ones where there's not a right answer because everything is just wrong. And you get to be in the center of that, and you get to figure out how to solve those compromises. Which constraints are wrong, push back. Which ones are really important and you have to listen to. And how do you tune that answer to really optimize across no good answer? And that's the part that I just totally love because you get to be creative and you get to really put your fingerprints on the design. And so this is us leaving our fingerprints on the surface. And I encourage you, when you're in those moments, to realize that that answer is going to be uniquely yours because it's you and no one else solving it. Thank you. I have to tell you a little story. When I was getting ready to go to Google X, I Googled Google X to try to figure out what it was because it was pretty top secret. And I came across a video with our next speaker, Megan Smith. And I was blown away. And I told my husband, I'm like, I cannot wait to meet this woman. And every day I come home from work at Google X, and he's like, have you met Megan Smith yet? I'm like, no. And he calls her my work crush. I haven't told her that until right now. And so I am very excited. It is on my bucket list of things to do. I get to introduce the Megan Smith.
Hello. That was incredible. It's clear to me that hardware is definitely the new black. You know, we wanted to focus on robotics because for this Women Techmakers session, the second one that we've had in our new tradition at I/O, because there's just extraordinary things happening in robotics right now. It's really entering the mainstream in so many ways, in so many parts of our lives. And there's really extraordinary women who are part of those teams. And so we wanted to bring it, like we do with Women Techmakers. We want to talk about and show you extraordinary women. Also, the other thing about robotics is that for whatever reason, because of media bias or other things, when we think of robotics and who's making them, we do think about boys and men. And so that kind of brings me to Women Techmakers. And I just wanted to say a little bit about Women Techmakers and this idea of debugging inclusion. So this is a photo from 2012. And what we thought of at that time, Google I/O was only in the single digits of percentages of women. I think there were about 300 women in Google I/O of 2012. And so we decided that the night before we would have a gathering so people would have some friends in the hallway and not feel like such a minority. And so this is an image from then. And I just wanted to show you an image from whatever, two nights ago or last night. One of the many dinners we had, we have more than 1,000 women here at I/O, and we had 800 women out to dinner in the gathering. Very exciting. The other thing that happened in 2012 was, you know, one of the things that's true about diversity at work, none of us created any of the biases that are happening to us. We inherited the world that we live in. And so it's not that we should feel guilty about them. What we should do is, as we wake up and see them, you know, many of them are very unconscious. As we wake up and see them, we should do things about them. And so one of the things we thought in 2012 is just we really noticed just how invisible the women, the technical women are. And so one of the things we started to do with Women Techmakers is we began to make a video series. And so we had videos from Mexico, from London, from Silicon Valley, from New York, all around the world of just interviewing technical women and get them in front of you. We also started to do things around Google I/O again. So for 2013, we really worked hard to make sure we put extraordinary women onto the main stage at the keynote. This is Johanna. And then we had our first Women Techmakers session, which was called 7 Techmakers and a Microphone. And one of my favorite talks at that was Kathy Kleiman. I don't know if people were there, but she talked about a 70-year-old lost history story of the first programmers in America. 6 women who, during World War II, were Rosie the mathematician. And they were handed the wiring diagrams of the ENIAC. And they had been calculating ballistic trajectories, which was a differential equation that took a good week-long to do. And they said, could you do this? Because it'd be a great demo. And they went in and wrote the first sort routines and made those happen. That movie has now been made that Kathy introduced that was going to be there. And it's already on the film festival tour. And we're going to start to do some film festivals. We're doing one at Hopper with the Makers series, which is great. The next thing that happened was Natalie joined, and she started to really drive us to do things. And this is an idea that we had for International Women's Day. During that month of March, everybody's celebrating women, and we thought we could engage the Google developer groups, and many of the leaders are here in the room, so thank you. So this is the team in Nigeria, and in fact, this is the map that shows you over 11,000 technical women met around the world during the month of March, met each other, began to build community, began to know about resources, and began to drive visibility. And so we had, I think, 52 different countries and over 125 events. So thank you to the GDGs and folks who made this happen. It's so important. So this is this is what we saw. And now we're also starting to expand on resources. And one of the things that happened this year was many of these partners on screen, Girl Develop It, Women Who Code, and others, Hackbright Academy, helped us find a lot of the women that are here, the women who we should have been inviting. And so we worked with many of them. And then I also wanted to let you know that we've partnered with Code School. So the Women Techmakers are going to be offering 3 months of free access for women who want to come in and hone skills, intermediate and beginner level. So I guess my ask to all of you is, as Women Techmakers, now we've got a platform. So let's keep pushing. Let's all work on this visibility. Let's all work on building community. I think that what's cool and amazing about the tech industry is we're really mission-driven people. And we really believe that we can make the changes. We work on all these extraordinary products. And so even though, like all the other industries, we have these issues with bias and with trouble and with things that have gone before, we are one of the most innovative groups on the planet. And so I think we actually have the possibility to move the fastest to change all of this and to really include the people that we need in the innovation in this world. So thank you for being here and for hearing these incredible women and for all of the work that everybody does. It's definitely only going to work if we have parallel processing everywhere, parallel innovation. One of the things I love about the fact that our L team, Larry's team, and the executives at Google set a goal for us to be, could we be the best company for women and underrepresented minorities? Could we figure out how to do that? Yeah. And you see us doing this innovative work, really piloting things, trying things. Some of them will work, some won't. We released our numbers to try to get our mind around the challenges. But really, what it really did by setting that goal to me was it opened up the innovation space to all of us to wonder, what does that mean? How would I measure that? How can I actually make an impact? And so that's what we're all up to. And we hope you'll join us and set that goal for our whole industry. So thank you for being here. And I think we're going to go to Q&A, right? OK, so come on up. So all of our speakers are going to come up, and also Natalie Villalobos, who runs Women Techmakers and been driving this, and Deborah, together with Stephanie Liu, who's here, and some of the other folks. So I think we have like 5 minutes for some couple questions.
Yeah, about 5 minutes. I actually have a question to Jamie. So why do you call it a her? Thank you. I forgot to tell you that. So everybody at JPL calls our rovers by the female pronouns she and her. Some will tell you that it's after the Navy tradition where they name their ships after females because they're difficult to control. Woo! I think it's actually because they're amazing, beautiful creations, and we should celebrate that. So that's why I call her. But yeah, so we have some mics up at the front. We already have one nice gentleman here. What's your question?
Hi, it's not as much a question, but I'm from Toronto, Canada. And my wife actually runs 2 organizations called Ladies Learning Code and Kids Learning Code. I don't know if you've had a chance to take a look at them. But if you haven't, I strongly recommend you take a look. It's exactly what you guys are doing, and I'm sure they'd love to participate in whatever you do. She is back in Toronto, unfortunately. She's running some workshops and preparing for the entire summer of camp and whatnot.
Nice. So ladies, say it again.
Ladies learning code.
Ladies learning code.
And kids learning code.
And kids learning code.
Girls learning code as well, sorry.
Okay, girls learning code.
Girls code.
So we will add those into, we have the Women Techmakers site, which Natalie's got all kinds of resources. Every time you want to tell us about stuff, we'll add them there. And also last week we launched the Made with Code high school girl outreach program, which is the things you love are made with code. For whatever reason, they don't know that, and we need to tell them. So we'll add the girls-related stuff.
We saw that and thought it was really amazing. She's really excited to use some of that stuff. And thanks, yeah.
Yeah, no, thanks for
being
that.
here. Yes.
This question is for Gabriella. When she was taking the measurements for the Fukushima disaster along the coast and measuring its impact in the coastal Pacific, what was the outcome, or what is the conclusion to that? Is that something that we could, at this moment, be fearful of all the fish? Is it jeopardize our, our food chain, seafood chain?
So that was my question as well. What's going on underwater, because people are eating the seafood, people are fishing, and it's being distributed. We just got a very little amount of data, and it was with a very rough sensor. So we're trying to continue that effort, and Prote's trying to get more partners to get more data faster. At the moment, there's not all that much data about it, but there are other resources to look at that I could also talk to you about after.
We ran a session, solveforx.com session, which is one of the passion projects at Google X, and there's a guy, Lou, who's here, who's doing really interesting crowdsourced measure monitoring across China. The Alibaba team actually went home from vacation doing crowdsourced, it's called Danger Map, look for that video. But this idea that Gabriella and others are onto, and your point, which actually drew from your insight from firefighting, that sometimes the big meta stuff isn't as good as small pieces on the ground and lots of data. And so using robots in this form is what she's advocating, I think. And we need to get out as developers and innovate more of that and do more measurement so that we can exactly have the answers, not only for this Chinese project in China or projects around the world, and to engage youth into them, but also specifically for our oceans.
Well, living in the Bay Area, this is a real major concern, because already there's some areas that they have signs posted, do not fish here.
Right.
And that's kind of in the back of my mind. Thank you.
Thank you.
Thanks.
Hi, my name is Daphne LaRose, and hearing all of your stories was, as a fellow engineer, it's like really inspiring and wonderful. And as someone who has made it my own mission to bring visibility not just to women in tech, but women of color in tech, I think it's just awesome to hear about what you guys have done. One of the questions I've often had for myself, and that I hear a lot from other engineers, is how do you find your niche? So each of you kind of have like an area that you just seem to fall into, but like how did you discover that, and where did you really discover your passion?
I'll tell you how I discovered my passion. I had it at JPL. I was sending stuff to Mars, and I was super stoked about it. And when you're doing things that you're passionate about, you rock at it, and that's pretty fun. Then I left, and I went into medical for a while and hated it, lost my passion, couldn't figure out what it was. And it was actually through Natalie calling me to do this talk that I figured out what I love again, and it's solving those gnarly, crazy problems. And so thank you to Women Tech, because you made me find my passion again. So
cool. Other passion, yeah. Other passion stories, passion?
I think mine's a little similar. Some similar aspects. I found a community that I really loved to work with, and the tools that I really loved working with. From there, it came easy, but I did have a very diverse background and a wide range of things that I had done, both very technical as well as creative. So it was trying a lot of things, really never saying no, and then getting excited about the tools and the people that I worked with, and I was lucky to find that because I got very focused, but also very unfocused, answering big questions, and so a combination of all of that.
Awesome.
Yeah, I think I would say my passion has been always around having impact, and that's what made me go into technology, because I felt it was creative venue to be and also have a huge impact on the world. So that's been kind of my rudder to go where I go.
I'll make it short, but for me, it's don't think too hard. It's a big one. So to just
as engineers, that's all we do is think too hard.
Yeah, I think it's really a key. Just don't think too hard and just get into something that you love, and then that might lead you to the next passion. And you don't worry about your life story. It's totally okay to have multiple chapters. I think that's really what I think.
So you have to answer.
I'm going to, I don't know if Pavni said her name when she got up, but this is Pavni Dewanji. She's a VP of engineering at Google. I just want to make sure everyone knew that.
She's amazing.
She's amazing.
She has so many different things.
And then in terms of me finding my passion, I think that, so I actually know Pavni because we built Google Plus together. Obviously, I'm not a VP, but I really looked up to her when I was first starting on Google Plus as a community manager. And I think for me, I started noticing that I loved nourishing large groups of people. I loved hearing stories and helping people and assisting them with particular asks, but it was really about kind of solving for a larger group. And so I think for me, I started to see an opportunity of how can I actually help foster a social movement. And with everything that's going on in our industry, I think I just needed to add more fuel to that, and I wanted to dedicate my life to that.
I got to take acoustics from Professor Bose, like Bose speakers, and he used to tell us, you guys are high performers, you have to find your passion. If you find your passion, you can be unstoppable. He says it's the #1 thing you need to do. And so I think it's a really important question for people to ask themselves, and I think also for women to also be, get out and speak and talk about your passions, because you have amazing things to talk about too. For myself, I was lucky because I got to do science fair as a kid, and I work on a million different things. I'm very ADD, so they tend to have a theme. One is I really like to work on things that help people with their lives, and I like to work on things that reduce our impact on the planet. And almost everything kind of themes around that, inclusion, those kinds of themes. And I think I also tend to not be the founder. I've done that before, but I tend to have a really good eye for people who have great ideas, especially in the earliest stages, and figure out how to help them. Reid Hoffman calls it the smart generalists who work with the founders. So I tend to come up underneath people and help them. And I think that in Silicon Valley, we always focus on the founder, when really Regina Dugan, who was, I think, in this room earlier today, who ran DARPA, she said there's a new thing the basketball teams are doing, is studying hustle. So who's on the court with Michael Jordan when he's really performing? And so there's people around who can do that stuff, and I like to do that kind of work. And I think that those are very valid jobs, and they really move stuff forward, because people have extraordinary ideas. If you can amplify them, major things can happen.
And to add to that, and then actually we're going to have to end Q&A, but we'll be over here and available to answer more questions. So Megan actually taught me a really important thing, which was the term yes and. I never took improv theater classes when I was younger. And so surround yourself with people that say yes and to you, more than yes but. Yeah. Thank you so much for joining us.
Thank you. Thanks.
Hi, my name is Pong Ying, and I work on the Google Wallet team. I'm here to talk about the Wallet Objects API for native Android. I used to have a keychain full of these, different loyalty cards to take advantage of discounts and rewards. And these, I usually just end up leaving at home, unfortunately. I could have saved so much money. I don't think anyone but the most dedicated savers carry around all of their loyalty cards and offers all the time. To make it easier for everyone to carry around everything, Google provides the Wallet Objects platform. Wallet Objects is the concept of digitizing and storing all of your items in your wallet in the cloud and making them accessible from anywhere. And combined with a mobile app that has contextual information, we can make these items smart, so they appear when you need them. For example, I have a test object with the geofence of this building. Whenever I enter the geofence, my wallet object appears in Now, and it can notify me that it's available to use through an Android system-level notification. And we fine-tuned the contextual triggers so that these notifications won't trigger when, say, I'm just driving by the office. This functionality allows developers to do interesting things. Let's say you have an existing mobile user base, and you want to convert users from mobile to another physical medium. One example, it's a mobile game, and you want to convert the user to a console. In the game, you could add a geolocated wallet objects offer for a console title to incentivize user action. With the offer saved, the next time the user goes to a geolocation you've specified, whether it's Fry's, GameStop, or Best Buy, or some other retailer, Wallet will notify the user that the offer is available to use. They buy the title, and boom! Now they're playing your game in the living room in addition to on mobile. Wallet objects can help with retail as well. Instead of all the coupons and offers that you need to remember to bring when you go shopping, you should just be able to save those offers from an app or from the web and have them notify you when they're relevant. Let's say I walk past a store in the mall and my phone notifies me that I have a coupon to save $20 off a purchase. I'm going to try to take advantage of that savings and check out if there's anything in the store that interests me. Cool. So you want to integrate, right? Let's go over how to create and save an object. The wallet objects flow is simple. You define the data representing the object and add a Save to Google button that calls our function createWalletObject with the object to save. The rendering is based on a template that gets populated by the information you define. To reduce redundancy, WalletObject stores data in two forms. It's somewhat analogous to programming. The class data represents information that's common to all users, like merchant details. The object data represents information that's specific to a single user, like a specific discount or a barcode. All this information is merged, then filled into the template. We have a number of fields here and in this template, and any section without data is going to be hidden. Let's check out the code. First, we need to create the class. This code defines an offer class. We set the merchant and some offer details, some images, some subsections, and lat-long geolocations. Finally, we insert the class. Inserting the class needs to use a server-side REST API. Once you've created and inserted the class, you can create the object data in your Android app. This may look like a big wall of code, but it's your standard builder pattern defining an object. Here, I'm referencing a class I just created. I'm overriding some class fields and defining information that's specific to the user, such as barcode and messages. Once I have that, we can tie the object to a createWalletObjects call and tie that to an image button click, and we're done. So if you want to remind and incentivize actions for your users, integrate the WalletObjects API into your app today. For more information on the integration and a step-by-step tutorial, check out our developer documentation. I can't wait to see what you build. I'm Pong Ying, and thanks for watching.
Hi, I'm Jason from the Google Sign-In team. I'm going to talk with you about helping more Google users sign into your app or website. Connecting with your users is important to you. It's how you build a stronger, more meaningful, and sometimes more profitable relationship with them. But some users may not be willing to jump right into a deep, committed relationship. Asking for this level of commitment too early can turn users off and make them think of connecting to your app as cheap and unimportant. People naturally build trust in a relationship over time. That's why we're excited to tell you about incremental authorization. With incremental auth, you can let your users connect with your app, see what you're all about, then decide to deepen that relationship. When you ask a user to authorize your app to access data during sign-in, she is presented with a screen that describes the data your app is trying to access. It's up to you as the developer to put yourself in her shoes. Ask yourself, will she understand why I'm asking for a certain permission? Are there so many permissions that it seems scary to sign into my app? If she clicks through without reading or understanding exactly how a permission works, how will she feel later if she finds out she granted me this permission? All of these answers may affect the trust that your current and future users feel towards your app. If your answers point to showing fewer permissions, you need something that will simplify signing into your app. To do this, you can use incremental auth. With incremental auth, you can ask your user to give just a basic set of permissions that are easy to accept, like accessing her profile information. Profile information includes her Google user ID, full name, and profile image. With just this basic connection, you now have a way for her to connect with your app across different platforms with just a single tap or click. You can also personalize her experience by showing her profile image and name inside your app. Your app may also have great collaboration or sharing features. After using it for a while, your user may find it useful to sign in to more Google services within your app. For example, if your app allows him to create images, he may want to upload them to his Google Drive or share them on Google+. Incremental auth enables you to ask him for these permissions at exactly the right time when he has already expressed interest by interacting with a saving or sharing feature in your app. By providing the proper context for the decision, your user already knows he's ready to use more features of your app, to be more involved in your app's community, and to tell his friends to come join him in that community. Letting your user understand why you're asking for authorization before asking for it can dramatically increase sign-in conversions, leading to more users with a deeper involvement in your app. It's that simple. You can use Google Sign-In today to connect any Google user to your app or website. If you offer an option to connect with Google+, we make sure they have a Google+ account set up before your app uses Google+ features. But feel free to use any Google API, such as YouTube or Drive. Consult the documentation for the specific API to decide which permissions you need to ask for before calling the API. And remember, it may be best to ask for permissions one at a time or to ask for a few at a time. The list just needs to make sense to the user so that they can feel confident granting your app the access it needs. By using incremental auth and building a relationship with your user over time, you can build a long-term, harmonious relationship with them. I'm Jason from the Google Sign-In team, and you just learned how incremental auth can help you to grow your signed-in Google users. For more information on how to get started with incremental auth, check out these pages on our developer site and get ready to grow with Google. Thanks for watching.